Click on the subscribe button and press on the bell icon to watch my all new videos.
My dear, so in this video tutorial you are going to learn about parallel shaft. Well, let me share with you, this is a topic and it's a topic or part of torsion. Okay, so probably you have gone through many videos of torsion, or maybe you have studied about torsion. I don't know what you have studied, but in case of parallel shaft we are having something, we are something a concept, and probably you have studied till now the concept of parallel and concept of series. That is different one. Probably you have studied about in electrical technology, or maybe 12th class physics, right? So what is basically parallel shaft? So what is basically shaft? Shaft is having something which we use to bear load, right? And probably we used for in machine, we have used in buildings, we everywhere almost we used shaft. But parallel shaft, when both the shaft are parallel to each other, if the shaft are parallel to each other, is known as parallel shaft. Now one most important concept, that is, parallel shaft is also known as composite shaft. And in case of composite shaft, what happen? Its torque is different. I mean, torque for both the shaft would be different. An angle of twist, or you can say angular deformation, will be same in case of parallel shaft or composite shaft. What you can say? Now what exactly we are going to do here, because as we got here that theta 1 is equal to theta 2, I got different pen here, right? By mistakenly I got this pen, yeah. So I have to use this one to make it a little bit thick. So theta 1 is equal to theta 2. Right now it's okay now, because it is little bit thick and it is visible too. So composite shaft, what is composite shaft? Basically it is having theta 1 is equal to theta 2. Okay, now but torque is different. Torque 1 is equal to, not is equal to torque 2. What exactly 1 2 I am talking about, that could be clear for you if I will share with you the diagram of the shaft, that is composite shaft. Of course you have to see the diagram. Without seeing the diagram it's almost impossible for you to understand. Okay, suppose that this is a shaft 1 and this is a shaft 2. Okay, this is shaft 2, this is 2 and this is 1. And if we'll see its cross section, then should be like this: shaft 1 and shaft 2. Suppose that this is 1 and suppose that this is 2. Okay, so this is how you can you can understand the composite shaft. But basically what exactly we do calculation based on its cross section. That's why I am sharing with you this one. We do not do calculation based on this most of the time. Yeah, we usually take only length from here, but from diameter or radius, you can say, we used or we get from this cross section only. Okay, so for finding out the equation, that is total torque, you can say also like this: T total is equal to T1 plus T2. That means torque in shaft 1 plus torque in shaft 2. Now most important thing is that how we can able to find out torque from this. So for this we have to use torsion equation. Probably you have heard, or probably you have read, or maybe I don't know, you have remembered or not, but I have already shared with you about torsion equation probably couple of times. Okay, because we have used this equation. And of course in this chapter in torsion the use of torsion equation is several times we have to use, most of the time we have to use, because it's all about torsion. So remember that equation, and remembering that equation is mandatory for all, for you, for me, and for all to understand this subject, right? So not talking too much, let's go forward this topic. Torsion equation means T by J is equal to tau by R is equal to G theta by L. I don't know you know all these terms or not. Well, in my all videos I usually share these terms. What are these terms? Because I don't know you have watched my all videos not, and my motto is to make you understand each and everything what I usually use in my video only. So that's why I'm going to share with you each and everything in this video. And what are these elements, what are these T, okay? So what is this T and what is this tau, what is this J, I'm going to share with you. T means you know that torque. Can you guess what is the unit of torque in SI? It's Newton meter. J means polar moment of inertia. It's MOI, you can say. I will share with you what is it. Tau is shear stress. R is radius of the shaft, and G is modulus of rigidity, and theta is angle of twist or twisting deformation, angle of twist, you must say that. So this is all about, and this is all terms we have included here. But most important thing, we are not going to use this term. We're just going to use T by J is equal to G theta by L. What we have to find out here, that is torque total. T total is equal to T1 plus T2, and we got the equation, that is T by J is equal to G theta by L, right? So T is equal to G theta J by L. Because this is a composite shaft, therefore we have to find out, I have to find out torque for shaft 1 and shaft 2. So T1 is equal to G would be same. Suppose that we are considering modulus of rigidity is same, for we are considering the material is same for the composite shaft. Therefore G theta and J1 by L. Length is also same. Theta would be same because this is a composite shaft. So theta 1 is equal to theta 2 is equal to theta. Therefore the same for the second shaft, T2 is equal to G theta J2 by L. Now what exactly we wanted to find out? We wanted to find out total torque, right? So what we have to do, T total is equal to T1 plus T2. T1 is I'm sorry G theta J1 L plus G theta J2 by L. Therefore what we can get common from here, G theta by L, therefore J1 plus J2. Now for this composite shaft, J1 and J2 would be different, right? So for this shaft J1 and J2 would be different. But what is J basically? What is J? We need to understand that, right? So J is what? Polar moment of inertia. And therefore we are taking here circular section. That's why we're taking here circular cross section. That's why polar moment of inertia for 1 and for 2 would be, and of course polar moment of inertia is different than moment of inertia. So polar moment of inertia for shaft 1 is equal to pi by 32 d to the power 4, right? Now if we will include this cap D, total D, then J is equal to pi by 32 is equal to another, suppose that D1 and D2 to the power 4. After adding these two, we can find out total torque. And if we are considering this is a hollow, then theta there would be a difference of full diameter, that means the outer diameter, minus inner diameter to the power 4 in case of only polar moment of inertia. So this is how you can find out. This is how you can find out torque, total torque in case of parallel shaft. I hope you understand the whole concept behind it, and definitely this equation play a most important role to find out parallel shaft, torque for parallel shaft, and angle of twist for series shaft. I hope you understand some basic concept, some indeed inside view about this tutorial. Thanks for watching. See you soon in my next video. Bye bye. My dear, so in this video tutorial you are going to learn about all theories of failure. I hope you are going to enjoy this tutorial, and because I am going to discuss all theories of failure, that's why this tutorial would be a little bit lengthy. Okay, so what we are going to discuss today? Theories of failure. So probably, I don't know, see which level you are right now. You are beginner, or maybe you are advanced, or maybe you are just starting out. So I will start from beginning. That's why you can understand. I am going to share with you all important things here only in this video tutorial. So what are basically theories of failures? There are basically, 5 theories of failures are there. 5. So before going to share with you all theories of failure, let me share with you what is exactly theories of failure. What is failure basically? So basically, what happened, we did experiment with different types of materials, but here we are talking about only 2 types of materials, brittle and ductile materials and brittle materials. So basically, if you'll get questions, MCQ questions, then definitely you would get a question which just I am going to share with you, that what type of material, for what type of material which theories of failure is recommended. So I will share with you right now, because first of all I have to share with you what are theories of failure. So first is maximum principal stress theory. Second, maximum principal strain theory. Third is maximum shear stress theory. Fourth is maximum strain energy theory, and fifth one is maximum shear strain energy theory. Okay, so this is all 5 types of 5 types of theories of failure, right? So now, most important, what type of material is recommended for what? So for brittle material, it is just principal stress theory. For ductile material, we recommend shear stress and strain energy theory. Okay, shear strain energy theory. So these two these two theories are most recommended for these type of materials. Now, most important, one of the most important factor what I should share with you here only, all these theories having different names too. Just like for principal stress theory is known as Rankines theory. For principal strain theory is known as St. Sant Venant theory. Shear stress theory is known as GUEST, G-U-E-S-T, GUEST, and Tresca theory. Strain energy theory is known as Higgs, and another name of this Higgs theory is Beltrami. Higgs and Beltrami, right? And shear, this theory is having 3 names. One is here, one is distortion energy theory, and there are a few others name I should share with you, that is von Mises, and then Hanke theory, Hanke Hanky theory. So these are all theories of failures, right? So what till now I've shared with you two key points. What are other names of these theories of failures first, and what type of materials we used for what type of theories of failures. Two things, two key points I have shared with you till now. Now we'll go through one by one numerical point of view what we should know. So we'll first start with maximum principal stress theory. First we'll start with maximum principal stress theory. Don't get diverted from this background music of background sound of pigeon. It's really amazing for me. Okay, so I cannot stop that pigeon to make noise. So maximum principal stress theory, what type of diagram basically we follow, that is rectangular. Why I'm sharing with you this diagram, because this diagram already it's been asked. Okay, this will be like here only. Okay, that's okay, rectangular. So already this type of diagram already asked in gate, that's why I'm sharing with you. So what type of diagram we must have in principal stress theory or Rankine theory, that is known as that is a rectangular. Okay, so one of the most important thing, another thing, what type of formula we must used, what type of formula we must use in case of principal stress theory to find out sigma 1 and sigma 2. Okay, so suppose that we have given sigma x and sigma y. So what type of formula we must follow for this, we need to understand that too, right? So what is that? That is sigma 1 and sigma 2 is equal to sigma x minus sigma y by 2 plus minus, what is about plus minus I will share with you, sigma x minus sigma y by 2 whole square plus tau xy whole square. The same formula we also used for Mohr circle. I have already shared with you a lot of things about Mohr circle. I hope you have enjoyed all those tutorials. Now sigma 1, if there would be sigma 1, then we have to write sigma x minus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy whole square. And in case of sigma 2, sigma x minus sigma y by 2 minus sigma x minus sigma y by 2 whole square tau xy square. So this is how we can find out sigma 1 and sigma 2 for maximum principal stress theory or Rankine theory in case of theories of failure, right? So, and this theory is recommended for brittle material. This theory is recommended for brittle material, remember. So there are three key points we need to remember: first, second and third, and of course fourth number is here, another name of principal stress theory. So four key points to get success in these theories of failure, that is principal stress theory. Remember and enjoy, and hopefully you got question, then you have to practice, because without practice you cannot remember all things together in your mind. So if you practice, you can easily remember, right? So let's go for the another theories of failure. Second, that is known as maximum principal it's not principal, it's principal, maximum principal okay, sorry, maximum principal it's PAL only. It's a principal strain, maximum principal strain theory, right? So this theory is also known as ST Venant's theory, right? And here, just like I have shared with you, diagram we need to know what type of diagram we are following. Graphical representation you can see also. In case of Sant Venant's theory, we are having a graphical representation, that is rhombus. And what type of is this? Like this only. So this is a rhombus, right? So this is one of the key point. And so first key point is here, another name. Second key point is here, it is known as rhombus. Now principal strain theory, what type of formula we have in case of principal strain theory? Probably you have gone through, or I don't know you have gone through or not, but let me share with you what kind of formula you must know in case of principal strain theory. Now this is here sigma, it's sigma 1 by E minus sigma 2 by mu sigma 2 by E minus mu sigma 3 by E is equal to sigma, in case of tension, if you'll say elastic limit in case of tension. So what we got here, if we'll take common of sigma 1 by E minus mu by E, if we'll take common, then sigma 2, it should be sigma 2 plus sigma 3 is equal to sigma elastic in tension. So actually we got what this is, principal strain theory, we got this one for tension. Now if we'll talk about in compression, what we got, then just opposite of it, just like we'll get mu sigma 3 minus mu by E sigma 1 plus sigma 2 is equal to elastic limit in compression. So this is for principal strain theory, right? Now let's go for the another theories of failure. Okay, so yeah, so this theories of failure is known as maximum shear stress theory. So this is the third one, maximum shear stress theory. This theory is also known as Guest and Tresca, right? So in this theory, what you have to remember, that is important. So I will already share with you. First point you have to remember, just let me say it. Yeah, first point you have to remember, that is its another name is Guest and Tresca. And if you will go through the graphical representation of this theory, then it's like here only. So you just need to guess what is this theory all about. Just need to guess, right? So what is this? Hexagon. So how we can do graphical representation of the shear stress theory? That is hexagon. And you will be wonder to know the formula for this, for finding out, if we'll find out maximum shear stress, that is sigma 1 minus sigma 2 by 2. Now most important, my dear, most important, if we are considering factor of safety, then what we have to do? Suppose that this is we are getting a sigma y here. Suppose that this is sigma y, right? So if you are considering factor of safety, then what we have to do, sigma y is equal to, suppose, sigma 1 minus sigma 2. Okay, so it will become sigma y by 2. So factor safety will be taking, then sigma y by FOS by 2. FOS means factor of safety. So most of the time we have seen question, they probably ask you the graphical representation from this shear stress theory. But if you're talking about this, from this we already use how to find out maximum shear stress, and we know also how to find out sigma 1 and sigma 2, right? So this is how you can find, you can use the one of the theories of failure, that is maximum shear stress theory, right? So we'll move to towards the next maximum strain energy theory. So fourth number is maximum strain energy theory. This is the fourth theories of failure, right? Let me use another pen. That's blue one is most interesting one. Yeah, blue one is quite good. So here, so maximum strain energy theory having another name, that is Higgs, and the next one is Beltrami, right? So about these two names, so what happened, first you need to remember the theories of failure name. Okay, that is obvious, you will remember. The second one is other name of this theory. So this is known as Higgs and Beltrami theory, right? Now the representation, graphical representation, the graphical representation for this theory is ellipse. So we represent this theory, the graphical representation is ellipse, right? And most important, how we can find out that value, that means maximum strain energy, that is also important. So how we can find out the maximum strain energy? By using the formula. So what is the formula for that? I'm just going to sharing with you. That's why it will be quite easier for you to understand too, and you can use that formula in numericals. Okay, so stay tuned and keep watching. Just I'm going to share with you. I'm kidding, I'm just sharing. Here is it, strain energy per unit volume. Okay, strain energy per unit volume, right? You can see in short SC per unit volume is equal to, if you're talking about 3 dimension, we are considering sigma 1, sigma 2 and sigma 3, then what is the value of it? We need to understand it. Okay, so little bit lengthy formula is here. 1 by 2e, 2e means Young's modulus or modulus of elasticity. Sigma 1 is square, sigma 2 is square, sigma 3 is square minus 2 mu. Mu means you know that, right? So don't know? Okay, don't worry, mu is Poisson ratio. Sigma 1, don't get confused with the other friction and I mean FM, fluid mechanics, don't get confused there, right? But who knows, probably we'll talk about this is dynamic viscosity. It's not like that. Sigma 1, sigma 2, sigma 3 and sigma 3 sigma 1. So this is the formula for finding out strain energy per unit volume in case of 3D. Now if you are talking about 2D, then what would be the formula? This is for 3D, right? 1 by 2e, sigma 1 is square plus sigma 2 is square minus 2 sigma 1 and sigma 2. So by using this formula you can find out strain energy per unit volume, and hope you have enjoyed this strain energy theory or Higgs and Beltrami theory. Now the last one is remaining. I'm just going to share with you last one, but before going to share with you last one, just think about 3 things only, 4 things here. First, 1, second, 3 for 3D and 4. These 4 things are most important, but if you're preparing for MCQ level question, then coming from this it is little bit difficult because it is little bit lengthy. If you're talking about gate, then it can come in only 2 marks, but if you're talking about 1 mark question, then this one is most important, graphical representation. Already they have asked in gate. Okay, so let's go for the another theories of failure, that is maximum shear strain energy, which is most recommended for one of the recommended, because maximum shear stress theory is also, I mean that one is most recommended, but yes, you can use this and the which one I'm just going to share with you. Wait, let me share with you first. 5th number is maximum shear strain energy theory. Now we'll talk on this topic, right? So for 2 things I have already shared with you. First is, if you're talking about brittle material, then which one is most important? That is a maximum principal stress theory. And if you're talking about ductile material, then maximum shear strain energy theory and maximum stress theory is also important. So these theories play most important role, right? So are you looking for this theory or not? I hope you wanted to learn this theory, right? So then what you are waiting for? Just let me share with you. This theory having 3 names, and other 2 names are here. One is von Mises Hanke, HNKY, Hanke theory, and another name is distortion energy theory. Alright, basically I have already shared with you question which came in gate, but definitely I will try to share with you in this video tutorial only that question. That's why it will be quite good and quite easier for you to understand how you can solve question related to this theories of failure. One is they already asked in GATE from graphical, but that one is quite simpler. But I will share with you a question probably that has been related with more circle. I have already shared with you, but right now also I will share with you in this in this video tutorial only, right? So let's go for this von Mises distortion energy theory or distortion energy theory. Okay, so this is also you need to remember. Now if you are talking about graphical representation of shear strain energy theory, then here is it is an ellipse. The graphical representation of this theory is ellipse. Okay, so these are two things you need to remember from here, 1 and 2. The third one is formula, which formula just I am going to share with you in this video tutorial only. So if you're talking about this in 3D, so there are two things we have to do in 3D, and second is in 2D. So there are two formulas we can get in 2D as well as in 3D. Let me use another color pen, that's why I will not get bored, right? So here for 3D, what we can do exactly, let me share with you. For 3D we have to use three stresses, sigma 1, sigma 2 and sigma 3, right? So what we exactly finding out, maximum shear strain energy theory. The formula for this would be maximum shear strain energy theory, you can see, okay, strain energy theory, okay, set SCT. Now 1 plus mu means Poisson ratio by 6e sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, plus sigma 3 minus sigma 1 whole square. Okay, this is for 3D. Now one thing we can do here, that is modification, simplification of this part, because we know from elastic constant relation, what we know exactly I am sharing with you, E is equal to 2g1 plus mu. So we got this here, this value here, this value we got here. So what we can do exactly, 1 by 2g, we just transferring this value 2g to this side, so 1 plus mu by E. So what we can do, for this value we can write this 1 by 2g. So this equation become, what this equation exactly become, I am sharing with you, 1 by 12g sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, sigma 3 minus sigma 1 whole square. So this is for 3D. Now if we are talking about in 2D, what will happen, this is that's just what we have to do, sigma 3 is equal to 0, we need to put in this equation only. Then what will happen, we get what will happen to this equation in case of 2 dimension. So we get the answer here only, that is 1 by 12 g sigma 1 minus sigma 2 whole square plus sigma 2 square plus sigma 1 square. After simplification, what we got, 1 by 12g sigma 1 square minus 2 sigma 1 sigma 2 plus sigma 2 square, because 2 sigma would be there, therefore 2 sigma 1 and 2 sigma 2 square. So this is how so this is how you can do this. Now we can do another thing here, we can get common 2 from this here. So what will you get here after getting common, 1 by, so g would be here, yeah, 1 by 6g sigma 1 plus sigma 2 square minus sigma 1 sigma 2. So this is for 2D and this is for 3D. We can use these two formulas. So what we got here, this one is 3 and this one is 4. So we need to remember these 4 things in case of this maximum shear strain energy theory. I hope you understand the theories of failure concept. And yes, the next thing is the numerical, which has been asked in GATE. So definitely stay tuned and keep watching this video. You will learn that numerical, how to solve that numerical. Okay, so let's go for it. So I have to write that question first. So what we got, that question, in that question we got the homogeneous, and this question already asked, already I have shared with you one of my video tutorial in this YouTube channel only. So stress, maximum state of stress for a metal, I hope you can see, right, for a metal part undergoes plastic deformation, that is here, and the equation for this is 10 5 0 5 20 0 0 0 minus 10, right? Now where stress component values are in megapascal, we have to find out using von Mises Hanke yield criterion. The value of estimation estimated, it's written shear yield stress in megapascal. A is 49.41, B is 9.50, C is 16.07, and D is 28.52. So this is the question, and the most important factor is that this question has been, they have relate with Mohr circle too. Probably not Mohr circle exactly, you can say it's little bit related to that only. I mean, because they are using this concept, so we can easily get this concept from here only. So this equation play most important role. I mean, this matrix play most important role for solving this question, right? So first of all, we need to understand what are these values talking about. So basically, this is sigma s, this is sigma y, tau xy, this is tau xy, right? And this is sigma z is equal to sigma 3. We have to take this value at sigma 3. Now from that maximum principal stress theory, we can get that sigma 1 and sigma 2 is equal to sigma x sigma y by 2 plus minus root under sigma x minus sigma y by 2 square plus tau xy square. So sigma x is 10 minus 20 by 2. Okay, so sorry, sigma plus minus root under 10 minus 20 by 2 whole square plus tau xy, that means 5 square. So after solving, what we are going to get, that is important. Just let me share with you how much value exactly we are getting here. Yeah, so what exactly we are getting here, 10 plus 20 is equal to 30, 30 by 2 is equal to 15, plus minus 10 minus by 2 5, so 5 square plus 5 square, that means 15 plus minus root under 50. So that could be if sigma 1 is equal to 15 plus root under 50, and sigma 2 is equal to 15 minus root under 50. And if you're talking about root under 50, what is the value of root under 50? That is important, that is 7.07. So what we have to do, we have to add with 15 7.07, that is 22.07, that should be in megapascal. And so minus 15, if we'll do minus 15 and 15 minus answer, that is okay, so 7.92. I'm getting, just a second, 1 divided by 2, 15 minus answer, so 7.92 we getting here megapascal. So we got the values of sigma 1 and sigma 2, but we have to use this von Mises Hanke yield criterion, which I have already shared with you what is about that, and by using that formula, we can easily find out the value, I mean the value we require, that is sigma yield shear stress, right? So sigma ys, I must say that. So basically what we know, sigma ys is equal to sigma elastic limit yt, yield tension in tension, so root 3. So we have to find out first that values, right? After finding out that values, we can easily find out the answer. So let's go for that formula, and which formula we require to find out sigma yt, right? So let's go for it. So yeah, that formula is most important, right? So that formula is here. So what we have to do, that according to that formula, we have to find out sigma what we have given name sigma. Actually I have to see this. Sigma ys is equal to, we have to find out sigma yt by root 3. So for implementing this formula, we need to know what is sigma. Suppose this is sigma yt, right? What is sigma yt? Yield value we have to find out. Its formula is 1 by 2 sigma 1 1 sigma 2 2 square, that means 1 to sigma 1 1 minus sigma 3 3 square, that means that one only, plus sigma 2 2 minus sigma 3 3 square. This is for yield. Okay, so 6 sigma 1 2 square plus sigma 2 3 square plus sigma 1 3 square. Now we have to see that values and what is sigma 1 1. Basically this is sigma 1 1, this is okay, sigma 1 1, sigma 2 2 and sigma 3 3. This is sigma 1 2. So we have to put values according to this equation. Half sigma 1 1 is what? 10 minus sigma 2 2 is what we got here? 20 square, and half is there, so half we have to put this half in bracket. Okay, so sigma 1 1 minus sigma 3 3, so 1 1 is 10, so plus 10 square, sigma 2 2 minus sigma 3 3, so sigma 2 2 is here 20 plus 10 square plus 6 sigma 1 2, sigma 1 2 is 5 here. See, sigma 1 2, sigma 1 1, sigma 1 2, so it's 5 square. Sigma 2 3, 2 3, 2 1, 2 2, 2 3, 0. Sigma 1 3, sigma 1 3, sigma 1 1, sigma 1 2, sigma 1 3, 0. So after solving what we got here, just we have to see that. Okay, just I need a calculator to share with you what exactly we are getting. So 10 minus 20, 10 square, I hope you can see, plus 20 square plus 30 square is equal to 1400 plus 25 into 6, just a second, is equal to this much, by 2 is equal to this much. And if I'll do this, then how much values exactly we are getting? 27.83 megapascal. So this is the value for yt. Now we have to find out what is ys. So 27.83 by root under 3. So what is the answer? 27.83 divided by 3 1 divided by 2 is equal to 16.06. Now if you will see the question options here, that is 16.06 megapascal, right? If you see the options here, which one is this one is the right answer. C is the right answer. So this is how you can solve question related to theories of failure. And of course I am sure you understand this question. And one most important thing, this is a lengthy video. I hope you enjoy the tutorial, and thanks for watching. Thank you very much, and hopefully this video will help you a lot in examination. Thank you very much. Bye bye. Good day. This is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about comparison between solid shaft and hollow shaft, of course. So what is shaft? Probably you know, it can be a loads and all that. So we are studying about strength of material, right? So here in this video comparison will be done. Okay, probably you are thinking why I'm repeating, because I wanted to make this topic in your mind only, in your brain only. That's why you'll not even mistakenly forget. So let's go for the topic. So first of all, what is solid shaft? The shaft is completely solid, means like this. There would not be any hollow, like nothing like that. And what is hollow shaft? If the shaft is having two diameters, okay, internal diameter and external diameter, this is only having D. And most of the time we have seen this, right? Now if you're thinking like this, that comparison, what type of comparison basically I am going to do here? Basically this is a topic of, you know, if you can understand, or if you are very good in strength of material, then I am sure you are getting what type of comparison I am going to do here. Basically this is a topic of torsion. So torsion equation will be used to compare hollow shaft and solid shaft. Really simple, and if you know what is torsion, and then definitely you can understand about it. So let me ask you, what is torsion? Can you tell me? Yeah, definitely you can tell me. Even you can tell me, I cannot listen to you. But let me tell you torsion. What is torsion? Basically, there is a relation between this, and this is happening because of torque. This is happening because of torque. And it's all about torsion, right? Suppose that this is a fixed beam, and this is a this is a this is a bar, and one side is fixed, and this is known. Then what type of beam is this? Like, this is a that cantilever beam, right? So if torque is acting like this, then there definitely some twisting movement will happen, just like this twisting movement happen, and that twisting movement, because of that twisting movement happen, and that is known as torsion. Basically, it is having a equation, and based on that equation we are going to do something here with this comparison, right? So what is that equation? Let me share with you. That equation is here: T by J is equal to tau by R is equal to G theta by L. If you are not aware about all these terms I am using here, don't worry, I am going to tell you each and everything in this video only. So T means torque, and its unit in Newton meter. J means polar moment of inertia. J means polar moment of inertia. Tau means shear stress. R means radius of this shaft. G means modulus of rigidity. Theta means angle of twist. As I have already shared with you, this is all because this is all happening because of twisting, right? L is length of the shaft, you can say, because we are studying about torsion. So this is all terms, and hope right now you can understand about all terms. Now what exactly we are going to do here? We're going to use this first part, two values only, because here what exactly we'll do, we'll just compare with this one. What is this? J means polar moment of inertia. So polar moment of inertia for hollow shaft and for solid shaft, for both the shaft it is having different formula, because shaft is hollow, so definitely moment of inertia will be hollow. Will be not hollow, will be different. And for solid, definitely moment of inertia will be different. So both are having different moment of inertia, and because of that we can compare the torque or shear stress. It is up to you how you wanted to compare, right? So are you ready, my dear? I think so, you are ready. So let's go for it. So T by J is equal to tau by R. Suppose that the radius of both the shaft and shear stress of both the shaft are same. If I am assuming shaft 1, shaft 2, both having tau 1 is equal to tau 2 is equal to tau, and R1 is equal to R2 is equal to R, but both the shaft, it seems to be a little bit different. But what I am assuming here, just concentrate here only, what I am assuming, don't see here. Okay, so the torque is same and radius of both the shaft is same. Okay, now what we have different, we have to find out, we want to compare torque 1 means torque for shaft 1, and torque 2 means torque for shaft 2. We wanted to compare torque 1 by torque 2. We want to find out ratio of torque 1 by torque 2. So what we can do here, because both are same, so we can get T is equal to tau J by R, T1, and T2 is equal to what we can get. So this one should be J2 and R2, right? So what we can do, as I have already shared with you, I am going to find out ratio of T1 by T2. Okay, so T1 by T2 is equal to tau 1 J1 R1 by tau 2 J2 R2. We need to find out, but as just before this I have shared with you tau1 is equal to tau2 is equal to tau. So this one will be get cancelled, and this one will be get cancelled. Now what will remain? J1 by J2. So what we got here, T1 by T2 is equal to J1 by J2. Now we need to find out polar moment of inertia for this circular bar. These two bars are circular, so we have to find out polar moment of inertia. Now if you don't remember, I don't know you know what is polar moment of inertia or not, even what is moment of inertia for circular cross section, I don't know you know or not, but let me share with you what is basically moment of inertia. So moment of inertia, in short we write MOI. Moment of inertia for circular cross section is pi by 64 d to the power 4. But here we are talking about polar moment of inertia, so its formula is pi by 32 d to the power 4. Now this formula is only for solid shaft. Remember that, because this formula is valid for only solid shaft, so we can use only for solid shaft. So we are having one solid shaft, that is D. So let's say this one is D1 and D2 and D1. Okay, small, that's okay, no problem. And of course this D1 is equal to D2 is equal to D, because I'm taking what radius of both the shaft are same, so it could be written like this only. So what I'm talking about, this is for solid shaft. Now what would be the formula for finding out polar moment of inertia for the hollow shaft? That is interesting, right? So the simple event, don't need to get panic, it's simple. So polar moment of inertia, it would be pi by 32 d to the power 4 minus d to the power 4. Okay, now we got polar moment of inertia for hollow shaft, hollow one. We got polar moment of inertia for solid shaft. Now what we have to do, we are having equation this T1 by T2 is equal to J1 by J2, right? So let's write T1 by T2 is equal to pi by 32 into d to the power 4 by pi by 32 into d to the power 4 minus small d to the power 4. This is internal diameter, and this one is external diameter of the hollow shaft. So this one will get cancelled. Now what we got here, T1 by T2 is equal to d to the power 4 d4 and this. So what we got the result here, that ratio of both torque for both the shaft, if the shaft having same radius, same shear stress, then we got the ratio is here. Simple, isn't that? Just what you need to remember, after if someone will see this at a time, what will happen, what is this, I am not getting anything. But if you watch the video from starting, you can understand what exactly going on in this video tutorial. Alright, so I hope you got what I wanted to make you understand from this video tutorial. I hope you understand. Okay, so thanks for watching. See you soon in my next video. Bye bye. There is some mistake actually, I haven't shared, I have seen this. Okay, so actually what happened, T1 we have considered this as a hollow shaft and T2 as solid shaft. So if we'll do this T1 by T2, so this should be upper side, this should be in the lower side. So just consider this as T2 and this one T1. Just consider T1 as solid shaft and T2 as hollow shaft, then the equation would be right. Okay, so I hope you can correct this. That's why I'm adding this part of this video to in this part. Okay, I hope you understand this. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video we are going to learn about slenderness ratio as well as a numerical problem which has been asked in GATE 2011. Okay, so as the data I have right now, according to that data, that question has been asked in GATE 2011. So that is different thing. Now let me share with you what is basically slenderness ratio. So basically it is denoted by, slenderness ratio is denoted by S, and S is equal to LE by K. So probably you haven't, if you haven't watched my previous video or videos about Euler's theory for finding out critical buckling load, then probably you don't understand this. So what I'm going to share with you in this video, I'm going to share with you exactly what you need to solve the problem if you will be as in competition examination, just like GATE or any other competition examination. Okay, so as you know, there are two things right now we have, that is LE and K. So you need to know what is LE and what is K, and related formulas to these two things, these two terms, I must say that. So if you will come to know related formula as well as about these two things, then definitely you can find out find out the value of slenderness ratio which has been asked in GATE. Okay, probably it will ask in PSUs also. I cannot share with, I cannot tell that, or I haven't seen any question which has been asked, because I'm not putting concentration there right now, I mean these days at least. Okay, so what's that? LE means effective length. What is it? Effective length. So basically there are four cases for getting effective length, but I have seen most of the question use this effective length concept to confuse students. So that's why I'm sharing with you the concept of effective length. Basically we are having four cases, only four cases are there, and if you understand these four cases, then definitely you can solve or you can overcome from problem of effective length. What is it, and how you will tackle this, and how to solve problems related to it. Okay, so what are these four cases? Let me share with you. Basically, if both the end of the column is hinged, then effective length is equal to original length of the column. If both ends are fixed, then what happened? LE is equal to LY2. That means effective length is equal to original length of the column by 2. If one end is fixed and other free, then what will happen? LE is equal to 2L. That means effective length is equal to original length, double of original length of the column. And last one is, if one end is hinged and other is fixed, then L is equal to L by root 2. So these are four cases you need to understand, or I must say you need to remember to solve problem related to effective length. After knowing these cases, four cases, that means we have done with this first term LE. Now we have to understand what is K. Basically K means radius of gyration. What is K? K means radius of gyration. So we are having a formula to find out K. K is equal to root under I by A. Now probably you don't know what is A. A is area, okay, of that object, and I is moment of inertia. So moment of inertia, MOI, in short we know this as moment of inertia. So there are two things, those are most commonly asked in the examination for finding out moment of inertia. One is for rectangle and another one is for circle. For circle, moment of inertia is pi by 64 d to the power 4. D means diameter of the circle. Now for rectangle, moment of inertia is equal to 1 by 12 b d cube. B means this width and d means this from here to here. So these two formulas are most important in case of finding out moment of inertia. Whenever in the question they are interlinking with like this, they interlink like this to confuse you. See the what is slenderness ratio we are studying, and they are interlinking with this moment of inertia we studied in mechanics. So definitely they wanted to confuse you, or definitely they don't want that everybody can solve the question. They want only few can solve the question, those understand its basic concept and those can link with other things with the term. That's why there are only few those can do much better in the examination, because there are only few can interlink the formulas. So the key to do much better in the examination, you need to interlink the formula. Now it's all about what in not university examination. Now if you are preparing for university examination, then what you have to do, you need to understand its basic concept first, and then you need to put your concentration little bit on theory, because you are going to get question at least for 5 marks or maybe for 10 marks. Then for that case you need to write, you need to fill up pages with good content related to the topic, and for that you need to understand its basic concept. The same thing is here also, but you need to know how to represent things on your answer sheet much better to get good marks, because doesn't matter what knowledge you are having, but teachers is not going to, examiner is not going to see your knowledge, the examiner will see your paper. So you have to represent much better as you can on your answer sheet. That's why you can get good marks. But in case of competition examination, you need to understand the basic concept and you need to mark the right answer to get good marks in the examination. I hope you are getting me what I mean to say. Okay, so this is about what is slenderness ratio and how is it helpful. I mean, what kind of things you need to understand or you need to get to solve the numerical problems. I am sure you wanted to know that numerical problem, that's why you will understand what I taught you. These all things are just perfect to solve the numerical problem which has been asked in GATE 2011. Okay, so what are you waiting for? Would you like to see this question? I'm sure you wanted to see that question, right? So let's go for it. Yeah, this is the question which is right now in front of you. You can read the question. Okay, and this question has, as I have already shared with you, this question has been asked in GATE 2011. Okay, it's around 5 years back. Okay, so let's see the question. So what we have given in the question, a column has a rectangular cross section. So first of all, if you're beginner, I mean if you do not solve numerical problems much, then you need to follow my step. If you are intermediate or advanced level, you don't need to follow my step, because you just need to understand the formula and you can solve the problem quite easily. Don't need to have panic for that. So if you're beginner, suppose that we are having a rectangular, okay, and this one is B, that is 10, and this one is D, that is 20. So length is L is 1 meter. So in this case we have to find out what slenderness ratio. S is equal to what? S is equal to, we know that LE by K. So here L is 1, we need to find out K. We don't have given K. So that is the thing, we don't have given K, we have given L only. And because why I am taking L is equal to L, because they don't have given any condition for the column, that's why I am taking, by default I am taking L is equal to L. As simple as that. Are you getting my point? I hope you are getting. If you are missing anything or you don't understand anything, you can just comment below. I will try to help you. Alright, so what we have to do, we have to find out K, and I have already shared with you how to find out K in the previous part of this video. So what is K? Basically radius of gyration. K is equal to I by A. So first of all, what we have to do, we have to find out area B into D. So B is 10, D is 20, right? Now what we have to do, we have to find out, we have to see the unit of these two. Unit is in mm, so we have to convert it into meter. So in 10 to the power minus 6. Now I have already shared with you, this is a rectangular column, rectangular cross section, sorry, not column. So that means I have already shared with you, in case of rectangle, what happened, how to find out I, that is 1 by 12 B dq. B is 10 and D is 20 to the power cube, and 10 to the power minus 3 whole to the power 4, because there are 4 terms we have used here, right? So how I mean, let me just calculate the value, and I got the calculator here only. 10 into 20 into 10 to the power minus 12, 10 to minus 12, okay, divided by 12 into 10 into 20 into 10 to the power minus 6. Okay, now what we have to do, we have to find out its root. This one is okay. Is there anything I'm missing? No, I don't think so I'm missing anything. So okay, 20 to the power cube, and let me see, this one is missing. 10 into 20 to the power cube into, sorry, cube into 10 to the power minus 12, okay, divide by 12 into 10 into 20 into 10 to the power minus 6. So probably I'm missing something, right? So let me calculate first. Alright my dear, so after solving this problem, actually we unable to get answer. The reason is simple, we did something mistake. And what is that mistake I need to share with you, because this is most important. See what happened, we know that k is equal to I upon a, but here in case of this I, we need to consider I minimum. And for this case we can find out I, that means moment of inertia for this rectangle. We are having two axes, x axis and then y axis. So we need to first find out ixx and then iyy, and then we need to use the value which one is minimum for this case. Minimum value we'll use, and then only we are going to get the right answer. So how we can find out ixx? Simply 1 by 12, b is 10, d is 20 whole to the power cube. Now how we will find out iyy? Just b will become d and d will become b, because the general formula for finding out moment of inertia of a rectangle is 1 by 12 bd cube. So here what will happen, 10 to the power cube into 20, because here b is 20 and d is 10. This is simple, right? After calculation, what we are going to get from here, I mean we need to choose which one is minimum. So 10 to the power 20 to the cube divided by 12. So how much values we are getting? 666.6666, okay, for this xx. And the unit would be in meter, b to the power cube, okay, mm to the power 4, meter mm and mm cube, so mm to the power 4. Remember that unit play most important role. Now 1 divided by 12 into 10 to the power cube into 20, how much? 1666666. So minimum is which one? iyy. So for this case we'll consider iyy. So what will happen, we need to do like this, iyy by a. So what will be iyy? 12 into 10 to the 10 to the power cube into 20 into 10 to the power minus 12 divided by 10 into 20 into 10 to the power minus 6. This minus 6 because of mm. So mm, if we convert mm to in meter, then we have to multiply with 10 to the power minus 3. So 10 to the power minus 3 into 10 to the power minus 3, that becomes 10 to the power minus 6. The same case is here, because 4, there are 4 terms here, so that's why 10 to the power minus 12. Okay, now we need to find out k. So what is the value of k? Basically 10 to the power cube into 20 into 10 to the power minus 12 divided by 12 into 10 into 20 multiple 10 to the power minus 6. So this become like this, we need to find out its square root. So it becomes 0.00288 meter. Now if I will do multiplication, then what will happen, if I'll convert this into mm, then 2.88 mm, or we can say like this, 2.88 into 10 to the power minus 3 meter. So what is the unit of radius of gyration? We got it here only. So let me share with you how we got the value in meter or mm. Okay, so basically iyy, meter to the power 4, if it's in SI unit, a square meter square root. So this one cancel, so meter square will be remaining. So root under meter square means meter, that's why I have written here in meter. Got it? Now the value is here k, the value of k is here, and remember this I is should be taken in minimum. So we know that SE is equal to LE by K. LE is equal to L and 2.88 into the power minus 3. Okay, so what will happen, 1 divided 2.88 into 10 to the power minus 3. So the answer is 347.22 and cylinders LEY, so there would be no unit of it because length is meter, k is also is meter, meter get cancelled, so cylinders ratio is dimensionless. So the answer is B here because we got here 347. Okay, so this is all about slenderness ratio, and this question really helped me also to find out something, this minimum one. Okay, so thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial you are going to learn about spring and of course its types as well as how it is related to stiffness. Okay, because all this video is for only mechanical engineers and those that are studying about a spring. So I will talk a little bit advanced as well as basic. So basically what is spring? It is just like acting as a reservoir, you can say, because it store store energy, right, and then release slowly or rapidly. Okay, so let me give you an example. Probably you have seen lip spring. We use this spring just below of the chassis of heavy vehicle. Okay, just like truck. Okay, so why we use this lip spring in truck? If you have studied automobile engineering, then probably you have heard about lip spring. Okay, if you don't know, then you can ask any mechanic. He can explain you and show you what is exactly it, because without seeing things you cannot understand properly, and he can make you understand each and everything about it. So actually my this video is not for making you understand about lip spring that you can easily understand from anyone. This video is for helping you to to have basic knowledge as well as very good approach to solve numerical problems related to spring. Okay, so why the question is here, why we use lip spring? Okay, so basically if truck is moving on a road, and you cannot say, basically I am from India, so you cannot say when the truck will face jerk because of the road condition, and to if jerk will be too much, then probably it may damage the chassis. So that is the reason, to avoid damage to the chassis we used lip spring or coil spring, even that would be depend on vehicle to vehicle. Okay, but most of the time for heavy vehicle we used lip spring. Okay, that's why I have given you this example. Okay, probably we have seen like this. Okay, like this you have seen this, the diagram for lip spring. You have seen such type of arrangement just below of the chassis, and don't you don't to even see truck, you can see in pickup also. Okay, so that is about spring. Now if you are studying in engineering level, then you need to understand little bit in-depth concept, just like helix and helix angle. You must say, what is helix angle? Actually helix angle is denoted by alpha, and it helps us to classify spring. So basically if you're talking about the types of spring, there are two types of spring. One is open coil spring and another one is closed coil spring. Open coil spring and closed coil spring. If it is less than equal to 10 degree, if helix angle is less than equal to 10 degree, then it is known as closed coil spring. If it is greater than 10 degree, then it is known as open coil spring. Okay, now if you're talking about actually which spring is most important for you, right? So then I will say closed spring is really most important for you. Okay, so we'll go through few formulas of closed spring, but let me share with you one of the thing which is really most important, that is known as stiffness. Stiffness is most important and play most important role for finding out finding out numerical problems. If you have studied mechanical vibration, in short MV, then you need to understand about stiffness, because without one of the concept I need to share with you, that is the arrangement of spring. You can say that arrangement of spring. So there are two ways we can arrange spring. One is parallel and another one is series. Probably you have studied about parallel and series concept in plus 2 12th maybe, for conduction capacitance as well as, not conduction, capacitance as well as resistance. Well, if you have studied about most probably you haven't studied about HMT, we also have this concept parallel and series. Now if two springs are parallel, suppose that we have stiffness K1 and this is stiffness K2, right? So this is mass. So if two stiffness are parallel to each other, then what we do, equivalent stiffness is equal to K1 plus K2. Now this is for the case of parallel. Now for what will happen for series, that you need to understand, suppose that this is a fixed and 1 and 2, this is mass K1 and K2, two stiffness are here. So if I wanted to find out there is only one stiffness, that is K equivalent, then what should I do? That is important. So for finding out in the case of series, what we have to do, we have to do just like this, Ke is equal to K1 by K2. So after calculation, what we are going to get here, K1 K2 K1 plus K2. So K is equal to, we can write K1 K2 divided by K1 plus K2. So this is all about stiffness of the spring and their arrangement. Okay, now one of the most important thing I would like to share with you. So what happened, most of the time they relate spring with strain energy and sometime with torsion also. I don't know you have studied this subject in strength of material or not, but these two things they can relate with the spring. Okay, so I will share with you in my next upcoming videos how they are relating and how to solve numerical problems related to it. That's why you will not face any problem. Okay, so now most important thing right now I would like to share with you the unit of the stiffness. What is the unit of K, which is we denote for stiffness, right? Can you guess how you can find out unit for stiffness? If not, or maybe you can find out, I don't know you can find out or not, but I'm going to share with you how to find out unit of stiffness quite easily. Alright, so what are you looking for? Would you like to know how to find out the stiffness of a spring or not? I'm sure you wanted to know, right? So let's go for it. Yeah, so we are talking about the stiffness of a spring, which is denoted by K. So basically we know stiffness is equal to force by deflection, delta delta x, you can say. K is equal to F by deflection. We have a formula about it. So what will happen, force is denoted by Newton and deflection, that means some kind of distance. Let me share with you how I am sharing like this. Suppose that we are having a beam, right, and we are putting load here, W Newton, and because of this load the beam is bending like this, and this distance is known as deflection. Most of the time we denote this deflection as delta x. That's why it is in meter only. So if we are taking in SI, so the unit of stiffness is in Newton per meter. right? If you are studying mechanical vibration, then we have different formulas to find out its unit. Okay, yeah, but unit is same for all the subject, by the way. Yeah, you must remember that. So this is all about, you know, spring and all that. But if you're talking about closed spring, then we have couple of formulas. Those are really important and play most important role for the competition examination. Okay, just like, you know, if you wanted to find out spring index is equal to d by d. Okay, so spring index, what is spring index? Basically, you know, suppose that we are having a spring. There are two types of diameter we are having right now. The diameter of this spring and diameter of this coil. So this is known as d and this coil is known as small d. So this is how you can find out spring index, right? Now, other than this one, we are having another formula that is, you know, that I must say that, yeah, other than this we are having, I must say that which one formula is that is deflection of spring. Okay, so deflection here we always, you know, delta x will denote like this. Okay, sometimes you also denote as delta. Okay, so this is about as deflection of spring, right? So what we can I mean what formula we have right now to find out deflection of spring, that is 8f spring index q, 8f as q n, and then by gd. This is the formula for finding out deflection of spring. So basically, what is G? G is modulus of rigidity. That is, I hope you know what is it. Shear stress by shear strain. I think so. Yeah, shear stress, definitely shear stress by shear. So this is a shear stress by shear strain. Yeah. Now, what is D? D is coil diameter of the coil. What is N? N, you know that, number of turns. This is number of turns, you can say. Okay. And S, the spring index, is I am denoted here as S, and F is applied load, or you can say force. Okay, so this is how you know, this is all about spring and its you know, deflection. Now, if you wanted to find out stiffness of spring in another way, we are having different formula also to find out stiffness of spring. So as I have already shared with you, is deflection is equal to what? K is equal to force by deflection. Now we are having, now relate this, let me write here also. So K is equal to delta x by F, sorry, F by delta x, because Newton per meter its unit is. Now relate these two formulas. How we can find out stiffness from this formula? This is simple, right? So what we have to do, like this, because delta x is equal to gd by 8 sqn. So we can say that delta x is equal to gd 8 sqn. This is the formula for finding out delta x is equal to this. Okay, now F, or I mean this should be K is equal to like this. Okay, because we have given delta x already. So K is equal to GD 8 SQN. So this is how you can find out stiffness of a spring by comparing these two formula. Okay, so this is all about spring, spring, open coil spring, closed coil spring, and all types of spring and things we can use to find out numerical problems and understanding basic concept of spring. Alright, I hope you understand something from this video. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so today I am going to start with a new topic, that is Euler's theory and of course buckling load. And in this topic, this is a really simple topic. If you are preparing for GATE, then definitely this is there is a very good news for you. That is, after sharing with you the concept of Euler's theory, I'm going to share with you a question which has been asked in GATE previous year. That's why you will understand the basic concept of it, as well as you can easily solve the numerical problems which has been asked in gate. So basically, before going to share with you what is it, let me share with you. Actually, basically there are few assumptions. There are few assumptions we need to take before going to start the I must say formula. Going to share with the formula. So what is assumption? The material we are going to consider for this case, that material should be isotropic and homogeneous. First is isotropic and homogeneous. Okay, second assumption we are taking, that is flexural rigidity should be same. Flexural rigidity should be same for the material, right? And third assumption we are taking, stress in the structure of the material or the structure of the column or stud should be within the elastic limit. That means it should be within the elastic limit. These three most important assumptions we are taking for the case of Euler's theory, and of course we are going to start solving numerical problems in case of buckling load. So basically, in case of Euler's theory, most important concept is buckling load, which is denoted by PE, right? Buckling load is denoted by PE. PE is equal to, we are having pi square E I means moment of inertia minimum we have to take, and by LE square. P is buckling load, pi you know that 3.14 or 22/7. E is Young's modulus of elasticity, you know that I minimum is, that means moment of inertia must be minimum in this case, and LE is effective length, which is different for all kind of end condition, or must say the beam condition of the beam we are having. So I will definitely share with you, what is basically effective length. Effective length, and most important thing we usually forget for the cases. We are having few cases, just like I'm sharing with you, first case, second. So if both the end is hinged, HIGNED, hinged, then hinged, HINGED, okay, HINGED, hinged, then both the end hinged, then what will happen? LE is equal to L. If both end fixed, then LE is equal to L by 2. Means effective length is equal to original length by 2. Effective length is equal to original length when both the end hinged. And third is, if one end fixed and other free. If one end fixed and other free, then effective length is equal to 2L. If one end fixed and other free, effective length is equal to 2L. And fourth number, one end fixed and other hinged, then L is equal to L by root 2. So these four cases, and most of the time we got question from all these cases only, because these cases are little bit confusing. If you are not familiar with these cases, then probably you are going to mark the wrong answer, which has been asked in the complete examination. So first of all, what you have to do, you have to first remember this formula. Well, remembering this formula is not that much difficult, but remembering all these four cases is little bit difficult if you will not practice. You have to practice little bit to understand with all these things. Okay, so basically what you have to do, so here there are three most important things you need to remember these assumptions, because sometimes we got questions from this also, the what are assumptions we are taking in case of Euler theory, and if you are trying to find out buckling load. Like Then this formula, this is the key, because without this formula you cannot solve the question. And then these four cases. Okay, so these three things are most important in case of Euler's theory, especially if you are preparing for examination just like GATE or IAS or even any PSU or even SSC JE. Even SSC JE, if you will get question, I don't know this topic is in SSC JE or not, because I am not preparing or even I am not sharing videos related to SSC JE, but yes, in upcoming videos I will definitely try to cover this examination also, because I got a lot of requests from my viewers, so I will not forget this. But these days I am really putting my concentration on GATE as well as university examination. That's why you can do much better in these two examination at least. Okay, so this is all about Euler's theory and buckling load. Now let's move to the next question, which has been asked in GATE 1994. If I am not wrong, this question has been asked in 1994. Okay, so this is the question in front of you right now, you can read it. So what this question already this question asks, that is, for the case of a cylinder column of length L and flexural rigidity EI built at its base and free at the top, the Euler's critical buckling load. We know that what we know, buckling load P is equal to pi square EI upon LE square. So there is nothing to do with these three, because these three is fixed as we have already given. But we have to do something with this. This is because this is known as effective length. And this length is depend on the case we have given in the question. So we are having only four cases. Definitely in the question we have given that should be in among these cases only. So we don't need to have panic, you are having all things here only. Now let's go to the question and understand what kind of cases basically in this question ask. In this question asks that Euler's critical load found at its end base and free at the top. That means one end is fixed and other is free. So I have already shared with you these four cases. Let's look at this. One end fixed and other is free. Then what will happen? This is important, because in this question we have to use this case. So basically according to this case, if one end is fixed and other is free, then effective length is equal to 2L. So already given that this is cylinder column, and in this column the effective length is L. The length of the column is L. So what would be effective length? L is equal to 2L. So what would be the next step to find out the right answer for this question? That we have to put this value here and solve the question. That is pi square EI LEY 2L square pi square EI 4L square. Right, so this is the answer we got after solving the question according to according to the data given in the question. We got the answer here that Euler's critical buckling load is equal to pi square EI by 4L square. So the right answer is D for this problem. I hope you understand the question, what I am trying to make you understand. So basically this question is like this only. Well, one of the question also asked in I think before 1990. Okay, so the question asked that if the length of the column, basically they asked that if one end length of the column is the length of the column is doubled. If length of the column, length of the L is equal to 2L, then what would be the critical load? Okay, what would be the critical load if length of the column is double? So in that case what will happen? We actually know PE is equal to that pi square EI by LE square, right? If L is equal to 2L, then what will happen? Pi square EI, because we know this, and this one is fixed in the question, so the changes is here. So what will happen? Again the same here, what we did same here, 2L whole square pi square EI. So what will happen? 1/4 by into PE, the original one. So this answer would be 1/4 of the critical load that given. So basically if we will go through that question, you can understand what I am talking about right now properly. So basically in this video I wanted to make you understand Euler's theory as well as a numerical problem which has been asked in GATE 1994. I hope you understand the question, understand this concept as well as that question. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial we are going to learn about Rankines load. Well, if you are preparing for columns and studs in strength of material, then definitely you have gone through this topic, Rankines load. And other than Rankines load, we are having other loads too. First is Euler's load. Sometimes we call it a buckling load, and this is denoted by PE. And another one is crushing load. Crushing load is denoted by PC, and Rankine load is denoted by PR. So if you definitely wanted to know the relation among these three loads, then let me share with you. There is a very good relation among these three loads, and based on that relation you can definitely have a numerical problem in the competition examination. And these days I am making all videos, that's why all videos related to competition examination most of the time. Well, if you're preparing for university examination, definitely you can get numerical problems, and you can definitely solve problems through my concepts. What I believe, and there are thousands of students already solving such problems by using my concept, whatever concept I am sharing in my videos. So what is the relation? Basically, probably wanted to know that only, right? So here is the relation: PR 1 by PE by 1 by PC. Now if we solve this one, then what we will get basically PE into PC, PC plus PE 1 by PR. And if I will little bit simplify this, then I can write PE into PC, PE plus PC, PR is equal to this, right? Now what I'm going to do, that is important, that is I wanted to share with you right now only, because without knowing that you cannot solve it. You cannot simplify the problem. What I'm going to do, I'm just going to divide both the upper one as well as lower one by PE. So here PC will be remaining 1 plus PC by PE. What is PC? Crushing load. PE buckling load, okay, and PC is crushing load. Again we know that sigma C is crushing load, PC by PA. Therefore PC is equal to sigma C into A. So we can write in place of PC sigma C into A 1 plus PC by PE. Now we know that what is PC, we know what is PE. PE means buckling load. PE is equal to pi square EI minimum by LE square. Here I would like to share with you what is the meaning of minimum. That is important, because I have already solved a problems and there I face, and I have also discovered that students can do mistake at this stage. What is I minimum? I'm going to share with you right now only. So basically this is the formula of it, right? So you can further simplify or you can use it. So you can say this is the Rankine formula for it, right? So if we'll further simplify this, what we can get basically sigma C A 1 plus A S square. S means slenderness ratio. S is equal to LE by K, and K is K minimum here. That is important. What is K minimum? Because we know that K is equal to I by A. So because we are considering here moment of inertia minimum, that's why we can say that here we are considering K minimum. Okay, so now the concept remain hidden for you, that is the concept of I minimum. What is the meaning of this I minimum? Well, probably you know that moment of inertia for circular section as well as rectangular section is not same. So moment of inertia for circular section is pi by 64 d to the power 4, you know that. But in case of rectangular section, there are two types of moment of inertia we can find out. Suppose that this is B and this is D, and we wanted to find out moment of inertia for this rectangular section, then we will get two moment of inertia, in x direction and in the y direction. Are you getting my point? Okay, so probably if you have studied about this in mechanics, and sometimes we have studied that subject as engineering mechanics. Many universities put it that mechanics, or many universities put it the subject name of that subject as engineering mechanics. In that subject we have studied about moment of inertia a lot. Okay, so in case of ixx, their formula would be p d to the power cube, 1 by 12 b to the power b d to the power cube, and for iy 1 by 12 bqd. So this is all about Rankine's load, the moment of inertia we are taking in case of here that Euler's load, right? So this, now let's move to the this one. What is A and what is S? S I have already shared with you, cylinderness ratio, and A is Rankine constant. Rankine constant. So A is equal to sigma C pi square E. What is sigma C? That is crushing stress. Pi, you know that, E Young's modulus of elasticity. So this is about the Rankine constant, and this is about E. Now most important factor in case of Rankine's load, you need to remember this formula is applicable for any type of column. Doesn't matter what type of column you are getting, you can easily apply this formula to find out the numerical problems or Rankine load of that column also. Okay, now let me share with you what kind of problems basically you can get in the university exam, in the university examination as well as competition examination related to this topic. Suppose that they have given you find out Euler's load, and they have given crushing load and this Rankine load, and probably they will not give you crushing load, they will give you crushing stress and area. Okay, and now another one way to give you the question, that is PR is equal to, we know that this one sigma C into A. They probably give you that the sigma PC is equal to this much, and Rankine constant is equal to this, and there is a rectangular section, because you know S is equal to LE by K minimum. So they will give you length of that column and rectangular section to confuse you with this minimum factor, because if the minimum factor I have shared with you here, there are two things we need to know. So most of the time in this problem, in this concept, you probably going to make mistake here minimum, or maybe you will make mistake here LE, that is effective length, because there are four rules of finding out effective length I have shared in my previous videos, and here also I'm going to share with you, because I don't want to jump to the another videos to understand those concept. So that there are four, to understand these four concept or four cases, I must say these four cases are most important for this formula, for buckling load, because you need to understand these four cases to get proper value, that is effective length, concept of effective length. You know what are those concept or cases I must need to share with you. Suppose that there is a column, and in that column both end are hinged, then what will happen, length L is equal to L. So in this case, why it is happening, which case is this case is hinged, both end hinged, then only effective length is equal to length. If one is fixed and other is free, then L is equal to 2L. If both end of the column is fixed, then L is equal to L by 2. What is L? Length of the column. If one end is hinged and other is fixed, then we say L is equal to L by root 2. So these four cases are also most important. So there are only two places where, two concepts you need to understand, because the probability of making mistakes here in this formula, related to this formula, there are two places only. One is effective length, and another one is this moment of inertia for I section and Y section, because most of the time they are not most of the time you are not going to get this one, because the column must be most of the time, not 100%, I must say that 90% time you will get question of rectangular section, because examiner wanted to confuse you in the question. Alright, so basically what you have to remember for this case is this formula, because PR is equal to this is the key formula, this Rankine constant, this is Euler load formula, and again this one PC is equal to sigma C into A, and another 2 3 formulas, but these are most important, that is Ixx is equal to this and Iyy is equal to this. I hope you understand the concept what I wanted to make you understand in Rankine's load. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial you are going to learn about strain energy as well as one numerical problem which has been asked in GATE 2007, and that question was asked for 2 marks. I hope 2 marks is much more in GATE, right? So basically what is strain energy? So energy is one kind of things which is having capability to do work, and strain energy, that means which is producing because of strain. Okay, now what is denoted by strain energy? How we can denote? We denote strain energy by capital U, right? And capital U is equal to some basic formula, that is half T theta. The basic formula is this, but as the numerical problem asked in GATE 2007, you cannot solve that numerical problem by using this basic formula. That is why I wanted to make you understand its basic concept as well as the formula we needed to solve the numerical problem. Okay, so what is that formula they have used here? That is the equation of torsion. You can say that torsion equation they have used. What it said, T by J is equal to tau by R is equal to G theta by L. Now as you can see here, we can write what we can write instead of theta. If I'll remove this one, then what we can say, we can also relate with this one, but according to that formula we don't require this. Even you will, what relation I'm going to just find out by using this relation, you have probably read somewhere, because there are many books, there are many guides I have seen they are using this equation to make you remember the formula. That's why I will not face problem in the examination while solving numerical problem. Okay, so T by J is equal to G theta by L. So what would be theta? Theta is equal to TL by GJ. If I will put this value here, then what I will get, U is equal to half T TL GJ. So what will happen? T square L by 2 GJ. This is the formula for finding out strain energy. Even somewhere they have related with shear stress also. Okay, that is different thing. Okay, but here yeah, you can also relate with shear stress. How? Let me share with you. Let me take this relation. So theta is equal to tau into L R, tau into L R G. So we can find out U is equal to half T into tau into L by Rg. So 2 Rg T tau L. Okay, so this is, we can also have this relation also, we can have this relation, but this one is most popular one, T square L by 2 Gj. So by using this relation we can solve the numerical problem which has been asked in GATE 2007 for 2 marks. I'm sure you wanted to see that numerical problem and of course wanted to learn how to solve that numerical problem, right? So don't worry, I'm just going to make you understand and show you that numerical problem I have already written. Yeah, this is the numerical problem which is just right now in front of you. You can read the question also, but this question has been, as I have already shared, that this question has been asked in GATE 2007. Okay, so according to this question, what this question said, a step steel shaft shown below which is subjected to torque. So what we have given already, torque is equal to 10 Newton meter. Don't forget to get all these things, right? If the modulus of rigidity, that is denoted by G, is 80 gigapascal, Okay, the strain energy in the shaft, so we have to find out U in Newton mm, so you should have to remember this one, that you have to find out Newton mm, but the values given, this is, if we remove this G, then Pascal Newton per meter square in SI, this is also given in SI. So first we have to convert this into mm before solving the problem. That's why we'll not face the, at least numerical value, answer. But yes, we can easily do it, right? So what we have to do, 10 into 1000 Newton mm, done with first one, and the second one just I need to multiple 1000, because megapascal means Newton per mm square, and this one become Newton per mm square. So all unit has been set to solve the numerical problem. Now the main thing is that we are having two step, but we know what U is equal to T square L by 2GJ. We are having L, we are having T, G, and J. What is J basically? J is polar moment of inertia. What is polar moment of inertia? If you'll see it like this, this is, this shaft they have shared with us, and we have to use this formula, pi by 32 j to j pi by d to the power 4. This is the formula for finding out polar moment of inertia. For this is circular cross section. In cylindrical, they are taking cylindrical. That's why you will get like this only, circular. Because of the circular, we are using this formula. You should not forget this one, right? Now, because we are having two step here, now what common things we are getting here? G is common, L is common because both the length are same, T is common. So what we can do, strain energy is equal to T square L 2GJ1 T square L 2GJ2. Now what we can get common here, T square L 2G 1 by J1 and 1 by J2, right? Now what is J1 and what is J2 we need to understand, but before going to do that, we can do like here, 10 L is 100, 280 into 1000. Now J1 is pi by 32, so this will become upside, into D. D is how much we have given, 50 to the power 4. Again 32 pi into D is 25 to the power 4. So this, the unit of this problem will come out in Newton per Newton mm, which has been as given in the numerical problem. Okay, so how we can find out its value, that is important. Let me share with you how we can find out. Suppose that this is 10 into 1000 10 into 1000 square into 100 divided 2 into 80 into 1000. What we got here, 62500, right? Now we'll do this one, 30 divided 5 multiple 50 to the power 4, okay, plus 32 divided pi into 25 to the power 4, and I have to use another bracket here. So this become this multiple 62500. Yeah, its answer is how much we are getting here, 1.7316 Newton mm. Okay, so this is here C. The right answer is C. So let me just review again what we have used here. we have seen the question, we have find out what we got values here, we got the formula which has been we have derived here. I mean use the torsion equation and strain energy, basic formula for strain energy. And what happened after using these two, we have been able to find out the main key concept, the key formula. And after getting key formula, we have seen that we have given two step and two different size of shaft. So we have to use two formulas, and both, because both for both the cases strain energy would be different because the formula is different. Okay, so if both the step given same, same size, the difference, what is the difference? Main difference is here 25. If it has been given 50, then we can do one thing, we can just find out for 1 and multiple with 2. We could do that, but in this question we have given different. That's why what we did, we have followed this step to find out the answer. I hope you understand its basic concept as well as how to find out numerical problems related to strain energy. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial we are going to learn about thin cylinder as well as its basic concept, and of course the numerical problem which has been asked in GATE. That's why you will have basic approach as well as approach to solve numerical problem. One other thing I would like to share with you, if you are preparing for GATE or maybe university examination, then thin cylinder is one of the most important topic to get question. And this is a really simple topic, and you can easily solve the question if you'll give 1 to 2 hours to build the approach to solve the numerical problem, as well as to have something, to remember the formulas. Okay, so basically there are three things. I have divided these things into three part. So one is stress, another is strain. Yeah, not three parts, it's two parts only. So there are basically two stress we find out. One is hoop stress and another one is longitudinal stress. But in case of strain, there are three things. One is hoop strain, longitudinal strain, and last one, volumetric strain. The question which has been asked in GATE, that question was asked from hoop stress. Okay, so definitely we need to learn it. So let me share with you formulas. So for finding out hoop stress, we need to, what is the formula for it? PD by 2T. Longitudinal stress, PD by 4T. Hoop strain, PD by 2TE. Sorry, it's D. And PD by 4TE. And volumetric strain is denoted by like this, PD by 4TE 5 minus 4 nu, and this nu is known as Poisson ratio. It is, what is Poisson ratio? Lateral strain by longitudinal strain. Okay, so this is Poisson ratio and all that, right? So these five formulas play most important role for finding out answer. So PD 40 is for hoop strain 2 minus mu, and for longitudinal 1 minus 2 mu. Yeah, I was missing this. So these four things, the five things, not four. These five formulas play most important role in case of thin cylinder, right? So most important thing, how to remember all these formulas. There is only one thing to remember these formulas, that is practice. Practice a lot, you can definitely remember these formulas, and do revision with time. If you will not do revision, you will definitely forget these formulas. This is not yours problem only, this is a universal problem, because there are a lot of formulas we need to remember. So to remember a lot of formulas, we have to work little bit extra, and that extra work is practice and do revision number of times. That's why you will have all these formulas in your brain all the time. right? That's why you can do much better in the examination. Okay, so I hope you understand it's all formulas and basic concept. Now one other thing which probably I am missing, that is thin cylinder. So there are two types of basically cylinder we have studied. One is thin and another was the thick. Thin and thick cylinder. Now when the cylinder is known as thin and when the cylinder is known as thick, that is important. So if thickness of the cylinder is less than diameter of the cylinder of its 10 times of diameter to its 15th time, it is less than t, then this is known as thin. For thick, it is just opposite. If thickness of the cylinder is greater than diameter of its 10 times to 15 times, then it is known as thick cylinder. So this is about thin cylinder and thick cylinder. How you can identify the cylinder. Is it thick or is it thin? So this is all about it. Now I hope you wanted to learn that numerical problem, right? So these formulas you need to remember. Now let's go for the numerical problem. That's why you will understand and definitely you have something after this video, right? So let's have. So what we have given, a thin cylinder of inner radius 500 mm and thickness of 10 mm is subjected to an internal pressure of 5 megapascal. The average circumferential hoop stress in megapascal is. So what we have to find out, that is hoop stress. Actually, one of the guy who has been preparing for GATE for a little long time, he has qualified couple of times. Okay, so I have asked him, what is your approach to attempt the numerical problem? Probably I have shared this thing in maybe 1 or 2 videos. Okay, but I don't know which video I have shared, but yes, I have already shared these things, but I am sharing again because it is worthful. If you are getting question like this, I mean the question is totally formula based, then just see what you need to find out. So here what we have to find out, hoop stress. Okay, now then write down the formula to find out hoop stress, that is PDY, and it is already stated this is a thin cylinder, so we don't need to identify that this is a thin cylinder or thick cylinder, right? So PDY, what would be hoop stress? PDY 2T. Okay, now what we require to find out hoop stress for this numerical problem, that is D and P and T. What is P? Pressure. We have already given internal pressure. P is equal to how much? 5 megapascal. So 5 megapascal, its unit is megapascal. Okay, so just write 5 only, don't need to do anything because it is already asking megapascal, right? So we got P. Now D is equal to how much we have given, radius is 500 mm. So most of the time what we do, we do mistake here, we don't change it, just use it in hurry. So don't be in hurry, just read what we have given. So in this question what we have given, inner radius is equal to 500 mm, that means diameter is equal to 1000 mm. Simple. Now what we have given, another thickness, T is equal to 10 mm. So what we require to find out hoop stress for this problem is 3 things we got from the question. Now you judge which one is better, write first and write the formula, or first write formula then find out what you require to solve the numerical problem. Which one is better? Just think of yourself, you can easily understand. So after looking at few problems and solving few problems, I decided, and I did analysis that first write the formula if the numerical problem is totally formula based, then write what you have given. That is much better, right? So 5 into 1000, 2 into 2 multiple 10. This is, we got it. Now let's solve this. 500 into 1000 Yeah, 500 into 1000 into 2 multiple 10. What we got? 250. So the answer is 250, and that should be in megapascal because we haven't changed its unit. Okay. Okay, let me share with you how the unit is working. So this is in megapascal, this is in mm, and again mm. So mm get cancelled and this become megapascal. So this is about finding out Hovis test. Well, if you are getting question like this in gate, then it's just like, you know, give a gift for you. You have must write that a gift for you, because it's totally formula based and really quite easy to solve this question. Well, most of the question you are not going to get like this, but yes, those have faced this examination 2011, they got this question to solve the numerical problem, and they were, I think, lucky to get such question. Okay, so what we got here, we got few formulas only. So don't forget to solve numerical problem if you are getting from thin cylinder. So what you have to do, we have to just remember all these formulas. You need to see the numerical problem and just solve it. I hope you understand thin cylinder concept and you will not face any problem to solve the numerical problem. Okay, I hope you got something new from this video also. Thanks for watching. See you soon in my next video. Bye bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about thermal stress and strain. Well, in this tutorial, yes, in this tutorial only I am going to share with you two questions those has been asked in GATE previous year. That's why we'll have the basic concept as well as approach to solve numerical problems. Well, this is one of the simple topic, and this is a little bit difference. There is little bit difference than simple stress and strain. So that's why this is a new topic, and this in this topic I'm going to make you understand about thermal stress. Just like the same, stress is denoted by sigma, and you can see this is thermal stress. Okay, so sigma is what is basically stress. You know that stress is equal to force by area. Okay, so we know that force per unit area, but here we are not going to use this concept, at least in thermal stress. So here what we are going to use the concept, that is Young's modulus, that is the relation between stress and strain. So stress is directly proportional to, we know that, strain, and we know that sigma is equal to capital E and E. This E is known as Young's modulus. Alright, so this is about the stress and strain relation, and Young's modulus also we have involved. Doesn't matter we are studying about thermal stress or normal stress, or maybe thermal strain or normal strain. So basically in case of thermal stress and strain, what we basically, you know, what we I must say what we include, that is temperature. Unit we include we use temperature. Basically we include heat. Okay, so I hope you got it what I'm talking right now. Okay, now here the same relation we used in case of normal stress and strain, but what is the extra in case of thermal stress? Basically in case of stress there is nothing to do with extra, but in case of strain there is something to do, because if the temperature will increase, the probability of increasing the body length would be more, right, because it is dependent on that. Okay, so that is different matter, but over here what I'm talking about, E, the formula for E is little bit different than the normal strain one. So here what we know, that E is equal to L alpha T by L is equal to alpha T. T is temperature, or most of the time, you know, we denote as delta T, because here what we are considering, that is change in temperature. That's why we always write delta T. Okay, and alpha is what is alpha? That is coefficient of thermal expansion. Coefficient of thermal expansion. Got it? So this is the thing. So the ultimate thermal stress formula would be E alpha delta T. This is the, you can say that this is the universal formula of thermal stress, and strain is here. So in this short video you have learned what is thermal stress and what is thermal strain, right? So the next step I would like to share with you, I mean the coefficient of thermal expansion, its unit, that is in degree centigrade, per degree centigrade. Okay, first. Second, which material is having maximum coefficient of thermal expansion? Okay, then let me share with you. Aluminium is having more than steel. Okay, that's why you will have basic approach. First, aluminium is having more coefficient of thermal expansion than copper. I hope you got the concept, right? So the by using these relation, you can relate and you can understand the relation, I mean the what is coefficient of expansion and relation among other materials, and which material is having maximum coefficient of thermal expansion. Okay, so basically if you are preparing for gate examination, then you will, most of the time I have seen question they have asked from this only, these formulas and this concept only. But other than this, there is a concept which they have asked in 1995. I have also put it that question, that's why I can share with you. Okay, I'm sure you are looking for those questions. Those questions I'm just going to share with you here in this video tutorial only. Okay, so let's go for it. Yeah, right now you can see I have two questions. One is on the upper part, and I don't, just leave the second part one. This one must leave, just stay with this one. Okay, so in this question what we have given, just see that a free bar of length L is uniformly heated from 0 degree centigrade to a temperature T degree centigrade. Alpha is coefficient of linear expansion. Okay, and E is the modulus of elasticity. The stress in the bar is, so what we have to find out, stress in the bar. So this is a little tricky question, let me share with you. Most of the time what we do, we'll just mark this as an answer, but this is not a right answer, this is a wrong answer. Okay, so what will confuse, with these three answers only, because this one out of range only. Okay, so this is a tricky question. So what happen in case of free bar, if there is if there is a free bar, and free bar of length any, and any length you can say that, and free to expand you can say, then what will happen in that case, there would be no thermal stress generated on the bar. Okay, because of change in temperature you can say that, because the temperature is changing here. Okay, so the answer would be what? The answer would be C for this question. I hope you got it. Okay, so remember, when a bar is free to expand, and because of change in temperature, there will not be any thermal stress generated in the bar. So this is about it, and it's a concept. It's a concept. You must remember this concept. If you probably you can get such type of question in SSCJ, or sometimes maybe IES objective type. I don't know, maybe they will ask or don't, that is depend on them only. I cannot say they will ask or not, but that is a very good concept, I must say that. Okay, now another question. This question asked in GATE 2007 for 1 mark. This is a very good question. I mean, this is a very good and of course a simple question, because what concept I have shared with you previously, by using those concepts and those things only, you can solve this question. And here this is not a tricky question, I must say that this is just a formula based question, and you can simply solve the question. Okay, so let's go for it. A steel rod of length L and diameter D, fixed at both ends. Okay, no problem, there is no issue of fixing and all that, is uniformly heated from to a temperature rise of delta T. So change in temperature is delta T. Young's modulus elasticity is E, and coefficient of linear expansion is alpha. Why it is linear expansion? Because the rod is expanding linearly, that's why it is known as linear expansion. Okay, and thermal stress in the rod is, so here you cannot say this is 0, because there is nothing written in the question that the bar is free or rod is free to expand. So this is the wrong answer for this. So we have to choose answer among these. Now if they said thermal stress, that means there should be E should be there, right? Because Young's modulus should be there, because there is a relation between stress and strain, and Young's modulus should be there. So this is again the wrong answer. So we have to choose from these two only, but we cannot choose just like that. We have to choose by using the formula, by using the concept which we have right now. Well, let me show you what I have shared with you till now. I have shared with you what is the formula of thermal stress is equal to E alpha T, and E alpha delta T, and how we have obtained this formula I have also shared with you. So I'm pretty sure you are putting your interest and concentration to get the answer. If you are thinking about E alpha delta T, then that is the right answer, because they haven't give anything else other than this. So the right answer is E alpha T. Let me share with you one of the simple trick. Okay, so that's why you can choose the right answer without even thinking about this, from this only most of the time. But that is a trick, that is not a concept. Concept is totally different, trick is totally different. Trick we learn, but concept we build. Okay, so why this should not be answer? Because L is here. You know that strain is change in length by original length, so that cannot be multiple with here, but because already length is given here, so that this should be there should be like this, alpha delta T should be there, not L should not be there. That's why the right answer is E alpha delta T. I hope you understand the concept of thermal stress and strain. And okay, would you like to go through quick revision? Okay, let me share with you thermal stress and strain. So what you have to do, you need to remember that thermal stress is equal to E alpha delta T, and its thermal coefficient of linear expansion or thermal expansion, these relations as well as its unit, and of course what is thermal strain. E is equal to alpha T. I hope you understand something new concept as well as approach to solve numerical problems. Those already asked in GATE. One question has been asked in 1995 and another one is in 2007. Okay, so thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial I am going to share with you about torsion of shaft. Well, probably you know about this topic, that's why you have landed on this page. If you don't know, then let me share with you. It's kind of it's kind of twist. Because of twisting movement, there is torsion of shaft taking place. Suppose that there is a shaft, and if I'm giving a torque T, then because of this torque there will be some twisting movement, and because of this twisting movement, the torsion will, just like if this shaft is moving like this, if I will just move both of my hands opposite to each other, then what will happen? There is twisting moment taking place, and that is known as torsion. If I will say this is a pen and this pen, and then I say this is the torsion of shaft, right? Torsion of the pen. So this is just like a shaft, this pen is. So this is actually called torsion, right? And we are doing such work on shaft, that's why we are studying about torsion of shaft. So basically in strength of material, this is one of the important topic. I need to say this. Okay, so basically in this video tutorial I'm going to share with you 3 numerical problems. Those has been asked in GATE previous year papers, as well as I'm going to share with you its basic concept, the equation, the torsion equation, which is really important for solving numerical problems, because I have gone through couple of problems, more than 20 problems in this topic, in this particular topic, and almost 19 problems are related to the equation which is known as torsion equation. So if you understand that equation, then probability of solving problems related to this topic will become quite easier for you. So what is the basic task is, you need to understand, and need to understand how you can use those equations, the equation right way in the numerical problem to solve the numerical problem and mark the right answer in the competition examination. So this is it here. T by J tau by R G theta by L. This is known as torsion equation. Probably you know, or probably you have studied about this topic. That's why you know. That's why I'm there. That's why probably you have studied. That's why you have landed on this page. So so basically, what is basically T? What is basically J? What is basically tau? What is R and all? So basically, I'm going to share with you about it here only. So T is torque. Okay, so T is, what is T? T is torque, and unit of torque is, if I will talk in SI, then Newton meter. Next, J is known as polar moment of inertia. Moment of inertia, we sometimes say MOI in short. This unit of this is meter to the power 4 if we are considering SI unit. Okay, so next, tau. Tau means, again, this tau is little bit different, probably you know about it. This is shear stress, and its unit is in Pascal or Newton per meter square. Alright, next, okay, next let me share with you R. R is radius of the shaft. You can say this is R, distance from the radius of the shaft. Basically we know this R as radius of the shaft. If we are considering SI, then again in meter. J is modulus of rigidity. This is known as shear stress divided by shear strain, and its unit, because strain is dimensionless, so this would be the same as the shear stress, so Pascal or Newton per meter square. Okay, theta is angle, and I can say that the angle in which we are twisting. Okay, and L is length of the shaft. Length of the shaft. Length of the shaft would be in meter, and angle would be in degree. So this is how you can get, or you can understand the torsion of equation for torsion of shaft. Okay, so this is about torsion of shaft, and the relation we have put it here. From this relation only we can solve almost all numerical problems. How? Maybe you wanted to know that, right? So I should go for all those questions. Those questions I promise you in the beginning of the video that I will share with you. Okay, so are you ready? If you are not ready, then drink little bit water and let's go for solving questions, because probably it will take little bit time. Okay, so here is it. But most important factor, you need to remember all the things I have shared just on the first page or first word of this video. Okay, now what we have, this question has been asked in GATE 2016, and according to this question, what this question said, for a circular shaft of diameter d subjected to torque T, the maximum value of the shear stress is. So we have to find out maximum value of the shear stress. Okay, so what we have given, that the shaft, circular shaft, okay, and diameter shaft is d and torque is subjected to torque, so T. Maximum value of shear stress, we have to find out tau. Okay, so what we have given, T and D, nothing else. We did not have given, even the question did not have even the value of T and D. We have to find out tau. So what we know, the relation, that is T by J is equal to tau by R is equal to G theta by L. We don't have any concern with these because they did not give anything or did not tell anything about these three values. So we have been told T and R, radius and diameter, we can relate directly. Okay, because this is a circular shaft, so R is equal to how much? dy2, we can say that, right? So let's go for these four things only. After relating these four things, we have to find out this shear stress, maximum shear stress. Okay, so we can write from this equation only, maximum shear stress is equal to T into R by J. As I have already shared with you, J means polar moment of inertia, and for circular body, suppose that this is a circle and its diameter is d, so polar moment of inertia would be pi by 32 d to the power 4. This is the formula for polar moment of inertia. It's it's just that sorry, d to the power 4. Okay, so it's just that just we have multiple with the 2 with the moment of inertia, because in case of moment of inertia, pi by 64 into d to the power 4 for circular body, right? So what we got here, T R means d by 2 pi into 32 into d to the power 4. So this will cancel 16, and so what we got here, and this will cancel, so 16t by pi dq. There is no rocket science required to solve this problem. So the answer for this question is what we got here, C. I hope you got what I have shown just now. Okay, if you did not, then I should share with you one thing. Just go through that equation, you will understand. And if you are studying first time this equation, then probability of not understanding properly is little bit, but of course what I am sharing with you, it's really simple. Okay, so what we got here, tau max is equal to 16t by pi dq. We got it here. Now another question they have been asked in 2004. Okay, so this question is totally depend on this this formula, because you can see as the question said, right now the question is in front of you, my dear. You can easily read the question. This question said a solid circular shaft of 60 mm diameter transmit torque of 1600 Newton meter. The value of maximum shear stress developed. So again, what the question said, this is solid circular shaft, its diameter is 60 mm, torque is 1600 Newton meter. So where you are going to make mistake, I am telling you, you are going to make mistake in this unit. So first of all, we have to change it into in SI. 60 into 10 to the power minus 3 meter. We got torque, diameter is equal to 60 into 10 to the power minus 3 torque got. And as you can see here, the formula for finding out maximum shear stress, tau max is equal to what, 16 into t 1600 by pi dq, 60 into 10 to the power minus 3 cube. Okay, so what we required right now, can you guess what we required basically? I think we required right now a calculator. So where is the calculator? I don't know, I have to find out. So just a second. Luckily I got calculator so soon. Okay, so here 16 into 1600 divided by pi into 60 into 10 to the power minus 3 a whole cube. And what we got here, say use values. So what we got here, 3772, okay, so megapascal. So divide by 10 to the power 6. Let me do this. So what the answer is given in megapascal, that's why I have divided by 10 to the power 6 to get the answer in megapascal. So answer is here 37.72 megapascal. Okay, 5 6 you can take. Okay, but already we got the answer, that is 37.72 megapascal. So this question is really simple, isn't it? And totally I have shared with you that all the questions I have gone through, that is totally depend on this equation. So remembering the equation is not a big issue, but implementation of the equation in the right way is really required a little bit patience as well as concept and of course practice. If you practice few questions related to this topic, then things become quite easier for you. Okay, so would you like to see that other question which I have already shared with you? That I am going to share with you 3 questions. Yeah, the question is here, and I hope right now you can read the question, because and this question has been asked in GATE 2011. Okay, about 5 years back. Interesting, right? Okay, so let's go for the question. What this question said: a torque T is applied at the free end of a step rod of circular cross section as shown below. So we have given the question. What we have to find out: we have shear modulus of the material G, that is modulus of rigidity, and the expression for D to produce an angular twist theta at the free end. So what we have to find out: D. D we have to find out, and the equation of torsion is T by J is equal to tau by R is equal to G theta by L. Okay, now we have given torque. Okay, so that means we have to consider this. We have to relate with theta. That means we have to consider this. So this part will be considered, and this one will be cancelled. That means we don't need to use that part. So what we got till now here: T by J G theta by L. Okay, so if I'll compare this, I can say like this: theta is equal to TL by Gj, isn't it? We can write quite easily, just cross multiplication I did. Now definitely theta for, because this is in series, where there are two types, there are two ways to finding out this twisting moment and torque, comparing torque and twisting moment. So this is in series, therefore we have to add thetas. Angular twisting will be different for both the step. That's why what will happen, suppose that this is 1 and this is 2, we have to find out both, then we have to multiply, we have to add for the first step 1 and for the second step 1. So what do you think? Should we find out one by one, or we'll do both together? Both together would be much better, because you are not a kid, man. You are studying, probably graduation. So theta is equal to T. Okay, so T is constant. We don't need to take care about T. Okay, T and L is different. This is L and this is L by 2, so L is difference, and G is constant. Okay, because we have given, so L1 by J1 plus L2 by J2. Why I have taken J1 and J2? Because diameter for both the step are there, but both are different. That's why I have taken J1 and J2. What is J? I have already shared with you probably in the previous question, that is polar moment of inertia. And for circular cross section, because in this question what we have given, this is a circular cross section, therefore polar moment of inertia would be pi by 60, not 64, pi by 32 d to the power 4. Just right now I am going to share with you. Okay, so T by J would be common. L1 is equal to, L1 is, for suppose that this is 1, so L1 is equal to L. J1 is equal to pi 32 multiple into D. D means 2D to the power 4. Don't make any mistake at this stage, because if you have gone through till now, that means you did something awesome. You have just solved the problem. Right now you just need to be calm and solve the problem till the end to get the right answer, and that's why you can mark the right answer and you can get marks for this question. Now what we got? L2 is equal to L by 2. Okay, again J2 pi d to the power 4, because it's D. Okay, it's D, because we have given D, so it's d to the power 4. Okay, into 32. Okay, so what we got till now here: T by G L into 32 pi d to the power 4 16 plus L into 16, because 2 16s are 32, pi into d to the power 4. So what we can get common from here: T into L G pi d to the power 4 32 by 16 and it's okay, it's 16. 32 by 16 plus okay 16, right? So what we got here, t into L g pi d to the power 4 2 plus 16 is equal to what got here, t into L g pi d to the power 4 into 18. Okay, so what we got till now, theta is equal to this. Believe me my dear, this is a step and where exactly student going to make mistake, I know that, but this is not the right answer, because in the question what we have asked, expression for d, we have to find out what is d, we don't need to find out what is theta. So first of all what we have to do, we have to do little cross multiplication to get the right answer. So what we do in hurry, we just mark the right answer. Well, we got this and we are going to just mark the right answer. You should not do this. Okay, so what we have to do, we have to find out value for d. So what I'm going to do, I'm going to do cross multiplication of it. So d to the power 4 is equal to 18tl theta pi theta g. Okay, now if we'll, this is 4, if we'll send this side, d is equal to 18tl pi theta g 1 by 4. Okay, so this is the answer for diameter for d in this question, and this question has been asked in GATE 2011. Okay, I hope you understand some basic concept as well as some useful things in this video. And can you believe my dear, it's been around 20 minutes you have been watching this video. Now one thing is pretty clear from my side, you are having good patience and hopefully you can get success in your life very soon. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so this is only a question, nothing else. But why I am sharing with you this question only? Why not I am sharing with you any concept before solving this question? Because you don't require that. I mean, you need to know, of course, but this question is is an example of a GATE. I mean, what type of question GATE really can ask you in the GATE examination? What type of question really you can get, and you will be confused. Now how they relate problems with each other, I wanted to share with you. That's why this question will not be lengthy. This question will be short, around 10 to 12 minutes. That's why it will not take, I mean, you can put your 100% concentration. Alright, so as you can see in this question, it states that homogeneous state of stress for a metal part undergoing plastic deformation is, they have given the equation. Okay, now we need to understand this equation, and here we have to use Mohr circle, the concept of Mohr circle. So to solve this question, first of all we need to know Mohr circle, right? And of course we have used little bit it, and then of course we have used some simple stress and strain concept also. Okay, and then we need to know theories of failure, because they have also related this question with von Mises criterion, and this criterion is also known as maximum shear strain energy, not stress. Okay, then what we have to find out, basically we have to find out shear yield stress. Okay, we have to find out shear yield stress. Okay, so this is the thing here we have given. So why this question is tough? Because they have relate here two things, and two things you need to know to solve this question right away. One is Mohr circle. Here we have to find out few things, then we can use those things here in case of von Mises criterion, and then we can only solve the question. Okay, so I hope you understand what I mean to say and why this question is tough, because this is interlinking question. So first of all, we need to know how we can write this table: sigma x, sigma y, sigma z, and this is tau xy, this is tau xy 0 0 0 0. Okay, you can write like this also. So here, as you can say, sigma x is equal to 10, sigma y is equal to 20, sigma z is equal to minus 10, and sigma z is known as sigma 3. Okay, and here tau xy is equal to what? Tau xy is equal to 5. So by using this, by comparing this, we can easily find out the value of sigma 1 and sigma 2, because we know that sigma 1 and, or we can say sigma 2 is equal to sigma x plus sigma y by 2 plus minus root under sigma x minus sigma y by 2 whole square plus tau xy whole square. We can put values here. So 10 plus 20 by 2 plus minus x minus y. Okay, no, doesn't matter because the square is there. So 2 is here as square, and 5 square. So what we got here, 30 by 2, 15 plus minus 10 minus 10, 100, 100 by 4, 25, and plus 25. So 15 plus minus 50. So what will happen, we can write sigma 1 is equal to 15 plus root under 50, and sigma 2 is equal to 15 minus root under 50. So here we got the answer. Let me share with you. 15 plus 50 root under 1 divided by 2. The answer is 22.07, because sigma there should be in megapascal, and here 15 minus 50 to the power 1 by 2 is equal to how much? 7.928 megapascal. Okay, 7.93 you can say. 7.93. Okay, so from here what we got, sigma 1 and sigma 2. That's not the end, my dear, it's just beginning. Okay, we have just solved the simple part of this question. Now we have to find out what that is, shear stress in case of tension, and shear stress we need to find out in case of yield shear stress. That is known as, in case of yield, that is yield shear stress. Okay, so shear stress. Okay, so we need to find out here, and we need to use the equation which is given by von Mises criterion. So that equation states that tau yt whole square greater than 1 by 2. Somewhere it is also known as sigma yt, so don't get confused. Okay, and sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. As you can see, you need to also understand what is sigma 3. I have already shared with you what is sigma 3. Okay, sigma 3 is minus 10. Alright, so half sigma 1 minus sigma 2, what? 100. Okay, sigma 2 minus sigma 3, what will happen here? Just think about it. Sigma 2 minus sigma 3, so this will become sigma 2 minus sigma 3. Okay, now okay, this will become what? 900 something, and sigma 3 minus sigma 1, this will become 400 something, right? And this is here only. So what we got here after solving, 100 plus 900. Alright, my dear, so there is a little bit problem with the formula. Okay, that's my mistake. Okay, so let's go for it. So basically what I mean to say, here we did mistake. There is a formula that is we need to add also: sigma 1 2 square plus sigma 2 3 square plus sigma 13 square in multiple 6. Okay, so from here, okay, so this is like this from here to here, and this is a little bit different. Okay, so from here what we get, okay, this is root under. Okay, and after root under, okay, I have to remove this one, so because I am sending this 2 to here, so this will become what, 1 by 2, that is known as root under. So after this what we are getting, 100, 900, 400, 1400. Okay, plus here what is sigma 1 2? Basically sigma 1 2 is 5. Let me share with you. Sigma 1 2, sigma 1 1, sigma 1 2 is 5, so this will become 5 square. What is sigma 2 3? Here sigma 2 2, sorry, sigma 2 1, sigma 2 2, sigma 2 3, what, 0, so this will become 0 square. Now what is 1 3? That is 1 1 1 2, sorry, 1 3, this is 1 1 1 2 1 3 0, so this is becoming 0, multiple 6. Okay, so what we got here, and all these values must be divided by 2. So what we got here, 25 into 6, 150, plus 1400 is equal to this much, by 2 is equal to itna, this much, and divided by 2 is equal to what we getting, basically tau yt is equal to 27.83, it's in megapascal. Okay, I hope you till now you got what we got from this what I can say from this numerical problem. Okay, so we got how much, 27.83. now what we know, what we have to find out, that is tau yss, yield shear stress. So the formula for finding out yield shear stress is tau yss. Somewhere it is also known as some people say tau y. So tau yss is equal to tau yt, yield shear yield stress in tension, divided by root 3. So the value we got here, we should divide that value by root 3. That means root 3, so 3 1 by 2. Okay, so how much we are getting basically here, okay, root 3, so oh, there is something mistake, I think so. What we got here, 27.83 divided by 1.73. okay, that's right, 16.086 megapascal. we are getting answer here. And what is the answer here, 16.086, so this is the answer. So B is the right answer for this question. Now probably you have understand how is it important to go through all concepts of the topic in each subject. That's why we can solve problem in GATE. This is not a matter of subject, even sometimes we have seen they relate with the inter-subject questions, inter-subject formulas to find out answer. I hope you understand what I mean to say, and thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so today in this video tutorial I'm going to share with you Hooke's law. And I'm sure, I don't know, you are studying in 12th class or 11th class, or maybe you are studying engineering. Because all videos I have created only for engineering student, and in mechanical engineering as well as in civil engineering, people study about this Hooke's law, as well as in 11th class we have studied about Hooke's law. Alright, so maybe you are in 12th class, I don't know from which country when you are watching this video, probably you in the below class you got this law, so doesn't matter. I'm going to share with you from base to little bit advanced level. That's why you will understand each and everything about this law. So this is a very, I must say, this is a simple law. Alright, this is really simple law. Even I'm going to share with you where exactly you will make mistake in this law while speaking or while writing definition of this law. This is the general mistake I must say, what I'm just going to share with you. So basically this law has been provided in would you like to know year? Then you will be impressed to know this. 1678. And probably you wanted to know who has been provided this law. The person name is Robert Hooke. And because his name is Robert Hooke, that's based on his surname, they have given the name of this law Hooke's law. That's why Hooke's law is known as Hooke's law today, which law we are studying. Okay, so the definition, if we'll go for definition, then it states that within the elastic limit, stress is directly proportional to strain. Now what happened if you were studying in 12th class or below undergraduate course, then you just don't remember this line, within the elastic limit. You just remember stress is directly proportional to strain. There you made a mistake, because without this line you cannot say this for Hooke's law, because Hooke's law valid till elastic limit. Remember that. And without knowing that, if you are stating this law, that means you are wrong, you are not right. Okay, so basically let's talk about what is basically elastic limit. So for understanding Hooke's law proper way, what you need to know elastic limit. And for understanding elastic limit, you need to know what is stress and what is strain. And of course, to understand stress and strain, you need to know properties of material. Can you imagine how things are interrelated to each other? If you are not having good concept and not basic concept of these things, then you cannot understand what is it and how is it related to each other. So first of all, we need to understand properties of material. And in properties of material, we are having one property that is known as elasticity. So properties of material, and among there are many properties, see. So in this video tutorial, I am only going to touch one property, that is elasticity. So basically, what is elasticity? Okay, suppose that there is a metal rod, and we are just pulling this metal rod, and just because of force we can able to pull this rod, and we just leave it after pulling maybe 2 or 3 seconds. Then what will happen? After few seconds, it will restore to its original position. Suppose that after pulling it will like this, and whenever we are leaving, then it is restored to its original position. Okay, so this property is known as elasticity of the body. Now here one of the interesting question I must share with you, and probably there are only few can understand about it, about the question, and there are many competitive examination that same pretty question has been asked. So basically, what about that question? They ask which one is more elasticity, steel or rubber. Can you guess, my dear, which one is more elastic? I don't know you can guess or not, but let me share with you, my dear. Steel is more elastic than rubber. Steel is having more elasticity property than rubber. Simple question, right? So this is all about elasticity. Okay, now let's come to the elastic limit. For understanding elastic limit, you need to understand stress and strain diagram. You know what is the stress and strain diagram? Basically, stress is denoted by sigma and strain is denoted by small e. And if you are talking about stress and strain diagram, then this is like this only. Now stress and strain diagram for different material is different, so the drawing must be different. But here we are talking about stress and strain diagram for MS. M for mild, one of the type of steel basically, and S for steel. So if you are talking about stress and strain diagram for mild steel, then this is very popular. Do you know why? Because from this diagram we can understand it properly. So basically from here to here, from O to A is till O to A, Hooke's law valid. And then after, then after we must say the Hooke's law is not valid because its property keep on changing with the diagram. As diagram is different, that's because of properties changing. I have already shared stress and strain diagram for different materials. Well, I will create another video, that's why you can understand much better way about it. Okay, but today what we are talking about, from here to here. So suppose that we are taking any material and we wanted to make valid this Hooke's law, then the material, the stress and strain proportion would be 0 to A only for the validation of Hooke's law. If you're talking about MS, mild steel, then should be from here to here if we wanted to valid Hooke's law and use Hooke's law for finding anything. Alright, so this is about elastic limit. From O to A, Hooke's law is valid and it is elastic limit. Okay, now from here to here, little bit also till here, it is elastic, but little bit plastic deformation keep on going. That means if you will go beyond this, then it cannot be restored to the original position as it is. It will be little bit different. There will be little bit difference. That's why I'm saying like this. Okay, I hope you are getting, and you are getting some inside information about Hooke's law, which probably you haven't studied till now, you haven't understand or haven't got information, such type of information from any sources till now. I believe so because I am providing something indeed and awesome information in this video. Okay, so let's go ahead. So now, what is stress and what is strain? Stress is, again, if we'll talk, force by area, and its unit is Newton per meter square. That's right. If you are saying this, that's right. There is nothing wrong with it. But exactly what is stress, you need to know. Suppose that there is a body, and in this body we are putting load. Okay, everywhere putting load, and if we are putting load and body is stable, that means there is something reaction force is going on, and that reaction force per unit that area is known as stress. And here the reaction force and the applied load, what kind of things is going on here? Newton's third law, action and reaction. Again we are using another law, and that law we can relate here also. So if you're talking about what is stress in numerical point of view, force by area, its unit is Newton per meter square or Pascal if we are talking about in SI unit. Now strain, what is basically strain? Strain means change in length by original length. Change in length by original length. That means delta L by L. So because it's, if we'll talk about in SI meter, so this is a dimensionless term or quantity, you can say. Okay, so here what we are getting here, sigma is directly proportional to small e, because sigma is denoted by, sigma is the denotation for stress and small e is for strain. So sigma is equal to capital E into small e. Now another, the different term I have introduced here, that is capital E. So you need to know what is capital E. So capital E means Young's modulus. Young's modulus of elasticity. It is, as I have already shared with you, it is denoted by capital E. And can you guess what would be the unit of this? Now see here, stress, the unit of stress is Newton per meter square Pascal, because this strain is having no unit, so therefore the unit of E, Young's modulus of elasticity would be same Pascal or Newton per meter square in SI. So this is all about Hooke's law, and what kind of questions you can get I can share with you, because there are many stress just like shear stress, simple stress. Same here, there are many type of strain: longitudinal strain, lateral strain, volumetric strain. So those are all things you need to understand if you wanted to go in depth about all factors we have used in Hooke's law. But if you are preparing for plus 2 examination, then all these things are not required, I think so. If you are studying, that's okay, you are getting very good knowledge about it, and what information I have given in this video total, that's enough for you to solve any numerical problem, almost any numerical problem, or maybe some tricky question you can easily solve, because they can interlink things with this, probably with this. So for plus 2 level, this thing is okay, sigma is directly proportional to E, but don't forget to use this one what I have shared with you. This is the mistake 90% students made while defining or while telling definition of Hooke's law. I don't want you to make this mistake, because if you are not using within the elastic limit, that means that is not Hooke's law. Okay, so this is all about Hooke's law. I hope you got some inside information about it. Okay, so thanks for watching. See you soon in my next video. Bye bye. Hello my dear. So in this video tutorial, I'm going to share with you stress and strain. Well, this is a simple topic, and of course if you are watching this video, that means you did not understand properly about these topics. That's why you are watching. So basically in this topic, I'm going to share with you a numerical problem which has been asked in GATE 2006, as well as its basic concept, and related to its concept what we can get. I'll also share with you types of stress, strain and all things together in this video tutorial will only. So stay tuned and keep watching this video. So basically, what is stress and what is strain? Before going to tell you the definition or other things about it, let me share with you how we denote stress and how we denote strain. Stress is denoted by sigma and strain is denoted by small e, and stress is denoted by sigma and it is denoted by small e. So basically, what is stress? Suppose that we have a body and it's made of probably cast iron, okay, and in this body we are putting a load, okay, and load, suppose that F. Now because of this load, if body, this cast iron, Ci means cast iron, this cast iron body still is in this position without deformation, that means there is reaction force acting against this force. The reaction force acting against this force per unit area is known as stress. Okay, so reaction force per unit area is known as stress. So what you got, sigma is equal to F by A. F means force. So if you wanted to know unit of stress, then what would be the unit of stress? Unit of force is Newton in SI and area is in meter square. So Newton per meter square its unit, and also we know Newton per meter square as Pascal, and another unit is bar, but this one is little bit bigger than Pascal or Newton per meter square, because 1 bar is equal to 10 to the power 5 Newton per meter square or Pascal, you can say. So this is about stress. Okay, now let's come to the strain. So basically, if you're talking about types of stress, then basically there are 3 types of stress. Okay, let me share with you what are types of stress, then I will talk about strain only. So first of all, tensile stress, and this type of stress is generated because of tensile force. Now you need to understand what is tensile force, right? So let me share with you. Suppose that this is a body and that tensile force is acting in this body, this side and this side, and because of this tensile force the stress is generated, that is known as tensile stress. Second is compressive stress. Again, just like the tensile stress, compressive stress is generated because of compression force or compressive force on the body is known as compressive stress. Suppose that we have a body and we are putting here compressive force, and because of this force the stress is generating in the body is known as compressive stress. And third one is shear stress, and this is a little bit different. Probably you are not familiar with this stress and most of the students struggle to understand this. Basically shear stress is generated by torque. Okay, so what you understand, I mean what you should know about this stress. So basically this stress is generated because of the force is acting and deformation or probably deformation is not happening. Okay, and force is acting in the angle, okay, I mean parallel to the body, but here in this case force is acting perpendicular to the body, you can say. Okay, I mean if you are if you are thinking that this is perpendicular to the body, it is acting, but in case of this this shear stress parallel to the body, and because of this there is shear strain is happening when it is acting parallel to the body. So this is the main difference, and all these forces also known as normal force. Okay, now these are all forces, I mean shear stress, compressive stress and tensile stress. Now when it comes to strain, there are three types of strain basically, but as I have shared with you, we denote strain by small e, and the simple definition of strain is lateral strain, it's change in length by original length. Change in length, suppose that we are denoted by delta L, original length is L. Now what is this? Let me share with you. Suppose that we have a body and its length is L, and because of we are putting, suppose that we are just trying to pull the body, so its length is changing to L1, and the change in length L1 minus L is known as delta L. Okay, so strain is what? Change in length by original length is known as strain. And because if you will come to know, I mean the unit of delta L is in meter in SI and length also in meter, so meter get cancelled, so strain is a dimensionless quantity. Alright, I hope you understand it. Now if you're talking about types of strain, there are a few types of strain. First is lateral strain. What is lateral strain? We need to understand. Suppose that the deformation is taking place in diameter, in this direction. This is diameter of the body and this is length. If deformation is taking place length of the body, then it is known as longitudinal strain. And if the deformation, longitudinal strain is just happening here as I have shared with you, this is longitudinal strain. And lateral strain, if it's because of pulling force both the side, okay, then its diameter probably the body will be changed like this. Okay, its diameter is changing, first D and D1, so delta D, D1 minus D. So this is known as lateral strain. Last one is shear strain, as I have already shared with you about this. This is happening in the, there is some angle, and because of that angle it is happening, it is known as shear strain. And let me share with you a diagram, that's why you can understand about it properly. Suppose that this is a body and we are just putting a force, and because of this force a body structure is changing to like this is suppose that phi. And if you're talking about here to here, it's changing, right? Okay, so original length, the change in length by original length is known as strain, and because of its changing here in angle, because some angle, that's why it is known as shear strain. So these are all three types of stress as well as strain. Other than this, we are having volumetric strain too. If you wanted to know the simple formula for finding out volumetric strain, then that is delta V by V is known as small ev. Small ev means volumetric strain, and delta v means change in volume, and the denominator, that this one v is known as volume, original volume of the body. So this is all about stress and strain. I hope you understand. So now the most important thing what I am going to share with you in the numerical problem. So basically what you have to understand, what is stress, what is strain, what are types of stress, what are type of strain, and of course you need to know diagrams, because if you are preparing for university examination, and most of the time we get question what is stress and what is strain for only short questions and answers. If we are getting numerical problem, then probably it becomes a little bit lengthier. Otherwise short question answers we usually see. And if you are in 12th class, then what material till now I have shared with you, that's really enough for you to for solving any questions related to it, almost any question, I must say that. Okay, so this is about stress and strain. Now let's go to the another that questions what I have shared with you already, that I am going to solve a numerical problem which has been asked in gate 2006 for 2 marks, I think. So 2 marks is a big marks. You know that if you are preparing for gate, you know what is the value of 2 marks very well. I don't need to tell you anymore. So let's go for the question. So right now in front of you we have a question, and this question has been asked in gate 2006, and this question was it was about 2 marks. And can you believe, my dear, this is one of the simple question as I ever seen in gate previous year, because this question is totally formula based, and you need to understand, you need to understand what this question is all about. Once you will understand this, what question is all about, then it becomes quite easier for you to understand about the question. So let's go for it. In this question it states that a steel bar of 40 mm by 40 mm square cross section is subjected to an axial compressive load of 200 kilonewton. If length of bar is 2 meter into E, and is equal to 200 gigapascal, the conduction of the bar will be what? Okay, so we have given all options just like you usually see in gate. Now before I can solve this question within a minute, because it's simple and I have also gone through this question, that's why. But I wanted to make you understand the basic concept about this question, how to solve it. Okay, so here what we are going to use, we are just going to draw a diagram, and this diagram is as we have given in the problem. Okay, so this diagram is square, cross section 40 by 40. Okay, and is subjected to an axial compressive load of 200 kilonewton if length of the bar is 2 meter. Okay, its length is 2 meter, and it's a square cross section. I have just drawn it's a cross section only 40 by 40. So length is 2 meter, and compressive load, that means force, is 200 kilonewton. Don't get confused with unit, because unit play most important role. Once you will understand about the question, your focus should be on unit, what unit they have given, what unit they have asked, because 90% time what we did, we make mistake in case of unit. Don't do that, don't make mistake in unit. I'm repeating again, I know that. Okay, so 200 into 10 to the power 3 Newton. Okay, here we got it. Now contraction of the bar will be, because of compressive load there will be some definitely compression. Why I'm sharing with you, suppose that we have a body and we are just compressing this body, and because of this compression definitely its length will be decreased, the size of the body will be decreased. That's why it states that contraction of the bar will be, because we are putting compressive load there of 200 kilonewton. It's not less, it's huge, man. And capital E is equal to 200 gigapascal. Okay, so it is totally depend on the stress and strain formula. Now what is stress? Stress is force by area. Force 200, not totally, I must say, a little bit partially, because we have to use the concept of Hooke's law to solve the problem. Okay, if you don't know, then go through my videos. What is Hooke's law? I made it understand from depth, its depth as well as basic concept. So 200 into 10 to the power 3, 40 into 40 unit, because of this is given in millimeter, so I have to convert into meter. So definitely 10 to the power minus 3 into 10 to the power minus 3 I have to multiple to make it, the unit in Newton per meter square. So what the values for this, I have to use calculator. And if you're preparing for GATE, then believe me my dear, don't try to practice with calculator, because you are not going to a physical calculator, you are going to get an online computer based calculator. So try to practice that calculator, and that I believe that calculator is not that much familiar with all of the students. So don't make that mistake, try to use that calculator at least once. That's why it will be quite familiar with you till the examination. Okay, so this is 200 into 10 to the power 3 divided 40 multiple 40 into 10 to the power minus 6. So what we got here, we got 125,336 megapascal, because Newton per meter square means pascal, that's why mega means 10 to the power 6. So the stress because of the load we are putting on the body is 125 megapascal. One thing is clear now. What we know, strain is delta L by dl by L. What we have to find out, change in length, contraction. Okay, so what we have to find out, length, delta, dl. So what length we have given, 2 meter. Now we have to use the relation between Hooke's law, that's the Hooke's law. What Hooke's law basically states, stress is directly proportional to strain within the elastic limit. Okay, so what we have to use, sigma is directly proportional to E. Sigma is equal to capital E small e. Sigma is given, E is given, small e is dl by L. So L is given, so what we have to do, we have to send this E to this side and L to the upper side. Simple concept. So 125 10 to the power 6, L is 2 meter, E is what we have given, 200 giga means 10 to the power 9. Okay, so after solving this problem, what we are getting, we need to see it, 125 into 10 to the power 6 into 2 divided by 200 into 10 to the power 9 is equal to 0.00, but this is in meter, remember that, because all unit in this problem is in meter. So I have to multiple with 1000. Why? Because the answer given is in mm. That's why before solving the question I have shared with you, always after understanding the problem, always your focus should be in unit. What unit you need to find out, what unit they have provided in the numerical problem. So after multiplication, what we are getting, that is 1.25. So you got the answer, A is right option. And after solving this question, you are going to get 2 marks from this problem. I hope you understand what I wanted to make you understand, the concept of stress and strain. And hopefully you have enjoyed the video, you have learned something, and thank you very much for watching. Bye bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about Pinel hardness number. So basically, I know we studied about this number in, if you are studying material science, manufacturing process, as well as strength of material. If you are studying about material hardness, then definitely you are learning about this number. This is one of the most important number, and I have seen questions has been asked in competition examination related to it. So basically, what is it, I'm going to share with you, and how you can use its formula to find out and to figure out hardness of the material, as well as I'm going to share with you our approach to solve numerical problem related to this number. That's why That's because of what you are watching this video, that will be fulfilled, right? So maybe probably you are in hurry, you wanted to get that formula, but don't worry, I'm going to share with you, that is most important too. So basically what we can do with this number, we can find out one of the property of material, that is hardness. Now probably you will be wondered to know what is basically hardness. What is the hardness of the material? Suppose that we are having a body and we are just hitting this body, or probably anything, any working force is working, any force is working on the surface of this body, and because of this surface working force is acting on this body, maybe the surface will be, abrasion will be taking place, or maybe indentation will be taking place from the surface. Okay, and suppose that the diameter of the body is something and the orientation diameter is something, and suppose, and probably you can assume this body is made up of, suppose, brass. Okay, so diameter is given and this is given. Now what we can do, we can find out hardness of the material, and that hardness is known as BHN. BHN play most important role to predict the hardness of the material. So if we wanted to know the exact hardness of the material, then definitely we must use this one. Well, we are having different process too other than this, but BHN is most popular nowadays. We have used, when I have studied engineering, that time our director said about it a lot, because he has been belonging from this background, material background. So hardness is one of the property of material, and BHN we use to find out hardness of the material. Okay, now what is the, basically if you wanted to know what is the formula for finding out hardness. Okay, so what is the formula for finding out BHN, that is also important. The formula is P pi d by 2 d minus root under d square minus d square. This is the formula. There is nothing like rocket science. You can easily solve the problem. You don't have any problem, you will not face any problem. Okay, now suppose that we have given in a numerical problem, we are putting a force, okay, because of to have abrasion or indentation of 100 kilonewton. Okay, and the diameter of the body is, suppose that 200 mm, and because of this force is acting on the body, there is some orientation. The orientation diameter, suppose that 2 mm. Okay, 2 mm. Now based on this data, these three datas, we can find out BHN of the material, and then we use that number to have to understand the hardness of the material. And hardness of the material is also required in many places. That's why we studied about material properties. Only elasticity or only ductility, only a good toughness of the material is not required everywhere. Somewhere we also required malleability, somewhere we required strength of the material, somewhere we required hardness of the material. That is depend on place to place. Alright, so let's go for the numerical problem what I am just discussing with you. So P is equal to what? 100 into 10 to the power 3 pi d means 200 by 2. Now here what we have to do, we have to change its unit. So 10 to the power minus 3. So d is here 200 into 10 to the power minus 3, 200 into 10 to the power minus 3 whole square minus 2 into 10 to the power minus 3 a whole square. Okay, so this is the equation we got after putting all values. Now what we have to do, we have to solve the problem. So let's start from here, because this one little bit complicated. So 200 multiple 10 to the power minus 3 a whole square minus 2 into 10 to the power minus 3 whole square. Got it? Now this is in root under, so I have to find out its root. So what we got here, almost 0.2. Okay, now what we have to do, just 200 multiple 10 to the power minus 3 minus 0.2. So this must be, I should get 1.99. So 1.99. Okay, so 0.2 minus 0.199. What we got here, multiple 0.001. okay, now we have to solve this part. Pi into 200 into 10 to the power minus 3 divided by 2. okay, multiple 0.0001. so what we got here, this much. Now what we have to do, we have to we have to divide this term by this term. We have to divide this term. This term should be in division and this term should be in the upper side. So 100 into 10 to the power 3 divided by answer. So this is the answer we are getting. It's really huge. So probably I made some mistake. Probably I have taken, I know data is totally little bit different, that's why we are getting the value is here. So this is the binomial hardness number for this numerical problem. So this is how you can solve numerical problem quite easily if you are getting a problem related to BHN. Other than this, hardness of the material also important. Other than this we are having other things, just like if you are talking about properties of material, and there are few things, those are important, most important. okay, if you're talking about machining process, then the malleability is most important. Malleability play most important role in case of machining process. Now if you're talking about ductility, then this is also one of the most important property of material, because we ductile material we usually study, as well as brittle material. These two material, most of the students are familiar with ductility as well as brittle material. So what types of types of properties basically I am sharing with you: ductility and malleability, and brittle material hardness, means hard material. And next is tough. Another one is I must say that strength of the material. So all these are properties of materials. Once you will understand all properties of materials, then definitely I'm sure you have gone through BHN. So if you are talking, so among all these, if you're talking about which one is most important, and how we can understand its relation with stress and strain, because stress and strain also play important role. That's why we usually draw a stress and strain diagram for different types of material. okay, so why it is happening, because to understand its basic concept and its strength the right way, stress and strain diagram play most important role. Suppose that most of the time what people make mistake, they thought stress diagram means like this, they draw like this, but this is not a stress strain diagram. Yeah, this is a stress strain diagram, but this stress and strain diagram is for a particular material, that is MS, because every material having different properties. That's why the stress strain diagram for every material is different. Remember that. I know this is a little bit off topic, then I am talking about this BHN. Well, I have done with BHN till now what I wanted to make you understand about BHN. That's why I was sharing with the properties of material, and of course this is related to BHN only, because BHN is also help us to find out one of the property of the material. I hope you understand something from this video tutorial. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, this is Ujjwal Kumar Sen, and in this topic, this is little bit confusing topic for all the time. Basically, those are preparing for university examination, or maybe you are preparing for any other examination, but this is one of the most confusing topic. Why? Because of this term, self weight. If you are talking about deflection of bar, then it's really easy to find out. Okay, because we are just going to use Hooke's law equation and simple concept of stress and strain. Okay, and that is P by A dl by L into E, and deflection of the bar would be PL by AE. But in this type of deflection, suppose that we are having a bar like this, okay, and because of its weight, something p is weight is acting here, because of this p we are having deflection here. But we are not considering weight of the body, weight of the body, of this body. That's why we have find out it quite easily. But in actual life, if something is hanging somewhere, and there should be some deflection, okay, maybe because maybe material is not that much flexible, that's why deflection will take place. Maybe there not be deflection also, but if there will be deflection because of self weight, then what will happen? I mean, what would be the formula for that? And let me tell you dear, this is totally vary from structure to structure, because different structure having different formula for this. Remember that. Okay, so let's go for it. So basically what I'm talking about here, I'm going to talk about two types of bar. One is prismatic bar, and another one is conical bar. So there are two types of bar here I am talking about, and in these two types of bar you are going to understand its basic concept as well as the formula to find out deflection due to self weight. I hope you are getting my point, and definitely you are going to understand something important from this video tutorial, right? So if we are talking about prismatic bar, then what would be the formula for finding out its deflection? Suppose that we have a prismatic bar like this, okay, and now here we are not going to put any load just like we have put it here, because here we wanted to find out deflection because of its self weight. This is the key, right? So the formula for finding out deflection because of this body self weight is, it's PL. P is load, self load, P. L is length by 2AE. A is area of the prismatic bar, E is Young's modulus, L is length of the, and 2 because of this. How we got this value, this is also important. Well, we can get this value after derivation. Okay, so it takes little bit time to understand, and of course you can easily solve that. But in this video my motto is not to tell you derivation of it. My motto is tell you the information we wanted to share with you. Okay, because here I am sharing the numerical approach. That's why I haven't written in the title that I am going to sharing with you derivation. Okay, derivation you can easily learn from book also, there are many books. Okay, and now if we'll go through the conical bar, okay, conical bar. So what is basically conical bar? That is also important to learn, because conical bar, sometimes it's confusing little bit. So diagram play most important role to understand about the conical bar. Suppose that this is a conical bar, and diameter of the conical bar is, suppose that D, and length is L. Now it is just like same, the case is just like same as prismatic bar, but the formula would be different because of its structure. That's why in the beginning of the video I have shared with you that the deflection due to self weight also depend on the structure, because here deflection, if it is happening because of self weight, so structure would be different, that means the weight would be different, and the weight act in the different way in that body. That's why the formula would be different. Okay, now deflection would be what? PL by 6AE. That's not all, my dear, that's not all, of course not all. Now next, if I would like to share with you one more thing that is also important, that is specific weight. Specific weight, because if someone is studying about this topic, then if you are studying this topic first time, then probably it is little bit difficult for you to understand. But believe me, my dear, if you'll go through few numerical problems, then it becomes quite easier for you to understand it, and of course it will be helpful for you to understand as well as to remember the topic. Now if I'll add term specific weight in both the equation, both the formula, then what will happen? It becomes PL square by 2E, and here also sorry, it's gamma L square by 6E. So from this, the relation between prismatic bar and conical bar we also get from this equation also. You can say that. That means if you are somebody tell that there is relation, what is the relation between prismatic bar and conical bar? That is conical bar 1 by 3 into deflection of prismatic bar, right? This is the relation actually. Okay, now what is basically specific weight? Okay, here we are talking about is weight of the body, so definitely it should be specific weight of the body. Now if you relate these two formulas, then you can say what is the value of what is the value of specific weight. You can easily understand, you can easily find out. Alright, so hopefully you wanted to know how to find out that, right? So let me share with you how to do that. PL 2AE gamma L square by 2E. Both the equation are same, so L get cancelled, E get cancelled, so gamma is equal to P by, and 2 also cancel, P by AL. So this is the formula for finding out gamma. And now put this P by AL, this become this. So gamma is specific weight and its formula is P by AL. P is self weight of the body. You got it? Now basically you can say P by AL means P by load by volume is known as specific weight. Okay, so but this unit of this load is in Newton. You must remember that. Alright, so this is all about deflection of bar due to self weight. Now numerical problems, if you wanted to learn numerical approach to solve and to understand this question, then definitely you should go through it, what I am going to share with you right now only. Now probability of giving question in the gate examination, if you are preparing for gate, then they definitely going to relate prismatic bar as well as conical bar, maybe with specific weight, maybe with these two equations. They probably going to give you the deflection of the prismatic bar is this. Probably they will tell, suppose that there is a prismatic bar, and in this prismatic bar E is equal to something, A is equal to something, P is equal to something, and L is equal to something. Okay, now find out if it is conical bar, then what would be the deflection of it. Then what you have to do, you have to find out first deflection of the prismatic bar. After getting a value of the prismatic bar, what you have to do, you have to multiply the value with 1 by 3, then you are going to get the right answer. So this is a little complex problem. Now if they wanted to make it more complex, then probably they are not going to give you value of A. Probably they will get with stress also, that P by A means, what is P by A? Force by area, that means stress. Probably they will give you stress generating because of self weight. So they can make you a little bit confused on this, but if you know the formula, if you know its little bit in-depth concept, if you know how they can relate two things together to make you confused, then definitely you will not be in confusion. You can solve the problem without any confusion. Alright, so I hope you understand what I wanted to make you understand through this example. So this is example. Well, till now I haven't seen any question they have asked because of this from this concept or from this topic. That's why, probably they have asked, but I don't have any question. If you got, then you can ask me. Otherwise it's okay. I think you understand what you wanted to what you need to understand from this topic. Alright, so thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial you are going to learn about elastic constants and of course relation among all. So this is Ujjwal Kumar Sen. Well, today I'm going to share with you all these things. Okay, so let's go for it. I hope you are interested to learn all things, right? So basically what are elastic constant? Okay, so this is important, and of course relation also important, because if you are preparing for GATE examination or even university examination. So actually what happened in university exam and GATE exam. GATE exam will not ask you any derivation, but university examination I have seen they've asked you derivation from this relation among all. Probably they will give you some relation and they will tell you derive this equation. Okay, so this is in that way you can get question. Other than this, you can get numerical problem also among the relation. Okay, now let's talk about elastic constants. What are elastic constants? Okay, so basically these constants are relation between two things. One is stress and another is strain. But elastic constant differ from types of strain and types of strain, because there are many types of strain and many types of stress. So according to that, the elastic constant also keep on changing. I mean their name is also keep on changing, right? So basically what is elastic constant? So the relation between stress and strain. So not most of the time, all the time we'll see stress is on the top and strain is on the division side. Okay, so first of all, Young's modulus, or sometimes we know this as modulus of elasticity. It is denoted by E. You will see almost 99.9% book that Young's modulus or modulus of elasticity is denoted by E, and it is equal to longitudinal stress by longitudinal strain. Now maybe you wanted to know what is longitudinal stress and longitudinal strain. Basically what is, I mean if there is anything happen because of in this direction, in case of length, in linear direction you can say also, that is known as longitudinal stress. If stress is happening in that direction, that is known as longitudinal. If strain is happening in that direction, that is known as longitudinal strain. So most of the time what happen, longitudinal stress is equal to force by area and longitudinal strain is equal to delta L by L. Okay, this is simple, force by area, P for force, but this one is maybe little bit difficult for you. Suppose that, let me make you understand through diagram, that's why it will become quite easier for you to understand about it. Suppose that we are putting a load here from this direction and this direction. Okay, PP. Because of this load, the shape of the body is changing to this and the length is also increasing L1. So delta L is what? L1 minus L. And this is known as what? Change in length. Change in length. And this L is known as this. This is known as what? In terms, in language you can say this is known as original length. Okay, so this is about modulus of elasticity and or Young modulus. Now how this Young's modulus come, I mean how we relate this one, that is also important, right? So basically we studied about it in Hooke's law, and believe me my dear, in Hooke's law I have shared with you a lot of things, and that was one of the most amazing I think video in all over the world. You can see about Hooke's law. That's what amazing. You must view that video, watch that video. That is just amazing. If you wanted to learn about Hooke's law, then that is just awesome. Okay, that is different thing. So Hooke's law, what it state, sigma stress is directly proportional to strain and sigma but within the elastic limit. Yes, within the elastic limit, stress is directly proportional to strain, and this one is EE. So this E is also known as this one Young's modulus, and here we got E is equal to stress by strain, and these two are longitudinal only. That's why I have written here longitudinal stress by longitudinal strain. Got it? Now let's go for the another elastic constant, whose name is modulus of rigidity. Sometimes it is also denoted by n. Modulus of g n, or somewhere it is also denoted by theta. But most of the time modulus of rigidity is denoted by g. So remembering these things is always helpful. Sometimes also C, okay, is always helpful. Why I am sharing with you? Probably there are many books out there, they have also denote with different things to make them unique, or that is their method, that is not my method. But my method is all about to help you to understand modulus of rigidity. So basically what is modulus of rigidity? This is happening, this thing is happening, theta also, this is happening, that's because of shear stress by shear strain. And the formula of this is this only, shear stress by shear strain. Okay, again I am telling you, if you don't understand the concept of stress and strain, you must watch my video about stress and strain. That will help you to understand its basic concept, types, as well as many things what you need to know about stress and strain. So modulus of rigidity, what is this? Shear stress by shear strain. Again I'm telling you, stress is nothing. Shear stress and shear strain is differ from longitudinal stress and longitudinal strain, because this is happening only because of there is something acting in the angle. Suppose that if you wanted to understand about shear strain, then let me share with you. Suppose this is a body and there is a force acting here, and because of this force the body's shape be changing from here to, suppose that this is B and this is B dash, right, and this is O. Okay, so what would be shear strain? B1 B by OB. This is known as shear strain. Okay, so I hope you understand about shear strain, right? So now in case of stress, if something is happening, something is acting perpendicular, that is known as that is known as also stress. But if it is acting tangentially, then it is known as tangentially, force is acting tangentially, then it is known as what is that? Shear stress. If it is acting, force is acting tangentially, that's why shear stress is also known as tangential stress. Remember that. That's why shear stress is also known as tangential stress. You need to remember this. Okay, so this is all about modulus of rigidity, which is most of the time denoted by capital G. Now let's come to the bulk modulus. Well, I have studied about, I have seen 5 to 6 books. I have read 5 to 6 books. Okay, so before teaching as well, before making this video, so I have gone through all things what they're talking about, and I have also talked to my friends, my teachers about all topics, what should be the thing I should share with you in the videos. That's why it becomes quite helpful for you people, right? So what is happening? Bulk modulus is always represented by, almost all author represented by K only, and it is known as direct stress by volumetric strain, and volumetric strain is denoted by small ev or epsilon v. Okay, direct stress is simply sigma. So don't get confused with these two, because many books are denoting with different things. I don't want that. I wanted to share with you both, and I wanted to share with you all. That's why you'll have all things together in this video only. Don't need to go anywhere else. This is my main motto. Okay, so this is all three elastic constants. And these constants, believe me my dear, one more thing that is also important, all these elastic constants having a single unit, that is Pascal or Newton per meter square in SI. If you are talking about unit system, then all these, I'm repeating again, I know this, I am repeating again, I know this, all these elastic constant having the same unit in SI, that is Newton per meter square or Pascal. Now let's go for another thing, that's numerical problem I would like to share with you. But before going to solve the numerical problem, I must share with you the relation among all elastic constant. Relation among all elastic constant. If you are studying about gate or any numerical problems from this subject in this topic, then this is very important. I must say that this is really important. So if you are preparing for gate, then that's just amazing for you to understand, to remember all these relations. So there are 4 relations I'm going to share with you, and all relations are elastic constant, as well as one thing is also I have involved, that is what is that? Poisson ratio. In my upcoming video I'll share with you what is Poisson ratio with different way, and definitely you will get some basic concept of that also in that video only. But in this video I'm going to share with you only 4 relations. Yeah, end of the video you will get what is that, you get a numerical problem which has been asked in GATE 2000. I couldn't remember in which year they have asked, but not in earlier. It has as some, I mean, some years ago. So 3k minus 2g, 6k plus 2g. Now E equal to 3k 1 minus 2 mu. Another one is E equal to 9k g 3k plus g, and another one is E equal to 2g 1 plus mu. These are 4 relations among all elastic constant. Okay, so if you are preparing for GATE, I will suggest you just remember all these relations. These relations will help you to solve numerical problems also. Okay, so I hope you understand all these relations. Are not understanding, these all are just remembering. You need to remember, right? Now the numerical problem I wanted to share with you, that is here only. This is the numerical problem. This numerical problem, I mean, this is the not numerical problem, basically this is a simple concept. You just need to understand the question and you have to go through it, right? So what in this question states that in terms of Poisson ratio, that is mu, okay, the ratio of Young's modulus to shear modulus G of elastic constant. That means we have to relate 3 things, mu, E and G, to solve the problem, and we have to get the answer in terms of, as you can see, Poisson ratio. Now I have shared with you few formulas and few relations. As you can see, these are 4 relations. Now as you can see, there are 3 things only they have shared, E and G and mu. So can you see any relation which is just denoting these 3 things? Yes, this is the 4th number relation I have shared with you, E equal to 2g 1 plus mu. So just write that equation, E is equal to 2g 1 plus mu. Okay, now don't be in hurry, just go through it slowly. That's why you can mark the right answer. This is the right approach to solve the problem, and mark the right answer, because if you mark the wrong answer, you are not going to get any marks. Even you have to give marks to the examiner, because most of the time minus marking would be there. So what it states that the ratio of Young's modulus to shear modulus, that means we have to find out E by Z is equal to what? Simple, what you have to do, just transfer this G to this side. So E by Z is equal to 2 1 plus mu. We have to check the right answer. Which one is right answer we have given in this problem, that is C. So C is the right option for this question. So as you have seen right now that how they can ask you question in this from this all this relation, and of course I guess you understand the topic which I wanted to make you understand. Okay, thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so this is the Ujjal Kumar Sen, and today in this video tutorial I'm going to share with you about Poisson ratio. And for this tutorial I have been waiting a little bit long because I have some work. So this is about Poisson ratio. So as in my all videos I always share the topic, what is all about, then I always share how to denote that thing and how to denote Poisson ratio. But in this case, in the case of Poisson ratio, we are having 2 ways to denote it. One is mu another one is 1 by m. But if you are seeing, if you wanted to know which one is most popular, then I must say mu1 is most popular. I have seen most of the books are using only mu. 1 by m is not that much popular because it is a little bit difficult to denote. Okay, so what is basically Poisson ratio and why it is important? Of course this one is important because this term has been come out from lot of experiment, of course, about it, right? So what is, and it is having also relation with the elastic constant, just like modulus of elasticity, modulus of rigidity, bulk modulus. I mean this term is also related with all those elastic constant. Now what Poisson ratio, what is the formula of this Poisson ratio? That is lateral strain by longitudinal strain. So lateral strain by longitudinal strain, is that simple? That means strain by strain, so this is dimensionless. That means Poisson ratio is dimensionless quantity. Alright, now most important, this thing usually you can get easily from book or anywhere, but what is lateral strain and what is longitudinal strain, and probably you cannot get from all sources. So let me make you understand what is lateral strain and what is longitudinal strain. That is, lateral strain means, suppose that we are having a body and the diameter of this body is d, and because the two forces we are just acting in this body, and because of these two forces, these tensile forces, because of these two tensile forces, suppose that P1 and PP, and the diameter of the body has been changed to d1. Therefore delta d, that means change in d, diameter of the body, d1 minus d. This is known as lateral strain. Lateral strain, what is? Delta d by d, change in diameter by diameter, original diameter, is known as lateral strain. But if you are talking about longitudinal strain, then that must be interesting, right? So suppose that we are having a body, and again we are putting tensile force PP. The length of the body before applying tensile force L, after applying tensile force, its length has been increased to L1. Therefore change in length is L1 minus L, and longitudinal strain is equal to change in length by original length. Okay, so this is about lateral strain and longitudinal strain, and its ratio is known as Poisson ratio. So don't get confused with it. Now tip, one of the tip I would like to share with you here, how to remember this right way. Most of the time what we confuse, that is it lateral by longitudinal or longitudinal by lateral? How to remember this? So just go to the lateral, spelling of lateral and spelling of longitudinal. If A is coming first, LA for first, A is first, and O is coming later on A, right? That's why if LA is coming first, that means this will be in the upper side. O is coming after A, that's why it is in the downward side. Simple concept. If you are getting confused anywhere, and most of the time we confused when we are in the tension, just like examination time, just like if we are sitting in front of the interviewer, in that time we usually get confused, and for that time we need to apply this concept, which concept I have just shared with you, to mark the right answer or to tell the right answer. I hope you are understanding my point, right? Now most important, the value of Poisson ratio. What is the value of Poisson ratio? Usually in the numerical problems, if you have solved numerical problems, probably you have solved, then you have seen they usually give the value of Poisson ratio in 0.2, maybe 0.3, and like these values usually get, they usually give you for in the problem. But what is the exactly value of mu? and when mu would be 0 and when mu would be maximum, that is 0.5. Till now I have gone through all books, all sources I can have to share with you the value of Poisson ratio, and of course I got some amazing views, amazing information, that's why I can share with you. So in general what happened, its mu point vary from 0.2 to 0.3 in general. Maybe 0.21, maybe 0.3, 0.35 or 36, 37, okay, that is different thing, but 0.2 to 0.3. But when mu equal to 0 in case of cork, and if you wanted to go little bit, almost zero, few sources I have used to get this value. For cork it's almost 0. Now just if you will say concrete, what is the value of concrete and what is the value of mu for concrete is equal to almost 0.1, almost 0.1. But when mu is 0.5, that is important for you to know, because it's almost maximum, isn't it? So for the case of rubber, only in the case of rubber we are getting maximum value of Poisson ratio. Think about it, maximum value of Poisson ratio we are getting in the case of rubber. Now if you wanted to know one thing that is also important, which one is more elastic, rubber or steel? Steel is more elastic than rubber, right? But here the value of mu is 0.5 in the case of rubber only. So this is all about Poisson ratio. Now we can have different case here also. Yes, we can have different case here also. How it is? If we are putting tensile force, then its length is increasing. If we are putting a compressive force, then length will what happen? Decrease. Here the same case, if we'll put compressive force, then diameter of the object will, what will happen with it? It will decrease. So the Poisson ratio also depend on type of load we are acting in the body. So it is not depend on only load, the type of load we are acting. Is it tensile? Is it compressive? So but there are two types of load we are having right now, because lateral and longitudinal. So it can be vary here only now in the case of lateral as well as longitudinal. Well, these are two types of strain also. If you will go through types of strain, then there are three types of strain. One is lateral strain, another one is longitudinal strain, and last one is shear strain. There are three types of basically strain, and here we have used only two types of strain. One is lateral strain that I have shared with you, another one is longitudinal strain. Now let me share with you one of the question already asked in GATE. In the question they have asked if there is a relation in that relation is also known as a relation among elastic constant. Okay, that is known as E is equal to 2g1 plus mu. Here E is Young's modulus of elasticity, okay, or sometimes we call modulus of elasticity. G is modulus of rigidity, and mu, as it is I have shared with you, it's Poisson ratio. So among these three we have a relation that is equal to 2g1 plus mu. Now they have asked in the question in GATE that what would be the value if Young's modulus to the modulus of rigidity ratio in terms of Poisson ratio. Simply what we have to do, we have to send this g to this side. So E by z, according to the question we got the ratio, the value would be 2 plus 1 to multiple 1 plus mu. So this is how you can solve question also related to Poisson ratio, and the formula it's said. So if you are prepared, if you are in plus 2, then it's okay, you can understand this one, that's enough for you, and you can remember one or two values. If you are doing engineering, then you need to remember all these values, because probably they can ask you question from these values only. And of course, relation among all elastic constant you need to learn. I have shared a different video in that, you must watch that video to understand its basic concept as well as few amazing things about all elastic constant and its relationships. I hope you understand the Poisson ratio and got something new from this video. Thanks for watching. See you soon in my next video. Bye bye. My dear, so in this video tutorial you are going to learn about a concept, the new concept which I haven't shared till now in my video tutorials. So it's all about, it's all about free body diagram. Probably you have heard this topic, that's why you have landed on this page, or maybe you have landed on this page really. Okay, I don't know how you have come to this page. So free body diagram, right? So what is basically free body diagram, you need to understand first. Second, you need to implement the concept of free body diagram in this numerical problem. Actually this problem has been asked in GATE 06 2006 for 2 marks, and I'm sure you know the value of 2 marks in GATE, right? So you don't want to lose marks, I think so, even 1 mark if possible for you to get it. So in this tutorial I'm going to share with you each and everything and the real concept to solve the problem quite easily. Okay, so all these things, these values are given in kilonewton. So because I don't get that much space here, that's why I haven't written. Okay, so let me use different pen. So what happened, we have to balance here all load, and compressive load is here, tensile load is here, we have to balance. And here we have given, this is P, it's not working, P, Q, R and S. Okay, so what we have to do first, for using the concept of free body diagram, we have to split all these three bodies. Now 3 parts are here, we have to split. So what I am doing, basically I am going to split this one. So PQ is here, another one is QR is here, hope you can see quite easily without putting effort, and this one is RS. So this one is the first part, this one is the second part, and this one is the third part. So before going to implement the concept of free body diagram, we have to separate all parts as possible for us. And in this question, what we have to find out, the value of stress in the QR. You should not forget that, right? So we have to find out the value of stress in QR. Maybe the black pen is not working, it's working. Okay, so what we have to do first, we have to find out the pinpoint thing. What is the meaning of pinpoint thing? That means we have to find out first one value only. If in the PQ, if this side is 63 kilonewton, that means in the opposite side, in the opposite direction, I mean if this side this direction, this side should be this direction, there would be same load will be acting. Are you getting my point? Now we have to see in the point Q, and in this space what is happening here, that in this direction we have 35 kilonewton load is acting. If we'll add these two, suppose that I am going to add these two, right? Q is the point. Without putting any load here, how much would be remaining here? 63 kilonewton. So what we have to do, we have to do something, we have to just minus this to get 35 kilonewton. Okay, we have to do minus something, that value, some value we have to minus from this value to get 35 kilonewton. So how much we have to get? 63 minus 35. So we have to do, we have to add 28 kilonewton in this direction, in the opposite direction of 63, to have if you will minus this, then what will have 35 kilonewton. That means if you add these two, part 1 and part 2, we will get that value 35 kilonewton. If you are not getting, then just repeat what I said. You will definitely get what I am talking. Once you understood this concept, then free body diagram is nothing for you. It's just like that. You can easily solve problem in this topic. It's really simple. Once you will understand the concept which I have just taught, if you understood it, you can easily solve the problem. It's quite easy, man. Now, after doing this, if it is in this direction, then there should be some opposite direction. The same load will be acting. Why it is happening? That's because of balancing. Without this, we cannot have this part. It may be thrown away somewhere else. It will maybe go into space if it will be more than the escape velocity, that is 11 kilometers per second. Okay, so we have done with part 1, we have done with part 2. Now from this only we can find out the answer. We can find out the answer because we have given the cross sectional area is 700 mm square. Okay, already given this and subjected to this, so we have to find out stress. Stress is what? Sigma is equal to force by area. What is force? What is the value of force here? 28 kilonewton, and area is 700 into 10 to the power minus 6. Yeah, you can see right now. So what is happening here? 28, you can see, yeah, 28 into 10 to the power 3 divided by 700 into 10 to the power minus 6. So how much values I am getting? Basically 40. After 40 we are getting 6 zeros. That means 40 megapascal. Just see the answer here. Yeah, C is the right answer. After doing this, you can mark the right answer, but because we are not sitting in the examination, so we will understand the whole concept. That's why you will not face any kind of problem. Okay, now just like here what I did, I am going to share with you the same step which I just shared with you here. If you did not get it right now, I mean in that time, right now just concentrate, pay attention and listen to me very carefully. Just right now what I am going to talk about this, what I am going to do here to make it like this balance. Now don't do anything, just add these two. After adding, what we'll get at this R 28 kilonewton, which is not given here, remember that it is not given here. It is here, if it is this side, now there should be some 49 kilonewton there should be. Okay, so how we can do that there should be 49 kilonewton. Okay, the direction is different. Yeah, this side only, the question direction is different. So there should be this direction, there should be 49 kilonewton would be acting, but here how much acting right now? If we add 28, so 28 plus how much will become 49? Simple, just like you were studying in class 6 or 7. So how much value required for that? It's 21 kilonewton. So after doing this, you don't need to think about anything, you just need to add this side only, because this side will be addition. So 29 kilonewton. Now add these two values, and for R what we are going to get? 28 plus 21, 49 kilonewton. Now after doing this, don't think about anything else. If it is compressive, just put it compressive 21 kilonewton. That's it. Now this is it. But one thing is, one more simple step I would like to share with you. Don't need to even do this step. Just look at here, how much is acting this side? 21. So definitely there should be acting 21 kilonewton. So that means what is the most important thing you need to find out here? We need to find out the value here. Once you did it, the problem has been solved. It's not that much difficult. Well, they in GATE I think they have asked right now in 2004 also they have asked the same question from this free body diagram. Well, I'm not going to repeat that question because that question is quite easy, and this one is also easier as I have shared with you till now, I mean in this video only. So this is really simple. Okay, so how to get all these things together in you, I mean how to get all these things, how to remember. The thing is that you need to know how to balance things. Once you will come to know how to balance, then it's easier, because almost everybody knows what is the formula of stress, what is the formula of strain. If you are going to write gate examination, definitely you know, I think so. Even 12th class student can tell you the formula of stress. But what make you difference from, what make you differ, or what make you out of the crowd, that is practice. If you will practice a lot the problem with by using the formula, you will have different concept to solve the problem. So this is all about practice, and of course the concept you need to have to solve the problem. I hope you understand something from this video. Thanks for watching. See you soon in my next video. Bye bye. Alright my dear, so in this video tutorial you are going to learn about ductile material and brittle material, and of course I am going to share with you few inside information about these two materials. That's why you can do much better. I mean you have better knowledge about these topics. So basically what is material, you know about it. It's all about structure and crystalline structure, non-crystalline structure, so which is having mass, shape, you can say that is known as material, and kinds of solid also. So if you're talking about ductile material and brittle material, so basically what are these two things? Basically these are two properties, of material. Okay, so these are two properties of material, while ductile and while brittle. So definitely there are examples of brittle material as well as ductile material, right? If you're talking about example of ductile material, then you can say that aluminium is a ductile material, mild steel is a ductile material, brittle material you can say cast iron is a brittle material. So this is about the example of ductile material and brittle material. So how you will come to know the material is ductile and the material is brittle? Of course from the nature you can say this is a ductile material as well as brittle material. But what is ductile material? Basically how you will come to know, that would be depend on strain. If strain is greater than 5%, about 5% you can say, then it is known as ductile material. If it is less than 5%, then it is known as brittle material. These two things are most important for understanding the ductile material and brittle material. Now if you're talking about application where we used ductile material and where we used brittle material, then this is really interesting. You must, I mean you will be wonder to know how these things are working. I mean how applications where we use ductile material, where we use brittle material. Suppose that we wanted to elongation, elongation work is required, just like wire drawing. It's an operation which usually probably or usually stated in manufacturing process MP, that in we know in short. And this is wire drawing. Suppose that this is a big wire, I mean this one thickness, and we wanted to decrease thickness of this bar drastically, just like any thread, then we can do the operation wire drawing, and elongation will be taking place, where that is then that material is known as ductile material. But if you're talking about brittle material, then this is different. If I'll talk about application of brittle material, then you will wonder to know, basically we use brittle material, you can say cast iron we used in case of propeller shaft. And why we are using this? Because the cast iron is having great compressive strength. cast iron is having great compressive strength, and because of this compressive strength we use brittle material. What is the meaning of this? The brittle metal is having very good compressive strength. Okay, so you come to know what is brittle material, you come to know what is ductile material, you come to know application also, right? So an example also, you come to know what are examples of ductile material, what are examples of brittle material. Now most important things, how these two materials, suppose that I'm taking cast iron and mild steel, how these two materials will work in case of stress and strain diagram. That means if we will draw stress and strain diagram, then how this materials diagram would be, that would be quite interesting to know, because stress and strain diagram is really useful, really helpful, and really important to understand the properties of the material, right? So let's go for it first. Suppose that we are going to draw a stress strain diagram here, sigma small strain for mild steel. Here we are going to draw this for mild steel, and here we are going to draw stress and strain diagram for, let's say, cast iron. This is a brittle material, I have already shared with you. This is a brittle material, and this is a ductile material, I have already shared with you, right? Now let's go for it, let's go for the drawing. Yeah. So in case of mild steel, the drawing is like this only. I'll let you understand what things are going on here. And in case of cast iron, it's like this only. This is a brittle material, and most of the brittle material having diagram like this, but in case of mild steel, this diagram is quite popular. The reason is simple, we can understand each and everything from this diagram. That means every point, everything what we require to know in case of stress and strain diagram. That's why I am sharing with you this mild steel one also. If you are studying any book, doesn't matter what book, I mean which writer book you are reading, you are definitely going to get the stress and diagram they have shown only for mild steel, because it will be quite useful for you. And most of the some common mistake we made, that is, if someone is talking about stress and diagram, usually we draw this one, but it's not the right answer, because every material is having different stress and strain diagram, remember that. So don't mix up with it. If you do mix up, then probably it will not be helpful. So try to understand the basic concept of every topic what you are understanding, right? So from here to here, I'm just going to, from A to A, O to A, suppose that it's, it's O to A, okay, A, it's O to A, it's the proportional limit, and till O to A Hooke's law is valid. And A to B, there is little bit, it is also elastic limit, and B dash, suppose that this is C, this is upper yield point, this is lower yield point. C to D, properly, so there is perfectly, you can say, elastic region is this, and this is the ultimate point. And from here to here, from D to E, it's the strain hardening, and this E to F, the necking region. After this point, beyond this point, the material will fracture for mild steel. And for cast iron, from here to here, after this point, the cast iron will not be, it will break, even you can say fracture or break, that is up to you what you want. So this is all about the ductile material and brittle material. Now most important thing, how these properties are very useful for you, how you can get from these properties. Suppose that you wanted to, let me share with you a few decent examples. Brittle material, also you can say glass. And how to remember what is brittle material, which is BR for break, which break easily. If you just drop from a little bit height, then definitely the material will break. That's why it is known as brittle material. The tile material, just opposite to it. So there are many properties of material, maybe let me share with you a few other properties, just like elasticity, plasticity, and then you can say hardness, toughness, as well as malleability, and then of course ductile, brittle. So these are all properties of materials. If you are a mechanical engineer or you are studying mechanical engineering, then you need to know all these properties. Just like let me give you an example. What is elasticity? Suppose that steel also is little bit elastic. If you will say which one is more elastic, steel or rubber, then I must say steel is more elastic than rubber. Plasticity, that means plastic deformation will be taking place because of the force acting on the body. Hardness, basically, it will resist body to not to be abrasion taking place on the surface of the body because of the load applied on that body. And toughness is something, ability to absorb energy in the elastic region is known as toughness. And malleability, that means the material is having very good machinability. That means after machining on the material, or on the on the material which is made up of malleable material, will after machining on the material, the surface finish will be just amazing. Malleability, if you are in manufacturing industry, if anybody is in your relative or in your known is in manufacturing industry, then you must ask him or her about malleability. You are going to get lot of inside information from that person. I hope you understand the trial material and brittle material, and of course its stress strain diagram, and of course the other properties of material. Well, I will make other separate videos on the properties of material. That's why I can share a lot of other things about it. I hope you understand the video. Thanks for watching. See you soon in my next video. Bye bye. So today in this video tutorial you are going to learn about Mohr circle. Well, I'm just sharing with you one thing. I'm not going to tell you its derivation because I already share with you derivation of Mohr circle. Today this video is totally dedicated to gate and of course how to solve numerical problems in this topic. So I'm going to share with you a few formulas as well as a concept which I have personally found after solving lot of problems in this topic. So basically there are two ways you are going to get question. Probably they are going to give you diagram like this, and probably they will give you direct values and you need to put that values in formulas to find out the answer. Okay, so this is it. Now if you'll get these values like this, then let me tell you one thing. This is sigma x, this one is sigma x, sigma y, tau xy. So if you get values here something, here something, here something, here something, then you can relate those values with sigma x, sigma y and tau xy. What are these things? Let me share with you. These things play most important role to find out shear stress as well as sigma 1 and sigma 2. So let me share with you both the formulas. There are three formulas basically, not two. That's why you can find out anything in the Mohr circle. Okay, so probably you also wanted to know that Mohr circle, right? Let me share with you. So suppose that this is a circle. Okay, this one is a Mohr circle, and suppose that this is sigma 1, this is sigma 2, and this is a mean, or that is sigma 1 plus sigma 2 by 2. And we can find out radius of this circle also, and this one is known as shear stress, and this one maximum shear stress, you can say this, right? So this is all about Mohr circle, but there is nothing, you cannot find out anything. You can just understand what is what is not. This is useful in the case of finding out derivation, but if you are talking about numerical problems and gate problems, then there are three formulas. For sigma max is equal to, tau max is equal to sigma 1 minus sigma 2 by 2. R is also known as shear stress. R is known as shear stress. So the formula for finding out R is sigma x minus sigma y upon 2 whole square plus tau xy whole square. So there are two formulas for finding out shear stress in case of Mohs circle. You should not forget this. And there are formula to find out sigma 1 and 2, because these two values, these two things are we are using here to find out shear stress or radius of the Mohs circle. Okay, so this is about it. Now sigma 2, how to find out this? Sigma x plus sigma y by 2 plus minus root under sigma x minus sigma y by 2 whole square plus tau xy whole square. Now right now probably you can wonder how this diagram is helpful to help you to find out sigma y, sigma x and shear stress xy. That's why I told you this diagram play most important role in case of Mohs circle. I hope you understand what I am talking about right now. So let's go to the problems. Those problems already asked in GATE. That's why you can understand what type of problems you can get in the upcoming examination. Okay, so let's go for those problems. Yeah, I got first problem is here, and what this problem said, let me just read. The state of plane stress at a point is given by sigma x is given, sigma y is given, and of course tau xy is also given. The maximum shear stress megapascal. So as I have already shared with you, first of all what you have to do, you have to find out what unit they have given and what unit we have to find out in the problem. That's why you will not make mistake in unit. As I have already shared with you, most of the student after knowing the problem they just go for it. They are in hurry, that's why they made mistake. I don't want any one of my viewers will make the same mistake as others are doing. So don't do that, don't be in hurry. So what you have to do, you have to be calm and give your 100% concentration while solving the problem as well as marking the right answer. So here what we have to find out, tau max, and I have already shared with you the formula for finding out tau max. Okay, that is tau max is equal to what? You can say that tau max is equal to, it's R is equal to sigma x minus sigma y by 2 whole square plus tau xy whole square. We have given all things. This R is radius of Mohs circle. As I have already shared with you, I am talking about today in this video only about Mohs circle. That's why I am sharing it all these. Okay, so sigma x is 200, sigma y is 100 by 2 a whole square, tau xy is 100, so it's square. What we got here from here, 100 by 2, so 50 square plus 100 a square. So 50 by square and 100, yeah, that's Mohs circle. Yes, of course. So we had here what we, sigma s, sigma y, and 200 and this. So it's okay. Now what we got, 50 square by 100 square. That's okay. So what we got here, 50 square plus 100 square, this much, divide 1 divided by 2, we got 111.80. we got 1111.80. so this is the example, I mean this is the we got the values that is known as 111.80 megapascal. So most probably this is the right answer, I think so. So we got the right answer is here 11.80. It's 118, right? So this is yeah, 11.80 is the right answer, right? Now let's go for the another problem. Yeah, we got this problem here, and in this problem what we are thinking that if the principal stresses in a plane stress problem are sigma 1 is equal to 100 megapascal and sigma 2 is equal to 40 megapascal, the magnitude of the maximum shear stress will be. So what we have to find out, we have to find out maximum shear stress in this problem. So what are maximum shear stress? Probably you know, I mean, if we wanted to find out tau max or r, sigma 1 minus sigma 2 by 2. So what is sigma 1? 100. Sigma 2 is 40 by 2. So 60 by 2 is equal to 30 megapascal would be automatically come. So the answer is 30. That is first option is the right answer for this question. And this question also asked in GATE, and this one is quite simpler than the previous one, so we don't need to take bother. I mean, quite easily you can solve these problems. Now what is most important here, what is most important here, that is then those things are here only, my dear. So what is important here, ki you need to understand this concept as well as these three formulas. Once you will come to know about these formulas, that these three formulas and this concept, then things become quite easier for you. I mean, you can easily solve the problem related to it. You don't need to take bother and you need to face any kind of problem. But in the previous, you know, in 2012, if I'm not wrong, what they did, I have already shared the question what I'm talking right now. What they did in GATE, they have relate Mohs circle and theories of failure to confuse students. So what you have to do, you have to understand interrelation between formulas to solve numerical problems in GATE, especially a GATE. Because in GATE what they do, they basically, especially in mechanical engineering, because in mechanical engineering we always study about physics, and in physics, you know, we have lot of numerical problems. So to solve numerical problems right away, we understand the formulas as well as few tips. That's why we can do those problems quite easily. I hope you understand something or you got something from this tutorial about Mohs circle. Thanks for watching. See you soon in my next video. Bye bye. Alright, my dear, this is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about superposition theorem. And as you know, this is a theorem which we study in strength of material. And if you are preparing for any competition examination, then probability of this theorem will come little bit less. But yeah, we need to understand this theorem, and of course the MCQ question can be asked based on its derivation as well as its concept, I mean definition. Based on its definition, you can say that. So basically, what is superposition theorem? This theorem states that the slope and deflection at any point is equal to algebraic summation of slope and deflection at that point due to all individual loads. This is the actually definition of superposition theorem. If you are studying in maybe +2 or 11th class, then this definition is enough for you to get 2 marks. Okay, but yes, if you know the concept, the real concept, and you know the most important thing, what is slope and what is deflection, also I am going to share with you. Because I have seen there are many those don't know even what is slope as well as what is deflection. And you know, there are other methods to find out slope and deflection. I'm going to share with you all things together in this video only. That's why you can get as much as information you can get from this video, and hope this video will help you a lot to understand all basic concept. as well as the derivation, and what I have stated in the in this definition you can easily also seen in the derivation. That's why it will be quite easier for you to understand, as well as you can do much better in the examination. So what I was talking about, what is slope and what is deflection. So what is slope basically? This is important. Slope and deflection both are different, that is for sure, and slope is denoted by theta and deflection somewhere this one or somewhere this one. Well, this is very from book to book. They wanted to make their things unique, that's why they do all things. Okay, that is different thing. Now, slope and deflection. So suppose that we are having a body, okay, I mean not body, it's a beam. So if I am putting a load here and the length of this beam is L, after putting load the length is just bending like this. So from here to here, this is known as, suppose that this is the total difference is delta x. So from here to here, this is known as deflection, and this angle is known as slope. So this is all about slope and deflection. Isn't it is simple, really simple, man. So now, if we wanted to find out deflection of beam, suppose that we wanted to find out deflection of beam, then how we can find out it? That is important. There are basically four methods. We have four methods to find out deflection. One is conjugate beam method, another one is double integration method, third one is strain energy method, and the last one I was talking about, moment area method. Alright, so these four methods are there to find out deflection of the beam. Okay, now I'm going to share with you, this is the little bit off with topic, find out deflection of beam. Okay, but this one is related to topic, that's why I have shared with you how many ways, I mean how many methods we have to find out deflection. Okay, so we have till now, what we have discussed till now: superposition theorem, definition, what is slope, what is deflection, and how many ways, how many methods we have to find out deflection. Okay, I hope you understand all these concepts. Now let's go to the derivation. So for this I have to go to the next page. Okay, so suppose that we have a beam, and there are, as you know, there are many types of beams, and here we are considering this beam is known as cantilever beam. Well, cantilever beam, I hope you know about it. What is cantilever beam? If any beam, one side is fixed and other side is free, that beam is known as cantilever beam. Okay, so suppose that we are putting load here W1, W2, and at the end W3, and this is A, this is B, this is C, this is D. Let me denote distance from here to here, suppose that A, from here to here, suppose that B, from here to here, suppose that we have C. Now according to theorem, what we have to do, we are just just separating all these loads. I mean we are just putting all loads individually. W1, that's it, plus W2, that's it, plus W3. At the end we are putting W3. Okay, so from here to here distance is A, and the whole distance, what is the distance, whole is C. From here to here it's B, and the whole distance is C, and here the case is different, C, and this is A, this is B, and this is U, B, C, D. So this is C, this is B, and this is D. So this is how we have separated all loads. The superposition theorem said that the summation of all individual loads will be the similar to that one only. That's why I did it. So addition of all these, the slope here because of these loads, and addition of deflection here because of these loads on this beam will be same in that case. Okay, so what we are going to do, basically we are going to find out theta 1. Theta 1 is equal to, we know that w1 a square by 2ea. Simply this is a simple concept of, in case of cantilever slope, is the formula for slope is this only. Now theta 2 is equal to w2 b square by 2ei, and theta 3 is equal to w3 c square by 2ei. Now total slope is equal to, slope total is equal to theta 1 plus theta 2 plus theta 3. That means w1 a square 2ei plus w2b square by 2ei plus w3 c square by 2ei. So 1 by 2ei w1 a square w2 b square w3 c square is the total slope for this cantilever beam. This is for total slope. Now we have to find out total deflection. So for finding out deflection, delta 1, suppose that delta 1 is equal to delta b from here to here deflection plus theta b, that means theta 1 into c minus its delta v, c minus, and distance is a. Okay, so the things will become p1 a to not p1, we have w1 a to the power cube 3ei, okay, plus w1 a square 2ei c minus a, because of this length is c minus a. Now delta 2 is equal to delta c, this is c, plus theta c, yani that means theta 2 into c minus b. So what we got here, w2 b cube 3ei plus w2 b square c minus b by 2ei. Now the next case is deflection 3. What is that? We have to find out that one also, w3 c cube by 3ei. So we have find out all deflection. Now deflection total is equal to deflection 1, deflection 2 and deflection 3. So we have to add all. Now after adding, just add like this, w1 a cube 3ei plus w1 a square 2ei c minus a plus w2 b cube 3ei plus w2 b square c minus b 2ei plus w3 c cube 3ei. So this is how we can find out deflection, total deflection and total slope of a cantilever beam, and how the superposition theorem has been proved through it. So this is all about superposition theorem and how we can find out slope and deflection, and how this is proven, how this method is proven for us. I hope you understand some basic concept of this theorem as well as what I have shared with you till now. So I hope you enjoy the tutorial. Thanks for watching. See you soon in my next video. Bye bye. So this is Ujjwal Kumar Sen, and in this tutorial we are going to learn about properties of materials. I hope you are excited and you wanted to learn about all properties. So there is no hurry. I am going to share with you. I am in hurry, not hurry. So I am going to share with you all properties of materials. So before going to share with you properties of materials, first of all let me tell you what is material. What is material? Which is having definite shape, size, mass is known as materials. It could be in liquid form also, right? Now and it can be also vaporization form also. So properties, basically what is properties, what are properties? Basically it's all about features. We are talking about features, characteristics of materials. So in this video tutorials, you are going to learn all characteristics, features of materials. So basically, there are many types of materials. So I cannot explain all types of materials here, but yes, I am going to explain all types of properties. Those are most important for you to learn. I hope you are going to enjoy all properties because I am going to give you some real life example in this video. Probably this video will be a little bit lengthy, so don't worry, keep watching. We'll learn a lot of things in this video. So first, elasticity. That means people said elastic properties. So basically what is elastic properties? This is one of the most common people, almost all people use this property in our real life, because we always use rubber band. We use most of the time, we use maybe for holding anything, maybe we for holding currencies also we use rubber, at least in India we used, right? So elasticity, this is one of the property. So what is this, what is about this property? And because of this property we have studied a lot of things. Well, I will go through all those things, but first of all let me share with you what is elasticity. Suppose that we have a body, and this body is fixed from this side, and we are pulling this body, and because of we are pulling, that means we are putting some force, and after pulling, the body's length has been increased here. And after increasing length, what we did, we just leave it as it is, we did not pull that body anymore. Then what happened, if the body is gaining its original position without any deformation, then the property of this material is known as, this thing is known as elasticity. Well, if we'll understand this in the technical point of view, see, I'm a mechanical engineer and I am sharing all these things only for mechanical engineering students. If you are not a mechanical engineering students, even then you can understand what I'm talking, and definitely you can get some in-depth concept, because studying materials all about material science, strength of material. We generally study all things in these subjects only. So if you're talking about to understand this in technically, then definitely we have to go through stress and strain diagram. Sigma is stress, small is strain. And if you are going through the mild steel, which is most common, people studied stress strain diagram for mild steel. That is one of the ductile material. So if you are going from here to here, and these all things are having, all points having different values. From here to here, Hooke's law exists. After from here to here, little bit deformation takes place. So this is from here to, when Hooke's law is exists, that means it is a elastic region. That means there would not be any deformation taking place in the material. So this is known as what? Elasticity of the material. You need to understand this, right? Now second, this is the property. And elasticity, if you will say which one is more elastic, I have two materials right now. One is rubber and another one is steel. If I will say which one is more elastic, steel or rubber, I have already shared in my videos, but again I am sharing because I don't know you have watched those videos or not, because this is one of the most important example to make you understand the elastic properties. So rubber and steel, which one is more elastic? Can you guess? Let me share with you. Steel is more elastic because time taking is also important. How much time is taking to gain its original position after leaving the body from load? That is also important. That's why steel is more elastic than rubber. I hope you got some inside information from here and here also. Well, second property, if I'm talking about, this is known as ductility. Because of this property, one of the operation we can do that is also important. Suppose that if you are familiar with electricity, then you have seen those small wires inside the wire, okay, and those wires can be made up of this operation wire drawing, and this is only possible because the material is ductility, ductile material. The material is ductile. If the material is quite good, quite ductility material, then we can do this operation wire drawing. Ductile material having one thing, having good elasticity, but after some time its plastic deformation takes place. Okay, it is having some, and as I have shared with you, ms is a ductile material, aluminum is a ductile material, you can say copper is also a ductile material, silver is also a ductile material, you can say that. So these are all ductile materials, and ductile material having this property, wire drawing operation we can do. This is known as ductility, and it is having its opposite to this property. One of the another property is brittle property. Ductile material having another features, that is it is having very good tensile strength. What is the meaning of tensile strength? Suppose that this is the body and we will pulling this body from both the side, it will just keep on increasing, it will not break quite easily. Yeah, of course it will break after a point, but it will expand after pulling both the side by using proper force. Now brittle, it is just opposite to ductile material. Ductility properties, then brittleness is brittle material is just opposite to ductile material. How? Now brittle material is having quite good tensile strength. Brittle material is having, what I am doing here right now, it's compressive strength. It is having quite good compressive strength. Quite good compressive strength is having. That's why we used brittle material. Example, cast iron is a brittle material, glass is a brittle material. That's why after falling glass from your hand on the floor, there is not even 0.1% chance that glass will not break. That glass will definitely break because of its property, that is brittle. But one thing is pretty clear, its compressive strength is quite good. That means definitely the application, there is some application where we can use this material, that is propeller shaft. If you are going to market, then you can see propeller shaft just below. In truck we use this shaft to transmit torque to the differential, okay, because that's why that car or that's a truck can move. So in propeller shaft we use this material cast iron, because propeller shaft required more compressive strength. That's why we used cast iron to make propeller shaft, which we used in automobile. So these all three are good properties of materials. Other than this, I will share with you plasticity. What is plasticity? Basically, I have shared with you elasticity. Elasticity is just opposite to plasticity. What happened after after pulling any body, if the deformation is permanent, that means after leaving the body, it will not gain to its original position. Suppose that we have body and we are just pulling this body, okay, for suppose that up to extend here, and whenever we are leaving, after leaving this load, it is not gaining the original position, it is gaining up to here. That means there is a plastic deformation taking place, and this deformation is known as plasticity. I hope you are getting my point. This is one of the most important, this is also one of the most important, because without plasticity we cannot do many things even, because wire drawing if you are doing, that is also plastic deformation is taking place. This is also known as permanent deformation, which cannot be regained automatically. This is one of the properties. So property number 4th I have discussed with you. Now 5th number property is toughness. This is probably, for many this is a little bit complicated, how to define this toughness property. But if you'll go through a diagram that is you know that is that is you know that is that what I can say, you will go to a diagram that is stress strain diagram, then definitely you can understand about this property. Because in this, according to this property, if you will say definition of this property, then I must say it is having, it is having capacity to absorb energy without fracture. What kind of energy? What kind of energy? That is important. Energy means some kind of load. If anybody is here and we are putting load, and we just putting putting load here, and this body is just absorbing load without any deformation, without anything, just absorbing load. There is nothing is happening in the body because of this load. That is known as toughness of the material. Okay, now next, malleability. What is malleability? Basically, malleability means, M for machine, and I must say machining. If any material having good machining property, that means after machining many materials surface finish is not good, because that material is not having very good malleability property. So for getting great surface finish, we can use malleable material which is having great machining property. That's why the material can be done any operation without any any bad surface finish on the surface. So basically this material is we used for good machining property. Okay, and this property having high degree of plasticity. I must say that this is a technical term, high degree of plasticity. You need to remember this also. So this is about malleability of the material. Now 7th number property, that is if you say strength. Well, I am teaching here strength of material. You must know what is strength. What is strength? Basically, if you say you are having very good strength, that means you are having capability to tackle anything. That means you are having very good strength in mathematics. You are having very good knowledge in mathematics. That means you are having capability to understand and solve mathematical problems. The same here in case of materials. If I am talking about strength in materials, so what exactly we do with materials? What exactly we do with materials? We used for any application. That means what kind of application? For most of the time we use material for load bearing application, where we required strength, load bearing. Okay, that maybe we are using in machine, maybe we are using in building, maybe we are using in automobile, anywhere. That because of this load bearing capacity the material is having, and how much load that material can bear, that object which is made up of different material, which material is bear, the material can bear, that is known as strength without fracture, definitely. Okay, the load can bear by the material without fracture, that is known as strength of the material. That's why many students face problem, even they don't know how to define strength of material. That's why I'm sharing with you, strength is also one of the property of material. Now last property I must tell you, that is hardness. And based on this there are many things we are doing. Basically BHN is most popular. There are other methods too, but BHN means Brinell hardness number. Okay, and we can say the material is brittle, and how much brittle, or how much not brittle exactly, the material is having how much hardness, or what type of hardness the material is having by looking at this BHN number. This is our standard form, and definitely we use most of the time in companies, that what type of material, how much hardness the material is having, how much hardness we required, and based on that we can solve problem in this. Okay, So what is hardness basically? Basically, suppose that we are having material and we are just impacting load here, and because of this impacting load, the material will resist for abrasion, or in maybe some part of this material will get erode. Okay, maybe erosion we say. So this will resist for erosion, or I must say not erosion we used in soil erosion, all that. If abrasion is the must proper word here. So metal is resist for against abrasion, that means material will be like this after even impactive. That property is known as hardness of the material. So there are 8 properties I have discussed with you within about 16 minutes. I hope you enjoy all properties and you understand all properties of materials. And what can I say? Thanks for watching and keep watching my videos. Bye bye. Hello my dear, this is Joel Kumar Sen, and today in this video tutorial you are going to learn about types of loads and beams. Well, I have already shared with you ton of videos related to shear force diagram and bending moment diagram, and I got overwhelming response from you guys, and thank you very much for your kind response. And because of that I got inspiration and cause to create more videos. Well, that is different thing. So come back to this tutorial, and in this tutorial I'm going to share with you types of loads and beams. That's why you can understand as well, you can visualize things much better way. I will try to make it happen for you. So what is basically load? This is important, right? What is load? uh, it's some kind of force. Basically it's Newton. It's you can say mass into acceleration. It's some kind of force that is known as load, right? When mass is multiple with acceleration due to gravity, that is known as mg, is also known as load. So load is sometimes we also called weight, force. These are 3 names, but most of the time, yeah, as I am making these videos, I am a mechanical engineer, and of course I am making these videos for mechanical engineering students and other students those are studying this topic too. So basically loads is something like force. It is acting on beams. That's why today's topic is types of loads and types of beams. So what we are exactly going to study, what type of loads can act on the beams, we are going to study. Are you getting my point? Basically, if you know shear force and bending moment diagram, if you have watched my videos, then there is nothing new here, because here only I am going to share with you very basic things about loads and beams, and very basic things you can easily understand from anywhere. Right? So basically, what are types of load? What types of load? Well, I hope you understand what is load. Then if I will ask what are types of load, then definitely you have to gone through all those loads. So first, second and third. First is point load. Point load. Second is UDL and third is UVL. If you are newbies, then definitely you are asking what the hell I am talking about. Actually I am talking about short form. It is having a long form also. This is known as uniformly distributed load, and its name is uniformly varying load. And point load is having another name that is known as concentrated load. Well, this is simple, you can easily get from anywhere, but what I am going to share with you, that is little bit difference. If you will read from anywhere, you can get this quite easily, but I am going to share with you what is exactly it, and how you can see, and where is the application of it, how you can see all these things in your numerical problems. I am going to share with you all those things. That is the difference. That will make you difference. That will make you know better things about this. Okay, that's why I have used that word visualization. I am going to make you visualize things here. So point load, what is point load? Suppose that we are having a beam. Well, I haven't shared with you till now what are types of beam. So suppose that we are having a beam, and beam is supported by 2 ends, and if there is a load acting on this beam just in a point, that is known as point load or concentrated load. If the load is uniformly distributed over the span of this beam is known as uniformly distributed load. If the load is varying from here to here, it is varying. I mean, here we have different load, here we have different load. That's why it is known as uniformly distributed load. So this is known as point load, this is known as UDL, and this is UVL. I hope right now you are getting my point, what I am talking right now. So this is all about types of loads. And you know what, if you wanted to learn SFD and BMD, then I have created ton of videos. If you already watched, that's great, but if you are newbie, then I will definitely recommend you to watch those videos. I think I have created around 15 videos in SFD and BMD. I don't know when you are watching this video, probably it will be increased, or definitely it will more than 15. Okay, so SFD and BMD, shear force diagram and bending moment diagram, if you are drawing, then you need to understand all these loads. These loads play most important role to draw shear force diagram and bending moment diagram. Okay, now okay, so till now what we have discussed here, what is loads, what are types of loads with the visualization. Now we'll go through types of beams. As I have shared with you, there are many types of beams. Yeah, definitely there are many types of beams, but what are types of beams, those you need to learn, right? So are you ready to learn all those types of beams? I'm sure you wanted to learn, right? So then what are you waiting for? Let's go for it. Well, I am waiting for something. You are not waiting, I am waiting. So let me use another color. That's why it will be little bit it will be funny and it will be enjoying for you. So color is different color will be very helpful for you. So types of beams. So basically there are many types of beams. So here I am going to share with you, there are 5 types of beams: first, second, third, fourth, and fifth. So first type of beams I'm sharing with you here, that is simply supported beam. Second, okay, before going to share with you what is simply supported beam, let me visualize you what is exactly. If any beam is support on the at the two ends of the beam, and these supports are not fixed, basically they're simply supported. Suppose that this is a beam and I'm supporting at the two ends. This is known as simply supported beam. Right? Now next is fixed beam. What is fixed beam? Suppose that there is a beam and both the end of the beams are fixed, is known as fixed beam. So this is fixed beam and this is simply supported beam. Now let's come to cantilever beam. So what is cantilever beam? Basically, let me share with you. Suppose that there is a beam and the beam, one side of the beam is fixed and other is free. One side is fixed and other side is free. That type of beam is known as cantilever beam. Another is overhanging beam. Probably you also wanted to know the example of overhanging beam. Suppose that there is two supports, okay, and there some part of the beam is hanging here also, and it could be like this also. This is also known as overhanging beam. It could be like this also, right? So all these examples are for overhanging beam. So this is the fourth one, and yeah, at the end of the video I am going to share with you what are beams are most important for numerical point of view, because this is a whole chapter, so you have to learn lot of things in this chapter. But definitely I am going to share with you what type of beams are most important for you if you are numerical point of view. Yeah, numerical. That means definitely you have to draw shear force and bending moment. So learn those topics, I mean these how to draw shear force and bending moment for any type of beam will be very useful for you for university examination as well as competition examination. I have seen question asked in GATE. I have also shared some videos related to it already. Okay, so yeah, let me use another yeah, okay, this one is quite good. So what I was talking about, the last one beam name is the last one with continuous beam. So what is basically continuous beam? If the beam is supported by more than two supports is known as continuous beam, but must not be overhang. If it will overhang, that means overhanging beam. So it will be like this. So this is known as what? Continuous beam. So what we have studied in this video tutorial, 5 types of beams, 3 types of loads. That's it. Now let me share with you one thing which is most important. What type of beams are most important for shear force and bending moment diagram? Here most of the students struggle, that's why I have created a lot of videos. I have already shared with you, but which beam is most important? Then let me share with you, my dear, there are only 2 types of beams, those are really important. First is simply supported beam, and another one is not this one, cantilever beam. I have seen 80% times question asked in university examination from these type of beams only. As per competition examination concern, then I cannot guess because they can give from anyone, but these two are really most important because most of the time the examiner asks question from here only. So I hope you understand something, you got something new from this video tutorial. Thanks for watching. See you soon in my next video. Bye bye. Kumar Sen, and in this video tutorial I'm going to share with you the shaft in series. What will happen when shaft will be in series? So this is a case of torsion, right? So in torsion we are having most important equation, and probably you wanted to know that equation, right? So that is T by J is equal to tau by R is equal to G theta by L. Well, what is T? Torque. J is polar moment of inertia. Tau is shear radius. Shear stress. R is radius. G is modulus of rigidity. Theta is angle of twist, and L is length of the shaft. This is all about the terms, and this is the equation, which equation we usually used 99.9% times in this subject, almost everywhere, almost every topic, maybe directly or indirectly. That's why I'm putting concentration here in this equation. So you have to remember this equation, and of course you need to remember also related terms to these equations. That's why you will not get confused in the examination. So let's go for the topic, which topic we are talking right now, that is shaft in series. So basically what happened, if suppose that a shaft is here, shaft 1 and shaft 2, right? So we are having 2 shafts. Suppose that both the shaft having equal length L, right? So that both the shaft of course in series. So what happened in case of if shaft in series, then torque would be same. That means if you say this is shaft 1 and this is shaft 2, then shaft 1 torque is equal to shaft 2 torque. This is for sure. But the main thing is where is the difference? Where is the main difference you can find out? How I mean what to do here then? If torque is same, what we can do here? That is, we have to find out total angular deformation or angular twist. That is theta total we have to find out. So theta total, to get theta total from this series of shaft, we have to find out theta for first shaft and then theta for second shaft. That is theta 1 plus theta 2. Get it? Now after doing this, what we can do? We have to go to this equation. Here what we can interrelate each other, what things we can interrelate with each other. that is this one and this one. So from this equation, what we can write, T by J is equal to G theta by L. Get it? I hope you are getting me right now, right? Pay attention what right now I am talking about. You are going to get this thing comfortably. This is really simple. Now, what exactly I am doing, I am trying to find out what would be the value of theta if I will do cross multiplication, or if I will do if I will simplify this equation. This is simple, right? So theta is equal to TL by JG. Suppose that I am talking about shaft 1, so theta 1 is equal to TL J1. I am just considering here, that G is same for both the shaft. Therefore, because same material we are considering, because modulus of rigidity is equal to shear stress by shear strain. So if we are considering both the same, then okay, it's okay, no problem. Then why I'm doing this? Because I wanted to make this equation simple, quite simple for you to understand. That's why you can understand it quite easily. Okay. Now what we got here exactly, if I will say for shaft 1 this is this, if then what would be the value for shaft 2? That is theta 2 is equal to TL J2G. This is for shaft 2, right? Now most important thing is here, you need to remember the formula for polar moment of inertia if we have circular cross section. If you can remember, or you remember the formula of polar moment of inertia for circular section, then the shaft in series, shaft in parallel, and all these things will become quite easier for you, because most of the time we are going to take a case of circular cross section. So you have to remember. We usually get numerical problems from here also. Later on I will discuss with you what type of numerical problem we can get in this. I have already shared couple of numerical problems related to gate, and yes, of course you can get some numerical problems too. Okay. Now theta 1 is here, theta 2 is here. So what we can do, theta total is equal to theta 1 plus theta 2. Then TL J1G plus TL J2G. Okay, just we have put the values of theta 1 and theta 2 here only. Therefore you got these. Now TL by G 1 by J1 plus J1 1 by J2, right? Now after then what we can do, TLJ 1 by J1 plus 1 by J2. Now we know that what is J1. Suppose that the diameter of the first is capital D and diameter of the second is small d. Then the polar moment of inertia for circular cross section is pi by 32 d to the power 4, because the diameter for the shaft 1 is capital D. I have already considered. Probably you have seen this before, what I have written right now. Okay. Now if we'll go to the next, that is J2 is equal to pi by 32 into d to the power 4. So this is J1 and this is J2. J1 and J2, right? So what we have to do right now, just we need to put the values in this equation and then simplify the equation. We will get the answer. Easy, right? Isn't it? Yes, of course. This is really quite easy, man, if you understand this. Now TL by G 1 by pi by 32 into d to the power 4 plus pi by 32 into d to the power 4. Then TL by G, it's 32 pi d to the power, so pi should be common, d to the power, okay, 32 can be also common. So 1 by d to the power 4 by 1 by d to the power 4. So 32 TL pi G d power 4, d power 4, d to the power 4 plus small d to the power 4. So this is theta total. If we have any connection in series, connection of shaft in series, then theta total is equal to, we got the value here. So this is the formula we have find out after the whole simple derivation, you can say, right? So the question I was talking about, that which is most important and generally asked in the examination, I must share with you in this video only. Well, before going to tell you that thing, just I wanted to know, are you getting my point, what exactly I wanted to make you understand? Because see, this topic is really simple. If you will go through Morse circle or probably shear force bending moment diagram, if you will not practice, then probably you will get confused in those topics. But here in case of torsion is quite simple, it's simpler, even it's simplest even in strength of material. So don't get confused what you are getting, just try to understand, then memorize it better way. So that's why it will be quite easier, quite understanding, quite beneficial, and quite useful for you for your future. Okay, now what exactly I was talking about, I was talking about the relation between these two formulas. I mean this one only. So what is that relation? I must share with you, that is T by J is equal to tau by R. Tau means diameter by 2, you can say, sorry, R means diameter by 2. So basically this is what, this is shear stress. So in torsion I have seen most of the question they are asking, find out maximum shear stress. So for solid shaft, maximum shear stress is equal to 16T pi d cube if the diameter of the shaft is capital D. Just like the same what process I have used here, you can use the same process and you can find out the value of tau, shear stress, from this equation only. I hope you got some inside information about shaft in series in case of torsion. Thanks for watching. See you soon in my next video. Bye bye. My dear, so in this video tutorial we are going to talk about one of the most important topic, probably because of that you have landed in this page. So what is resilience? Well, this is one of the important term I have already shared with you. But if you're talking about resilience, then it's related to it's related to strain energy. Strain energy. It is denoted by U is equal to half T theta. Okay, so this is the formula for strain energy. Almost all books, or I must say that there are many places I have seen this. They are using, they are writing this formula, that is strain energy equal to half T theta, right? Somewhere they also use the they are using torsion equation, that is T by J is equal to G theta by L. So theta is equal to TL GJ. That's why you can write this T square L by 2 GJ. This is also can return the strain energy is this. Okay, but what is resilience basically? That is I haven't clear till now. Don't worry, in this video we are going to learn about resilience, proof resilience, as well as modulus of resilience. So what I'm talking about, proof resilience, third option, first is this, second this, and third is modulus of resilience. So three topics we are going to discuss in this short video. So basically, what is resilience? To understand resilience practically, we need to understand the stress strain diagram. Suppose that I am considering a material that is MS for mild steel, and I am drawing a stress strain diagram for MS. So the drawing would be like this. Probably you have this is a fracture point. So this from here to here, suppose that this is O, this is A. O to A, Hooke's law is valid. That means this is within the elastic limit. In the elastic limit. Okay, that means if till this point if we'll remove load because of this elasticity the shape of the body changing, then definitely the body will regain its original shape. That is known as elastic limit, right? So resilience state that strain energy, let me write first, that's why you can understand. Strain energy absorbed in the elastic region or elastic limit is called resilience. This is exactly called resilience. You know, I have seen most of the interviewer ask this question to mechanical engineers, what is resilience basically? But I bet you nobody is going to ask you this concept because this is in depth. I mean, this is under resilience what right now I'm talking about. This is just to understand what is exactly resilience practically. You need to understand first stress strain diagram. Now probably you are getting my point that how stress and strain diagram is useful to understand things much better way in strength of material. Are you getting my point? I hope you are getting. I'm not serious, I'm just making you understand what exactly I'm talking right now. Okay, so this is all about resilience, and I have already shared with you what is strain energy. It's some kind of energy also. Okay, so this is all about resilience. Let's come to proof resilience and modulus of resilience. These two topics are also interesting. I hope you will enjoy these topics too. I'm just going to share with you. Okay, so let's talk about proof resilience. Proof resilience. So here is the proof resilience, right? So if you'll go through definition, it states that maximum strain energy absorbed in the elastic limit or region of the material or shaft, you can say, what you are using, that is known as it is known as proof resilience. This is the proof resilience. Got it? So maximum strain energy, what is the meaning of this? Everything is clear. What I have shared till now, it is simple elastic limit what I have shared. But what is maximum strain energy? That means if you are seeing elastic limit, I mean till the elastic limit, how much the maximum energy material can absorb. How much maximum energy material can absorb. That is known as maximum strain energy. So if we'll see the difference in the definition of resilience and proof resilience, there is only one word difference. That is, here we are writing only strain energy in case of resilience, but in case of proof resilience we are writing maximum. Just one word changing the changing the name of the definition, for which the definition is that's because of one word, that is maximum. So don't forget this maximum. If you will understand, if you remember this maximum, then you can remember and you will have this what is proof resilience. Are you getting my point? Basically, I hope you are getting me, because I am telling you something, indeed, and some undercover information about resilience. Okay, so if you want more thing, I want your favor. If you are liking these videos, then please share with your friends. I want everybody to enjoy all mechanical engineering subjects. Okay, so this is the reason to make all videos and help you guys to enjoy, and definitely I'm sure I'm going to create more videos related to life. That's why you can do much better in your life. You can do, you can get success just like that. You will not have to be panic. You will be happy to have my videos and have information what I'm sharing. Well, that's not enough talking. Let's come back to the topic. What I'm talking about, what the topic is left, that is known as modulus of resilience. What is it? Modulus of resilience. Now I have shared with you difference between proof resilience and resilience, and in this here I'm going to share with you exactly what is modulus of resilience. So basically these three are interrelated to each other. So the definition is here. Proof resilience per unit volume is called modulus of resilience. Simple. So as you can see, proof resilience is related to resilience. Modulus of resilience is related to proof resilience. Okay. Now, what is the formula of this modulus of resilience? That is also interesting to know. That is, would you like to know? I think so. You wanted to know, right? So, modulus of resilience is equal to, let me use different color pen, that is sigma E square by TL. E for elastic, or ER, elastic region I can say, or elastic limit you can say. Okay, that is different thing. I mean, that is depend on your understanding. So sigma E elastic region is square by 2E. Okay, so E means elastic region, so stress in the elastic region by 2E. E means Young's modulus. So this is all about, where is that page I have all about what resilience, proof resilience and modulus of resilience. I hope you have enjoyed the tutorial, you understood the concept of resilience and other two, and sure, definitely don't forget to subscribe this channel and don't forget to share this video with your friends. Thanks for watching. See you soon in my next video. Bye bye. So, this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about derivation of bending equation. That's right. So basically, before going to share with you its derivation, really simple, it will take not even 10 minutes to learn, but I'm going to share with you few assumptions of bending equation before going to share with you derivation. First is the material we are going to consider for driving bending equation, that should be homogeneous, and of course isotropic, homogeneous and isotropic. And second, it must obey Hooke's law. Third, I must say that its cross section will not change frequently. Cross section will not change frequently. Fourth one is the most important thing, that is the beam must not twist while loading. You can say that must not twist while loading, right? So these are few assumptions. Well, other than this, we can assume things also, but yeah, one more assumption I must say, that this is just like Hooke's law, elastic limit. The beam must be in elastic limit, so it's about Hooke's law only. So these are major assumptions of bending equation. I mean, for deriving bending equation, the beam must follow this thing. I mean, the beam must be follow this number. Beam must be Hooke's law, follow obey Hooke's law, and the beam must be homogeneous and isotropic. Its cross section will not change frequently and must not twist while loading. So these are assumptions, just like. So now what we are going to do, we are going to derive the equation. Okay, so here is the equation for bending equation. Okay, suppose that we got it here and that pen is not working. Yeah, so this one we got this line, and okay, suppose that this one is it, and okay, this one is the line, this one is the line, another line is here, another line is here. Okay, so let's say this is a dash, b dash, this is a, b, this is c, d, this is e, f. Okay, so we are getting this a dash, b dash because of compression. Suppose that e, f is the this is the simple line. Okay, this is the neutral line, you can say. This is the line, this is the position of the beam when it is not loaded. Then AB is the intention, and we are getting this as a line. Through this line we will drive the equation, just like so. From here to here we are saying it's R, its angle is d theta, and from here to here we are saying the change in length because of this beam, that is y. So it is touch with here. Once you will understand this diagram, once you will come to know how to draw this diagram, it's really simple, you can see here. Then what you have to do, you have to go through a simple formula that we have studied in class 10th. D theta is equal to L by R. So here what is R? R is equal to capital R. DL is equal to, here we are considering DL is equal to EF. So we can write the same equation, that is d theta is equal to EF by R. Then we can also write EF is equal to R d theta. Sorry, EF is equal to R d theta. Simple. Now one thing is clear there, that if because of somehow load, if its radius is changing from here to here, that means we can say this, that what is happening here, basically what is happening here, it's because of loading, its radius is changing, right? So we can say this as that d theta is equal to CD by R plus Y. We can say this. Now what will happen, CD is equal to d theta R plus Y. Okay, I hope you got it. Now we got two equation 2 and equation 1. Now what we are going to do, we are going to just subtract from equation 2 minus equation 1. Now what we got, CD minus EF is equal to d theta R plus y d theta minus R d theta. R d theta get cancelled. Now what we got, CD minus EF is equal to y d theta. Okay, now if we'll divide this by EF, and I will also divide this EF, then we can say that from this equation what, that d theta by EF is equal to what, 1 by R. If I'll do cross multiplication, then we can say that y by R. Okay, because here d theta by EF is equal to 1 by R. So what we did, in place of this we have put this value. So what is this basically? This is a strain, change in length by original length. This strain is, why this strain is happening, because of some kind of load. Now as I have shared with you in the beginning of the video, that we have to assume that this beam must follow Hooke's law. So if it is following Hooke's law, it is also telling that within the elastic limit, and I have also said that the beam will be in elastic limit. Okay, beam will be in elastic limit. So within the elastic limit, stress is directly proportional to strain. So it should be proportional to 1 by R, because here strain is equal to y by R, and stress is sigma. Sigma is equal to Ey by R. So we can say that sigma by y is equal to E by R. from here we can say that sigma by y is equal to E by R. So one part of the equation we have been derived till now, and probably you know the bending equation which is most useful, that is sigma by y is equal to E by R we got till now. Okay, now what we have to get the another part of this equation. What is that? Let me share with you, just keep moving. So I have to get the another page. Okay, yes, now what exactly doing, we have to find out moment of resistance, and for this we have to take a neutral axis. Suppose that it's AB, and we have to take a part, a single cross section part, and its distance from here to here is y. Let's say that's, and distance, this is happening because of because of it's changing length. Okay, so that's because of happening, I mean it is happening because of that only, changing in length. Okay, now what we'll find out, moment of resistance, that is m, we have to find out, because till now we have find out one of the relation. Now we have to find out the other relation which is also important. Now what we got till now, sigma by y is equal to E by R, right? So what you know, moment of resistance, we know moment of resistance is equal to y sigma dA. Now we can write sigma is equal to y E by R. So y into y E by R into dA. So y E by R is constant here, y square dA. Now we can say y square dA, what is this? Is cross section area, this is a change in its length, you can say that. Okay, so y square dA means m to the power 4. M means meter. That means this is moment of inertia, and this is m. So we can send this I to this side. So m by I is equal to E by R. And from this equation we know that E by R is equal to sigma by y. So this is the, what is this? This is bending equation. So it took only about 9 to 10 minutes to understand its bending equation. So what's important, let's revision this, and we'll end up here. So what we got here, m by I. So sigma y is equal to E by R is equal to m by I. So this is the relation which is bending equation. And most important thing what I was sharing with you, most important thing is diagram first, second these assumptions, because without assumptions you cannot derive the equation. So this is all about bending equation. I hope you understand now. It is not going to trouble you anywhere, I hope so. I can only guess that. Okay, so what you are thinking about this bending moment equation, just let me know through comment. Thanks for watching. See you soon in my next video. Bye bye. How are you? So in this video tutorial we are going to learn about torsion equation. Don't worry, you can easily see I got very good camera, right? So torsion equation derivation you are going to learn today in this video tutorial only. So let's get started. So before going to start, let me draw a cylinder, right? Because this is important. Without this diagram it's like impossible to share with you torsion equation. So what exactly I am doing, one side this is a cantilever cylinder, you can say that, and one side is fixed and other is free, that's why it is known as cantilever. So this is let me just fix this. This is it, and let me do a little bit this angle. Suppose that its radius is R, and this should be circular, right? And this is R, and let me show you, this is, suppose that the angle is theta, and this one is A, this is B, and this is C, and here angle is gamma. This gamma is known as shear strain. Length of this cylinder, suppose that L, right? Now we have done with the diagram. So what we required right now, that is important. Assumptions. What are assumptions we have to consider for doing derivation? Assumptions play most important role. Okay, so first assumption is the material we are using in this cylinder should be homogeneous. It should follow Hooke's law, right? And third assumption, which is most important, circular section must be circular for the whole path. I mean, from here to here the section must be circular. So these are three most important assumptions. Okay, based on these assumptions we are going to derive the relation of it, right? So first of all, we have to use one of the most basic formula. Probably you have studied about that formula in class 10th, that is arc is equal to radius into angle. So here arc is BC, first equation. Again we have arc BC is equal to the shear strain into L, equation 2. This is the 10th class concept, and we also know this by popular equation, that is equal to theta is equal to L by R. Okay, so probably that is depend on you how you are taking this equation. Okay, so that's it. Now from these two equation we can say that R theta is equal to gamma into L, and we can also say this R is equal to gamma is equal to R theta by L. We can also say this. Let's say this is equation number 3. Now let's come to the most common thing, that is modulus of rigidity, that is denoted by most of the book denote, or most of the time we have studied modulus of rigidity is capital G. So what is basically capital G? That is ratio of shear stress by shear strain. It is the ratio of shear stress by shear strain. So shear stress is denoted by tau and shear strain is denoted by gamma. So from this what we got that, and we can also say this shear strain is equal to tau by G. Okay, now let's say this is equation number 4. Now see equation number 4 and 3, what we can say, R theta by L is equal to tau by G. What we can say, R theta by L is equal to tau by G. We can do little bit cross multiplication. R should be here and we'll send this G to here. So what we'll get now, tau by R is equal to G theta upon L. Okay, so what is our main motto? That is also important, right? What is our main motto? That is also important. Once we come to know what is our main motto, then things become quite easier, because our main motto to get equation is what we got, tau by R equal to G theta upon L is equal to T by J. So this is our ultimate equation. What we got till now, tau by R equal to G theta by L. That means half of the equation is done. So for deriving torsion equation, we have to consider a circular cross section. Just I am going to share with you in the next page only. Don't worry, you will understand each and everything what I am sharing with you. So first of all, draw a circular cross section. This is circular cross section, and suppose that this circular cross section having its little cross section diameter and cross section radius is dr, and from here to here it's a dr, and here shear stress is acting tau, and here also shear stress is acting tau. I can say this, right? Now we can say that force on each element is equal to what we can say that force is relation between force and stress is equal to force by area. So here what exactly force is acting, that is shear, what is force based on the shear stress. Shear stress upon area. Shear stress is denoted by tau, and area of this is 2 pi r dr. Approximately we can say this is the area of it. Now what we can say, because of this force there will be produce moment about the center of axis of the shaft. Okay, therefore what will happen, tau 2 pi r dr multiple r. Therefore we can say that 2 pi tau r square dr. Okay, now what we can say, we can do integration to find out total torque. Total torque, let's say denoted by capital T. So 0 to r 2 pi tau r square dr. Now we know that one thing is clear from here, that is tau by r is equal to g theta by L. Therefore tau is equal to g theta r by L. Okay, so this is r. Now what we can say here, from that equation we got that. Okay, so what we can do it, because one thing is here, we need to understand this, right? So basically what happened here, I have taken this capital R. Okay, so I can do one thing, I can just consider this as small r, because I wanted to share with you this one. So small r is here, so we can say this, right? Now what happened at the, I have shared with you that thing, that's why probably you got confused, that's why I have shared with you. Okay, so this is the relation we can also write. Okay, so small r and capital R same here. Okay, so what we can do, we got this here. Now we have to write this here also. Okay, so 0 to r 2 pi g theta r by capital L multiple r square dr. Now let's just got all these constant values outside. So 2 pi g theta by L 0 to r r cube dr. Till now I hope you understood, right? Now from integration what we got from here, 2 pi g theta by L r to the power 4 by 4 0 to r. Okay, let me use, okay, you have noted down all these. Okay, don't worry, we'll use another page, that's why you can understand, right? So for is equal to what we got here, 2 pi g theta by L r to the power 4 by 4 minus 0 to the power 4 by 4. What we got here, 2 pi g theta by L r to the power 4 by 4. T is equal to this. Okay, now 2 pi g theta by L, let's say r is equal to d by 2. So d by 2 to the power 4 by 4. So let's say 2 pi g theta by L d to the power 4 multiple 16 to 8. Okay, so 2 8s are 16. So pi g theta by L d to the power 4 32. Okay, so we can say that g theta L pi d to the power 4 by 32. Okay, now one thing we can do here, that is we know that J means polar moment of inertia is equal to pi by 32 d to the power 4 for circular section. Okay, so we can write this in place of this as J, right? So g theta L multiple J T is equal to this. Now we can send this J to this side. So T by J is equal to G theta by L. Let's say this is equation number, which one? We have already done with 4. So 5. Okay. So now let's come to here. From this equation and from this equation, what we can write? T by J is equal to tau by R is equal to G theta by L. And this equation is known as, hopefully you know, torsion equation. Let's say it's my small r. So T by J tau upon R is equal to G theta by L. This is known as torsion equation, and this is the derivation of torsion equation. I hope you understand the derivation, and hopefully you can do better in the examination for what you are watching this video taught well. Well, thanks for watching, and if you got help from this video, I will ask for your help to share this video with your friends. That's why who need this video tutorial the most. That's why they will also get something from this video tutorial. Thanks for watching. See you soon in my next video. Bye bye. This is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about Mohr circle. I know most probably you have why you have landed on this page that this circle is this, that, and difficult to understand all that. So in this tutorial you are going to learn about how to derive Mohr circle quite easily without getting any problem. So let's get started, right? So basically, who is the person? Let's talk about who is the person behind this Mohr circle. Name of that person is Christian Otto Mohr. The person behind this circle is Christian Otto Mohr. He was a civil engineer, and actually, if I talk about his hobbies, to play with graphical things. That's why he found this graphical method for finding out principal stresses. Are you getting my point? Right. So what basically we are going to find out by using this circle, that is sigma 1 and sigma 2. Yeah, so because of this method, this is a graphical method. I mean, this method is different than other method, and this is comparatively easy for designer to find out principal stresses. That's why this method is quite popular, right? So basically he is German engineer. I must say that, must give credit to him, because he has provided us such a system, I mean such a circle. That's how we can find out principal stresses by using this graphical method, right? So what we are going to basically find out in this tutorial, that is sigma 1 and sigma 2. So this is a derivation tutorial. If you wanted to watch any numerical problems, all that, I have also uploaded GATE numerical problems. Those are quite good, I must say that. So let's go for the diagram first, because it's a graphical method, right? So what is my suggestion to you? If you are watching this video, that means that's good, that you wanted to learn about this circle, but you can make it more effective. How? Let me share with you. Just take a pen and a paper and start doing what I am doing. In this way, what will happen? Your efficiency of knowing the things will be doubled. That's why I'm sharing with you. This is my personal experience, right? So what we have to do, we have to pause this video and bring some paper as well as pen, right? So this is a circle, and just we are going to put few things inside this circle, and it will happen. That means this will become more circle, right? So I'm just drawing, and if you got pen and paper, just keep drawing, right? So after drawing, you can easily understand what is going on here. So let's say x dash and y dash, right? Now what I am going to do, basically I am just going to put some numbers or letters. That's why it would be quite good for us for denotation of the things, right? So this is D1, this is D2, this is O, this is C1, this is C2, this is theta, right? So there is this at this stage we don't need to use that theta, right? So sigma y, and this is sigma x. All right, and I have to give two other things. Those we have to find out, that is principal stresses. So this is 2, they'll say, and this one is sigma 1. All right, So these are all things you need to remember. Yeah, other than this we have to remember this is C2, this is C1 also, right? So now if you can remember this diagram, then I am 100% sure you can derive the equation quite easily. You will not face any problem. I mean it will take very less time to know and to derive this equation, right? So let's get started. What we have to do, basically we have to choose few things from here. Alright, let's say this is OC1 and OC2, right? Both are same because I have divided on the mid. So we can so we can say OC1 is equal to OC2. Now look at the OC1 and OC2. If I will do sigma x minus sigma y, sigma x minus sigma y, it will remaining part would be C1 and C2. So if I divide by 2 sigma x minus sigma y, then it will become either OC1 or OC2. Are you getting my point? So sigma x minus sigma y 2, sigma y by 2, we got this value. In the upcoming parts we will use this thing. I mean definitely you will come to know about it, right? So let me use another color marker. Yeah, now let's go for the next part, that is AO, right? So what is AO? Basically AO is equal to, we can say AC2 plus OC2, AC2 plus OC2 is equal to, AC2 is sigma y, OC2 I have already find out, that is sigma x minus sigma y by 2. So if I will do simplification, then 2 sigma y plus sigma x minus sigma y, so it's 2 sigma y, yeah, sigma x plus sigma y by 2 is equal to AO. Got it? Now we'll look at the triangle here, triangle OD1 and C1, OD1 C1, and from this right angle triangle, this is the right angle triangle, we can say that according to Pythagoras theorem, OD1 is equal to root under OC1 square plus C1D1 square. Alright, OC1 square plus C1D1 square. Now what we have to do, basically we know that OC1 and C1D1 square. Okay, now what is OC1 here and what is C1D1? Let's look at this. We have already find out OC1 is equal to sigma x minus sigma y by 2. So write that sigma x minus sigma y by 2 whole square, and C1D1 is a shear stress tau xy. So this is tau xy whole square. So we got this, what we got right now, OD1, that is OD1 we got. Again from this diagram we can say that OD1 is the radius of this circle, is equal to OE, we can say that, is equal to OB also we can say that, because all are radius of this circle. Alright, so from here also we can say that from here to here, let's say AE is equal to what? AE is equal to, we can say that AO plus OE, AO plus OE. Alright, AO plus OE is equal to AE. Now AO is what? We have already find out AO is equal to, you can see here, AO is equal to this. So we can write sigma x plus sigma y by 2, and OE is what? OE is equal to OD1. So OD1 is equal to what? We have already find out this. So sigma x minus sigma y by 2 whole square plus tau xy square. So what is this? This is a maximum principal stress, you can say this, right? Because plus is here. Now we have to find out, that is AE is what we have already taken, that is sigma 1. AE is equal to what? Sigma 1, and this is maximum principal stress. So formula for finding out maximum principal stress, sigma 1 is equal to this. We have already got it. Now what is remaining, that is minimum principal stress, which is denoted by sigma 2. This is minimum principal stress, and this is maximum principal stress. So what we have done till now, we have find out maximum principal stress. We have to find out this one, minimum principal stress. Now let's go for this formula. I mean, look at this diagram only. From this diagram alone you can understand what is minimum principal stress. That is what we have to find out, sigma 2, that means AB. Now we have space here, right? So now from here we can say AB, sigma 2 is equal to AB, right? Now what we can write, AB is what basically? AB is what? AO minus OB. AO minus OB is equal to AB. So AO minus OB. AO minus OB. So what is AO here? AO is here. AO is here. So AO already I have find out what? Sigma x plus sigma y by 2. Sigma x plus sigma y by 2 minus OB. We have what find out here? OB is equal to OE is equal to OD1, and OD1 is equal to what? This value. So what we have to do? We have to put this value here only. So just do it. Sigma x minus sigma y by 2 whole square plus tau xy square. This is in root only. Okay, this is in root. So what is sigma 2 basically? That is sigma x plus sigma y 2 whole square. This is root. Okay, this is root. So don't make mistake here. So we can say that, let me write properly, that's why you will not make mistake. Sigma 2 sigma x plus sigma y by 2 minus root under sigma x minus sigma y by 2 whole square plus tau, that is shear stress, tau xy square. So this is what? This is a formula for finding out minimum principal stress. So this is all about the derivation of Mohr's circle. I hope you understand it, and if you are getting any problem regarding any circle or anything else, you can just share with me. I will try to make a video on that, and definitely I will try to share with you, and that would be, I hope, these solutions, these videos helping you a lot. So don't forget to subscribe my channel, and of course don't forget to share with your friends, that's why they can also enjoy my tutorials. Thanks for watching. Thank you very much. Bye bye. Hope to see you again in my next video tutorial. Alright my dear, so in this video tutorial we are going to learn about volumetric strain. As you know, this is one of the important topic, and probably you have gone through questions, those has been asked in GATE. Yes, so definitely I will share with you that question which has been asked in GATE in 2007. You will definitely have some concept on that. So basically, before going to share with you what is volumetric strain, let me share with you what is a strain basically. So if you will go through the simple definition of strain, then it's change in length by original length. Change in length denoted by delta L, it's L. Suppose that it's in L. So this is the simple definition of strain. And what is this change in length, what is original length, I hope you understand. That's why you are here on this video, to learn volumetric strain. So I'm not going to tell you what is that, this and what is that. Now probably you also know what are types of strain. Basically there are three types of strain. One is lateral, another one is longitudinal, and the last one is lateral strain, longitudinal strain, last one is shear strain. These are very basic types of strain, but whenever it comes to volumetric strain, it little bit difference. There is little bit difference. Okay, so why volumetric strain is known as volumetric strain, that is also important. All these strain are in one direction only, maybe x, maybe y, maybe z. Alright, but this one is happening in all direction. Suppose that we are having xy direction, but I am taking here a 3D object. Okay, so definitely it is y, definitely it is x, and definitely it is z. If the shape of this object is happening three-dimensionally, then definitely we can find out volumetric strain of this object. Are you getting my point? Now what is basically volumetric strain, we need to understand. That is also important. So volumetric strain is something which changing in volume, change in volume by original volume. So we denote volumetric strain small e v, change in volume delta v by original volume is known as volumetric strain. Are you getting my point? Probably you are getting. So this is the volumetric strain, but here what is it and what is this? What is the change in volume and what is the volume? That is also important. All right. Now if you'll go through the derivation of A, this one is basic, but if we'll go through derivation of A, then I must say Ex plus Ey plus Ez. This is the definition. I mean, strain in the x direction, strain in the y direction, strain in the z direction, and adding all these strain becomes volumetric strain. So if we'll add strain, what is strain? Sigma x by E plus sigma y by E plus sigma z by E into 1 minus 2 nu. After derivation we got this value. I'm not going through the derivation what you should have to do, because that will be quite lengthier. You can read from anywhere, from any book, but I am sharing with you the main concept of this volumetric strain. After this, what happen if, okay, we can write this equation like this: sigma x, sigma y, sigma z by E 1 minus 2 nu. Okay, now if all stresses are same, sigma x is equal to sigma y equal to sigma z is equal to sigma, then what happen? What we can write? Sigma plus sigma by E 1 minus 2 mu. That means 3 sigma by E 1 minus 2 nu. So this is all about it and what we can do. So what we got here, 3 sigma by E 1 minus 2 nu. Okay, so basically probably you have, if you gone through some books or maybe some problem, you have seen this. But there is a case where sigma x is equal to sigma y is equal to sigma z. All these stresses in all direction would be same in the case of hydrostatic loading. Remember that this is important. Probably, this is important, I must say, this is important. Probably you can get question in case of hydrostatic loading, what will happen to the volumetric strain. Probably you can get question in this topic, so we should not forget. Okay, now this is the formula. This is it about all volumetric strain and all that. But if you are learning, if you are preparing, or if you wanted to get a previous year question which has been asked in GATE, then I must share with you that question. Well, I haven't written that question, but that question is right now in front of me, so I can share with you, I can read, and you can listen to me carefully. In this question, what is stated that there is a steel block of 200 by 100 by 50 mm. Okay, this is a steel block of this is subjected to hydrostatic pressure. P is equal to 15 megapascal. Okay, the Young's modulus and Poisson ratio of the material are 200 gigapascal. Poisson ratio, Young's modulus E, and Poisson ratio mu is equal to 0.3. The change in length and change in volume of block in millimeter cube. So option A, B, C and D, we have to go through all option. 90, B is 85, C is 110 and D is 100. So this is the question we got, and what we have to find out, the change in volume of the block. Change in volume we have to find out. What we have to find out from this question, that is change in volume. So how we can able to find out change in volume from the question, that is also important, right? So we have the question and we have the formula for finding out volumetric strain. EV is equal to what? EV is equal to, we know that 3 sigma 1 minus 2 mu, 3 sigma 1 minus 2 nu by E. Okay, so here what we got basically, volumetric strain is equal to, also we know this, change in volume by volume. But what we have to find out basically in this question, change in volume, that is delta V. I hope this you have gone through, I mean the question you understood, right? We have to find out delta V. So that means delta V, volume into 3 sigma 1 minus 2 mu by E. This is the formula for finding out this. I mean just I have sent this V to that side by using cross multiplication concept. Now what is volume basically here? 200 into 50 into 10 to the power minus 9. Okay, this because this is okay, I'm not using minus 9 because we have to find out this would be in mm, but I had to change these two in mm. Megapascal means automatically this is in mm. Okay, now pressure is this, that means we can use this as a stress. So 3 into 15, 1 minus 2 mu is 0.3 by E 200 gigapascal means 10 to the power 9. That means we can do like this, multiple 10 to the power 3, because here let me understand you, giga means 10 to the power 9. So 10 to the power 3 into 10 to the power 6 we can write. So 10 to the power 3 mega, because 10 to the power 6 is equal to mega. That's why I did it here. Now what we require, my dear, I think we need a calculator for calculation. So what we got here, 200 multiple 100 multiple 50 multiple 3 multiple 15 into 1 minus 0.6, right? 2 and 0.3 is at 0.6. So how much we got here? This much. 200 into 10 to the power 3, 90. So what we got value here, 90 millimeter cube. If you have gone through the question, then probably you got the answer, which one is the right answer, that is 90. Okay, so I hope you understand what I wanted to make you understand in this volumetric strain topic, as well as few concept I have shared with you. So let me review the whole things what I have shared with you till now. So in this topic, most important formula is this one, but this formula is only applicable when there is acting hydrostatic something, hydrostatic pressure, hydrostatic load, that kind of thing. If acting, then we can use this equation, otherwise we cannot use. And one of the most important tip, let me share with you, my dear, if you are writing gate examination, then definitely most of the time they are going to use this term to make it simple and also complicated, because sometimes we did mistake here, we don't remember this one, we just do what 3 sigma by E, that is the mistake. We should not forget this one, and even sometimes we forget this one, and sometimes even we forget the whole term. We only know this change in volume by volume is known as volumetric strain, but we just forgot this term. This one is also useful. So these three things you need to remember for the case of volumetric strain. That's why you will not repeat any kind of mistake in the examination, and hopefully I have covered all things in volumetric strain till now. So let me share with you the same page what I have shared with you. So this is all about volumetric strain, and what I have shared here, this is all about a single axis strain. Well, so I hope you understand all things here what you got, and hope you enjoy the tutorial. Thanks for watching. See you soon in my next video. Bye bye.